Good morning everyone. Welcome to Azure Community Conference. My name is Johnny Hooibergs and I have the honor to talk to you today on Microsoft Q Sharp and Azure Quantum. So again, good morning, very happy to be here. I hope you are too. So let's get right into some Q Sharp. So as I said before, my name is Johnny Hooibergs. I live in Belgium. I work as a software consultant for a company called Involved. I help customers with developing their .NET applications. So I'm not really into quantum computing professionally. So why am I doing this talk? Well, basically, a couple of years ago, I saw a talk on a conference just like this on the topic of quantum computing, and I was so interested in the topic that I decided to learn about it myself. I spent a couple of years to learn, read some books, talk to some people. I became a Microsoft MVP in that time frame, so I could talk to the people from the Microsoft Quantum team. And this is basically how I got into quantum. My goal for today is to teach you about Microsoft Quantum, Azure Quantum, from a developer to you guys and girls developers. So I'm not going to talk to you in pure theory. I will also show you some code, and I will show you some Azure Quantum. So if there's any questions about this, you can always contact me using my Twitter handle or on my GitHub page, or even using my company email address. And everything that I will show you today is already available on my GitHub page. So the link to my GitHub is in the bottom of each of my PowerPoint slides. It contains the slides itself, and it will contain all of the examples for you to learn from. So let's start. So first, why quantum computing? Well, basically, if I go back to when I was younger, when I was a teenager, still attending school, there was a teacher that knew that I was into programming. When I was a teenager, I was already doing some programming in Turbo Pascal, a very old DOS-based programming language. And the teacher came up to me and said, I have something fun for you to solve. I have a problem that is very fun to solve. And the problem that he was talking about was a knight's tour. I was just a teenager. I didn't know about this problem, but he explained it to me. He said, you have a chessboard, and on this chessboard you have a piece which is represented by the horse, which can do specific jumps. So a horse on a chess set can jump 2 positions forward and 1 position sideways, or vice versa. So on the left hand side you can see an image of this horse and the 8 different positions it can jump to. And then the teacher said to me, just start at a random location, and you can see this on the right hand side. Make these jumps over and over and over again until you fill the whole chessboard without coming on a square more than once. So I was like, that's easy. I will write a computer program for that. I will just jump around randomly, and when I get stuck, I will backtrack and I will try a different route. So I wrote the application. I was very happy with the result. I started the application and it ran. It ran for a couple of minutes. No solution. It ran. I got a little bit afraid. I was still young. I tried to look at my code. Maybe I made some mistakes. I tried to run it again, but it kept on running and it never finished. Even one time I ran it completely overnight, and when I woke up in the morning, it was still running. So I thought, I made a mistake. I'm just a teenager. I will go play outside. And basically I abandoned the problem. It was only when I got older that I that I knew that this problem was called the knight's tour, and basically it's too complex to be brute forced by a classical computer, which sounds really weird because a chessboard is only 64 squares. So how hard can it be for a computer to visit all of these 64 squares? Well, the idea behind this is that it's an exponential problem. It's an exponential problem, and there's so many different paths that you can take that a classical computer, when making all the wrong decisions, will take hundreds of years to solve this problem. Of course, when you by accident take most decisions correctly, it will go a lot quicker. But if you're just brute forcing this, it can become very difficult. A couple of months ago, I rewrote the algorithm that solves this problem. And if you take a little bit more correct decisions, there are some rules, if you know them, then it will be solved in a matter of seconds. But then when I was just a teenager, I was making all the wrong decisions, and it was taking too long to solve. So yeah, why quantum computing? Well, basically, today there are still problems, algorithmic problems, that we cannot solve on a classical computer because they are too complex to solve. There's too many variables, there's too many different possibilities to visit all of those possibilities by a classical computer. And this is why we are looking into some other kind of computing. So quantum computing is actually based on quantum mechanics. And in quantum mechanics, there's all different kinds of phenomenon that we actually can use to our advantage to help solve these exponential problems. How can we solve these exponential problems? I will talk about that a little bit later. But first, in quantum mechanics, there are two very important concepts or phenomena that are called superposition and entanglement. And these can really help us when building physical quantum computers. So you can see two images. On the left-hand side, there's an image that is trying to represent what superposition is all about. I draw these images, so they are not lifelike. They are just a representation of what it looks like. So on the left-hand side, superposition, we can see an electron. We know an electron is a very small particle that spins around the nucleus of an atom. So this electron has a property called spin. And that property can be two distinct states. It can be spin up or spin down. And that's what you see in the left-hand side. You can see like a circle or a sphere, and it can spin up or it can spin down. Now, in quantum mechanics, there is something called superposition, which means that that property is not in either of those two states. It's somewhere in between, or it's two states at the same time. We don't really know for sure, but it's both, basically. So that's what you can see after the equal sign. So the spin up and the spin down is both at the same time. This only works for really tiny quantum objects, like the spin of an electron. It doesn't work on a macroscopic scale. So the chair you're sitting on, or the couch you're sitting in, it cannot be in superposition because it's too big. It exists out of very tiny small particles, billions of them, and each individual particle can be in some kind of superposition, but not all of them at the same time. So that's why we are not familiar with this concept, because we cannot see it in real life. Well, basically the only thing I know in real life is a USB key. A USB key is in superposition, because when you want to plug it inside of your computer, it will never fit because the state of the USB slot is in superposition. And here comes the interesting part. Superposition stays while it's not being observed. So only when you observe or when you interact with that state, it will collapse to either one of those distinct states. The same with the USB key. It doesn't fit. You turn it around a couple of times and it never fits. But then when you look at the USB slot, the superposition collapses. It chooses one of its distinct states. You can see the state, and then it will fit. It's the same with these quantum particles. So the spin of an electron, when we measure the spin or when we look at the spin, it will make a decision and it will collapse to spin up or spin down. Very weird stuff. Then on the right-hand side, you see an image that represents entanglement. This is even more weird. When you have two particles, two quantum particles that are both in superposition and entangled, it means when you observe or you measure or you look at one of these two, the other one will collapse immediately in the opposite state. So when you have an electron, you put it in superposition, so it's both spin up and spin down. You entangle it with a second electron, then both of them are in superposition. Now you can just look at one, and the other one will collapse to the opposite state immediately. Now, scientists have done many experiments using these things, and they even built satellites that could fire photons using laser beams to different laboratories on Earth, very far apart. So they would basically, in the satellite, they would split a photon into two half photons. They were entangled. They would send one to China and one to Austria in Europe. And then scientists would observe one of these entangled particles, and the other particle will immediately collapse to the opposite state. So very, very weird. Scientists don't know how this works. Also because it happens instantly. So they measured the time it takes for one particle to collapse and the other particle to collapse. It's instantaneously. There's no time difference. So there cannot be any kind of communication, and that's the reason why they tested it so far apart, to test the time difference, but there is no time difference. So scientists have no idea how this works. And actually, it's not very important that we know how it works. Of course, we are curious, we want to know, but we just don't already know. But it works. We know it works. We did many experiments, many experiments, and it works. So we can use it for something cool. Now, back to the question, why quantum computing? Well, as I told you before, there are multiple problems that are exponential in nature that we are not able to solve on classical computers. So first thing, for example, is security. We built our security based on the concept that classical computers cannot break it because the problem is too difficult to solve. So of course, in the future, when we have big, useful, stable quantum computers, it may be possible to break our current security, so we will need to invent a new one. But the security we use today, like public-private key encryption, we cannot break that using classical computer because it would take thousands of years to calculate the result. The second thing is drug development. So drug development, maybe you know, there are programs out there, at-home kinds of programs that we need to run on all of the computers on the world at the same time to just unlock a very, very tiny part of some solution to a problem that we're searching when developing drugs for different diseases. Why are we running these programs on as many computers as we can? Well, because the problems are too hard to solve by only one computer or even one supercomputer. Basically, when we are developing drugs, we are developing something that needs to interact with all of the particles in our body. And there's so many particles inside of our body, so many cells, so many atoms, billions of atoms, and we cannot simulate that. It's easy when we are working in software development and we are working in construction, for example, and we want to simulate the forces on a bridge. Very easy. There's only a couple of forces. The bridge is quite simple in its concept, so we can simulate this and we can see, will the bridge collapse, yes or no? But when developing something for our body, there's so many variables, it's just not possible to solve. So again, hopefully these kinds of problems can be solved by quantum computers. It's the same for artificial intelligence and machine learning. Basically, what happens in our brains is a reaction to something that we can see, something we can taste, something we can smell. When a bus is going to hit you on the road and you look at the bus, very quickly, your brain will make the decision to jump away. Very quickly, almost instantaneously. For a computer, an artificial intelligence inside of a computer, it's much harder because he needs to process all of the variables before he can make that decision. And here, again with this, sometimes there's so much data that you need a lot of time to process all of this data and all of these variables before you can make a decision. So if you want to have immediate feedback from an artificial intelligence, we also need these exponential power gains. So before I explain how quantum computing can help us solve these problems, this was only the why, not the how, I'm going to have to teach you a little bit of mathematics. It's just a little bit, don't be afraid. It's basically high school math, so it should work. And it's really fun if you know how everything sits together. So first, we start very easy. When we look at a classical computer, we have bits. We know these bits. They can be 0, they can be 1, and we represent them as the numbers 0 and 1. If we want to represent data, we combine all of these bits together. So 1, 0, 0, 1, 1, 0 can be some kind of data. It doesn't really matter. We decide the rules on representing data. It can be an image, it can be a video, it can be audio, it can be a letter from the alphabet. It doesn't really matter. We decide the rules, but this is data. On a quantum computer, we're going to use the same concepts because we're already familiar with bits. So on a quantum computer, we are using quantum bits. If you look back at that quantum superposition, we have that property of an electron that could be spin up or spin down. We just make a decision. Spin up can be 0, spin down can be 1, for example. And now we can represent a binary state in a quantum object. If we want to combine data in quantum, we can do the same thing as we know from classical. So 1, 0, 0, 1, 1, 0 in quantum is the same thing as it is in classical. Maybe you noticed, but the notation is a little bit different. There's like a vertical line, and then there's like a greater than sign, and then in between there's the number 0 or 1. Well, basically it's called the Dirac notation, and this is this very specific notation for quantum computing. This is helpful because when you read this, you immediately know, oh, this is the state of a qubit, and this is the state of a classical bit. So you can immediately see the difference. By the way, it's not a greater than sign, it's a different character, and this is very specific to mathematics, linear algebra, and in this case, quantum computing. Now, things become more interesting when we put the state of a single qubit in superposition, because now we have the 0 and the 1 at the same time, like I explained to you before. It's not really at the same time. It's basically a linear combination of 0 and 1. So if you remember linear algebra from school, this is a linear combination of the 0 and the 1 state. And that linear combination has some values, alpha and beta, to make a division between those two. So it's alpha times the 0 state plus beta times the 1 state. Now, these alpha and beta, they represent some kind of percentage, some kind of probability. And the way to calculate that probability is by using the following formula. It's like alpha squared, or the absolute value of alpha squared, plus the absolute value of beta squared equals 1. So equals 1 means that there's a 100% probability of it being 0 or 1. And then we make the division. So maybe it's 50% 0, 50% 1. To make things more complex, pun intended, alpha and beta can be complex numbers. And that's the reason why we need to take the absolute value before squaring, because alpha and beta can be complex numbers. So a complex number is like an imaginary part and a real part added together. So A plus BI or C plus DI. It's very, very complicated. Basically to represent all of the different kinds of superposition that we can observe from real life, mathematicians needed to use complex numbers to be able to do this. That's the reason. It's not to make our lives more complex, it's just to be able to represent all of the different scenarios that we can physically measure. Excuse me. You don't really have to remember this. Just know that alpha and beta are a probability chance of this superposition collapsing to either 0 or 1. Now, if we take that perfect superposition of 50-50%, we can write that down in a formula: 1 over square root of 2, 0, plus 1 over square root of 2, 1. Because remember the formula: 1 over square root of 2 squared is 1 over 2, half, plus half equals 1. So now we have a 50-50% chance of collapsing. The reason why we need these mathematics is because it becomes harder to calculate from the top of your head. When we're doing classical computing and classical bits, and we have different gates, like the AND gate and the OR gate and the exclusive OR gate, we can do that from the top of our head, because calculating with zeros and ones is very, very easy. But in quantum computing, when we need to put qubits that are in superposition through gates that do operations on these states, yeah, it becomes quite hard, because as you can see, the numbers are more complex than just zeros and one. So that's why we need the mathematics, so that we can do the calculations, basically. That's why I'm explaining to you. A little bit easier would be to represent the quantum state in a three-dimensional world, because this is also what is happening. I told you that the superposition was a linear linear combination of 0 and 1? Well, basically, because those two values are complex numbers, we can represent that as a vector in a three-dimensional sphere. On the left-hand side, you can see the empty sphere with the x, y, and z axes. And on the right-hand side, you can see a vector inside of this sphere. And the state of a qubit can always be represented by a vector that originates in the center of this sphere and points somewhere on the surface of this sphere. When that vector points straight up the z-axis, it represents the 0 state, and when it points straight down the z-axis, it represents the 1 state. If it's somewhere in between, it represents some kind of superposition of these two distinct 0 and 1 state. So on the right-hand side, you can see a vector that is in an arbitrary state, somewhere not on the z-axis, so somewhere in superposition. And now it actually points more towards the up position and towards the down position, which means that the chances, the probability of collapsing to 0 are much higher than collapsing to 1. If that vector would be somewhere on that plane on the x and the y axis, so if that vector points like flat horizontally somewhere on that plane, it would be in perfect superposition because it's halfway in between 0 and 1 state. So it can collapse with a 50-50% probability. If you dumb it down a little bit, so if you take away one of the dimensions and you look at it from a two-dimensional perspective, so if you just remove complex numbers and only use real numbers for alpha and beta, it's a lot easier to comprehend, and then you just need some trigonometry. Basically, on the left-hand side, when that vector points halfway between the 0 and the 1 state on the z-axis, it's in perfect 50-50% superposition. The angle is pi over 2 radians, and you can just calculate the two probabilities by using the sine and the cosine, which are your trigonometry functions. So sine of pi over 2 squared will equal the probability of it collapsing to 0, and cosine of pi over 2 squared will equal the probability of collapsing to 1, or vice versa. I always forget. I need to write that stuff down. On the right-hand side, you can see a different kind of angle. So it points more towards 1. So the angle is 2 pi over 3 radians. And then again, you take sine, you take the cosine, and you get 1 over 2 and square root of 3 over 2, which calculates to a 1 over 4 chance and a 3 over 4 chance of collapsing to 0 or 1. So this is basically what superposition is all like. We just do some mathematics to calculate the probabilities based on where the vector is pointing, and that is really what is happening in the physical world. So we can use that to our advantage. So if you look at that quantum state, that can be two states at the same time, things becoming interesting when we combine multiple qubits together. When we have a system containing 2 qubits, now we have 4 distinct states, because 2 qubits can represent 2 bits. When we have 2 bits, we can represent 4 different states, 0, 0, 0, 1, 1, 0, and 1, 1. And now we have 4 of these probabilities. We have like alpha times 0, 0, beta times 0, 1, delta times 1, 0, and gamma times 1, 1. I'm messing up my Greek numbers here, but don't worry about that. So we have 4 different states. So in a perfect superposition, all of these states have a 25% probability. Now, and this is where the power of quantum computing comes from. When we want to represent the superposition of states, when we add a single qubit to that system, we double the amount of states it can represent. So for a 3-qubit system, we have 8 different states. For a 4-qubit system, we have 16 different states, and it keeps on doubling like this. So the growth of power for our quantum computer is exponentially. It grows exponentially with the amount of qubits that we are using. And this is basically what we hope that can help us with all of our exponential problems. Because when the computer system we designed can harness exponential power, we can hopefully solve exponential problems. Now, I forgot what I wanted to talk about. So when you look at a classical computer and a classical CPU, it exists out of transistors. So when your current CPU inside of your laptop or whatever has 1 billion transistors, when you want to double the amount of power, so to double the amount of power it can represent, you need to double the amount of transistors, which is quite expensive. For a quantum computer, when you have 99 qubits, and you want to double the amount of states that it can represent, you only need to add 1 qubit to that system, which should be a lot more cheap to do and not so expensive. But of course, today we are already building quantum computers, but they are not quite stable yet because we are just searching for the perfect way to harness these physical qubits. Because as I told you, we can represent the superposition state of a qubit by looking at the superposition state of some kind of quantum particle. So different companies are trying different quantum particles to help us represent these states. I know that some companies are using electrons, and then they are using microwave beams to change the state of an electron like this. Other companies are using ions, and they are using laser beams to change the states of these items. And even other companies are experimenting with more crazy particles. I read about a company that's trying to do the same thing with larger crystals instead of just tiny particles to somehow represent this state. So in theory, it works, but the physical machines have yet to be built that are powerful enough. We have very small quantum computers today where we can do like 5 qubits or 10 qubits or even 20 qubits, but that's not enough qubits to really solve our very large world scale problems. We really need to build quantum computers that have 100, 200, 300 qubits to be able to solve this. And today we are not yet there. How does a quantum algorithm or quantum computer code actually looks like? You can really compare this to the classical computing. So classical computing on a hardware level really works by putting booleans through gates. I already talked to you about NOT gates, AND gates, OR gates. We can combine all of these gates to create more advanced logic. And actually, I'm not sure how it worked for you guys, but when I was a young teenager in school, we had a class which was called technological education, and there we had like these boards, like these physical boards that had different kinds of tools. Like it had a button, it had a switch, it had a light, it had a buzzer, and then it had some gates like an AND gate, an OR gate, a NOT gate, and then it had a couple of wires. And we could use these wires to make connections between a button, an AND gate, another button, the AND gate, and then the output of the AND gate could go to a light. And then we could work with these buttons. Press one button, nothing happens. Press two buttons at the same time, and the light would go on. And this would learn us how to think in this Boolean logic. Basically, this is what quantum computing is today. It's a board, it's a circuit. We just put qubits through gates, and we measure the result of these qubits. So this is what we are doing today. Of course, we are building programming languages that are more high level, so that we don't need to write code in the form of putting qubits through gates, so that we can have higher level functions, but this is still the basics. And what you can see here on my PowerPoint slide is the circuit for teleportation. And teleportation is actually something that works in quantum computing and quantum physics altogether. Basically, we have 3 qubits. So on the left-hand side, you can see 3 qubits. I gave them a name just because it's easier to remember. So the first qubit is called the message qubit. The second qubit is called the Alice qubit. And the third qubit is called the Bob qubit. And what we are doing is we are teleporting the state of the message qubit from Alice to Bob. And this is what it looks like. So basically, the message qubit can be in some kind of superposition. That's why I called it X. So X means some kind of probability between 0 and 1. So it's not really important exactly what superposition, it's some kind of superposition. And then Alice and Bob qubits, they are in state 0. So they are not in superposition. So the teleportation circuit is going to try to teleport the message X, so that complex superposition state, on top of Bob's qubit from Alice. And the idea behind this is that basically teleportation works based on entanglement. And for entanglement, the quantum particles don't need to be close together. They can be very far apart. So actually, Alice and Bob, if they are two persons, they can teleport that message value or superposition state from Alice to Bob, even if they're not on the same location. So what actually needs to happen is that Alice and Bob first need to be close together. So they need to be together in the same room. They need to create their qubits and they need to entangle their qubits beforehand. So that's the first thing that happens. So Alice puts her qubit through what we call the Hadamard gate. And the Hadamard gate is a gate that puts a qubit into superposition. So Alice's qubit is 0 to start with. She puts it through the Hadamard gate, putting it in an equal 50-50 superposition. And then she puts her qubit and Bob's qubit together through the C-NOT, or the controlled NOT gate, which means that Bob's qubit will be flipped from 0 to 1 if Alice's qubit is 1, or it will remain the same if Alice's qubit is 0. But Alice's qubit is in superposition, so it's not 0, it's not 1, it's both at the same time. So this C-NOT gate will actually entangle these two qubits together. So the entanglement circuit is a very easy circuit. It's just these two gates combined. First the Hadamard gate and then the controlled NOT gate. And this first part of that circuit entangles Alice and Bob's qubits. So now both of these qubits are entangled, and Bob can travel to another location. So let's say that Alice is in India and Bob is in the United States. So Bob travels from India to the United States with his entangled qubit. Now, Alice, still in India, will have a message qubit. This is in some kind of superposition. So she does the same thing. She puts her qubit in entanglement with the message qubit by putting it through the controlled NOT gate, and then she puts the message qubit through the Hadamard gate. And now the teleportation circuit is almost complete. So Alice has her message qubit and her own qubit, and Bob traveled to the United States with only his entangled qubit. Now Alice needs to first measure her own qubit. So she takes a measurement, which means she looks at the state, which means that the state will collapse to either 0 or 1. So that superposition state is destroyed, and Bob's qubit will automatically collapse in quantum computing to the same state. I told you before, in quantum mechanics, the state will be opposite after collapsing an entanglement. In quantum computing, it's the same state. So Alice measures her qubit, and depending on the result, she picks up the telephone or she sends an email to Bob and she says, my qubit is in state 1, so you need to put your qubit through the X gate, which is another kind of gate. Only if it's 1. If it's 0, Bob doesn't need to do anything. And then Alice measures her message qubit, collapsing that state. So this was in some complex superposition state, but now it's collapsed to 0 or 1. And if it's 1, she calls to Bob and she tells him to put his qubit through the Z gate. So basically, the only thing that Bob needs to do is start with the 0 state, entangle with Alice's qubit, and then put his qubit through the X and the Z gate, depending on the results from Alice. By the way, the X and the Z gate are very easy to comprehend. If you look at the Bloch sphere, it's a 180 degrees rotation around the X or the Z axis. So it's just rotating your vector 180 degrees around that axis. Very easy gates. Now, for some magical reason, now the Bob's qubit is the exact same state as the original message qubit. And the only thing that Bob did was entanglement and putting it through two 180 degrees rotations, which is very powerful. So this is what teleportation is all about. The message qubit, of course, is destroyed because we measured it, so it collapsed to 0 or 1, so the state is lost. And this is basically how teleportation works. Teleportation does not exist in the real world, but there are science fiction movies that try to show us what it could be like the movie The Fly, for example, where a person can be teleported from one booth to another booth. It's the same thing. The original person is destroyed and it appears somewhere else. If you really think about this, when you want to teleport yourself using these science fiction booths, when you appear in the next booth, it's not you. It's like you teleported. It's a new you. The original you is destroyed. So it sounds a little bit scary there. So it's the same with quantum here. And we can really do this on physical quantum computers today, and it works, this teleportation circuit. Just remember that the original state is destroyed. So we cannot copy states, we can only teleport states. Very important concept in quantum computing. You can never copy the state of a qubit. You can only teleport a state to another qubit, and then the original qubit is destroyed. So let's show you some code. And let's also show you this teleportation circuit in code. So Microsoft created a programming language to do quantum, which is called Q#. And you can use that from Visual Studio or Visual Studio Code. So I have here a new Visual Studio Code. I can create a new project, and I'm going to create a new Q# project. Visual Studio Code will ask me what kind of project I want to create. I can create a standalone console application. And the console application is actually a simulated environment. So it's going to be a console application that uses .NET for simulating a real quantum algorithm. So let's see, where shall I put this? Sources, repos, and let's call this Quantum 999. I'm sure that this folder does not yet exist. I'm opening the project. So we are actually running real quantum code, but in a simulated environment on my classical laptop. Because of course I don't have a quantum computer here in my office. So yeah, it's a bit difficult. So I can use Visual Studio Code and .NET to simulate. So this is basically an entry point operation. So this operation will be called, and I can do some quantum stuff here. I can assign a qubit, and I can use qubit factory function to allocate a new qubit to the Q variable by using use. So you can compare use with using in C#. You use something and you dispose of it afterwards. Because a qubit is a very expensive resource, we use it, and then when we don't need that qubit, we can dispose it. So it will automatically be disposed when it goes out of scope using these curly braces, just like we know from C#. Now I can put this qubit through the Hadamard gate to put it in superposition. So I'm just going to call the H function to put it in superposition. And then I can, for example, print a message to the console with the result of that qubit. So basically, I'm going to take a measurement. So I'm going to do a measurement of that qubit. We can also use interpolated strings, just like we know from programming languages like C# here. Now, if I view the terminal, I can run this application on my local classical laptop. My computer is having a very hard time. Not sure why. Let's give it some time. We'll get there. Yes. So because we are simulating this quantum algorithm in .NET, we can just use .NET Run to run our application. And I'll give it some time. Of course, it needs to build a whole simulator now to run this. And the reason that you are quite limited here is because when you use these qubits, each qubit needs to be represented mathematically in the memory of your computer, because we don't have the physical qubits to put in superposition. We need to remember all of that mathematics. So basically the simulator for Q# really has all of this mathematics inside of it. So when you have, like, for example, 10 qubits, you need to put all of those different states in one big linear combination with big real number, with complex numbers inside of your memory. So it takes lots of classical memory. My laptop that I'm using right now has 64 gigabytes of memory, which only allows me to allocate 30 qubits. And then I am out of memory. So yeah, it's very hard to do hundreds of qubits on a classical computer, or it's just not possible to do hundreds of qubits on a classical computer. Yeah, so it's taking a very long time. So while we are waiting for the result here, I'm already going to show you something different. So let's go to that teleportation project. So this is the same Q# kind of project, but I prepared the teleportation for you. There we go. So let's see. So this is an operation. So we can create like methods. So we can split up our application into different methods or operations, it's called. So an operation is a method on a quantum level. We can also do functions. So operation, there's a difference between operations and functions. So operations is very specifically for changing qubit states. So I'm just doing the same thing as you saw before in that graphical layout. So I'm creating 3 qubits. So the message qubit is the one that I want to teleport. And then I have Alice's and Bob's qubits. Dump register is something that we can do from Q# for debugging purposes. This is not something you can do on a physical quantum computer because you cannot debug the state of a qubit that it's in superposition, because when you look at it, when you observe it, it will collapse, and you cannot let it collapse when it's not ready to. So this can only work for a simulated environment. But then the first step was to entangle Alice and Bob's qubits. So I put the Alice qubit through the H gate. I put Alice and Bob's qubit through the controlled NOT gate. Then I entangle Alice and the message. So I put the Q message and Q Alice through the controlled NOT gate, and then the message through the H gate. Then I measure Alice's qubit, and only when Alice's qubit is 1, I will put Bob's qubit through the X gate. And then I measure the message qubit, and only when the message qubit is 1, I will put Bob's qubit through the Z gate. And that's it. Now I've teleported from the message to Bob. And this program actually puts the message qubit in some kind of superposition. So not perfect 50-50, but 2 pi over 3, which is at angle for 25-75%. So this is a complex superposition state. And then I'm teleporting that qubit to Bob. And it works. The dump register actually dumps the mathematical state to a text file. So if I look at message before, you can see that the message before can have 2 distinct states, 0 or 1. And here you can see the probabilities. It has a 25% probability of collapsing to 0 and a 75% probability of collapsing to 1. And this is a graphical representation of that probability. And this is that mathematical alpha and beta. So this is 0.5 plus 0i, and this is 0.866025 plus 0i. And then, of course, if you look at the Bob's qubit before, it's in 100% 0 state, and then after the teleportation circuit, it has the same state, 25-0 and 75-1, which is very, very cool. So that's teleportation. And here you could see a little bit of Q#. You can see that the result is 0. So if I run this application multiple times, it will be a 50-50 of zeros and ones. But of course, I'm only running it once, so it will be either 0 or 1, depending on that probability. So let's go back to the slides. So final part of my presentation will be Azure Quantum. So yeah, Microsoft has their cloud environment Azure, and because quantum computers are so difficult to keep in your living room because they're very expensive, they need like cooling to absolute 0. They need to be completely, there can't be any air inside, so the particles cannot interact with other particles. So it's very hard to keep a quantum computer stable. There's lots of error correction there. So it's cool that Microsoft decided to allow us to use physical quantum computers through Azure Quantum. We can use those for quantum simulation, for optimization problems, for machine learning, and so on and so on. And Microsoft is working on their own quantum computer, but it's not yet finished. So they are working together with different kinds of companies. Microsoft is building what they call a topological quantum computer. I'm actually not sure what that means. I'm honest about that. But there are other companies like IonQ and Honeywell. They are using the ion traps. I talked about that already. Ion traps, which they use laser beams to change the states of those states of those qubits. QCI is another company that is using superconducting qubits, just like IBM is doing, using electrons and microwaves. And Microsoft is giving us access to these physical quantum hardware by these companies, by these partners. The way it works is very similar to .NET. Basically, we have Q# as our programming language. We can simulate that from .NET on our classical computer, but we can also upload it to Azure Quantum, and Azure Quantum will translate that into an intermediate representation. Just like .NET, which compiles from C# to intermediate language, and then that intermediate language is just in time compiled by the runtime on the platform you're running your application on. It's working the same thing with Azure Quantum. So your Q# is compiled down into quantum intermediate representation, or QUR, and then QUR is delivered to these partners like IonQ and Honeywell and QCI, and they will compile at runtime your code, or the QIR code, to real quantum machine code for their specific system. Because of course, these are different companies. They are building quantum computers, and each company has their own little machine language. So we need to compile our higher level language to intermediate representation, so it can be compiled down to, depending on the platform that we are using to run our applications. So let's show you a little bit of this Azure Quantum. So basically in Azure, you can create a resource by finding Azure Quantum. Something is killing my laptop. Very sorry for that. It's already 100 degrees. So Azure Quantum, I can create what we call a workspace in Azure Quantum. So this is a workspace, and it gives you the opportunity to create or to use these physical quantum computers. I need to select a subscription and a resource group, of course. Just pick a random one. I need to provide a name. Select a storage account. And then go to the next step. So we need the storage account to store the input and output data for our quantum algorithms. That's why we need the storage account. Now here, I can add the providers that I want to use. So if I want to work together with Honeywell, I can add Honeywell as a quantum computer. I can add IonQ, or I can add OneQ Cloud. So basically these two, Honeywell and IonQ, are quantum computers. And then OneCloud and Microsoft QIO, quantum-inspired optimization, those are optimization based algorithms. So it's something different, but I don't have time to talk about that. So only the middle two are quantum computers. I'm not going to add it right now. I already prepared a workspace that uses IonQ. And then from Visual Studio Code, you can go ahead and build a quantum application for IonQ. So when you do a new project, Q# new project, you can select a quantum application targeting a Honeywell backend or IonQ backend. This is creating a quantum application specifically for these quantum computers. So I already prepared this one, and if I open the project file, It's very similar to a C# and a .NET project file. We are actually using .NET Core 3.1 to simulate our algorithm, but we are executing on an IonQ QPU. So QPU for quantum processing unit. So we are executing this on a QPU. And because this is here, the compiler will know that we are targeting IonQ, and each hardware vendor has some limitations. So IonQ has some limitations, functions that we or operations that we cannot use because they have not yet implemented it on their physical quantum computer. So the compiler from Q# will tell us. The compiler will tell us you are using this operation, but it's not yet supported by IonQ's QPU. So it put like the red squigglies in the bottom, which is very cool. So that's why we can build these very specific project templates. Now, if I look at the Q# file, this is a very simple project that will entangle two qubits based on that 25-75% superposition. And for me to run this on a physical quantum computer, I can use Azure CLI. So with Azure CLI, I can push my quantum program to Azure Quantum, and Azure Quantum will run it. Again, my PC is very slow, so I'm not sure if I'm able to show it. Let's see what happens. So I have some of these things in memory here. So this, for example, Azure Quantum Target List will target a list of all the different kinds of quantum computers that I have available in my workspace. So I created the new workspace in Azure Quantum. And this will give me a list of everything that is possible. Guess it's not working. Just going to give it one more minute. So while I'm waiting for this, I will talk about where we at today with physical quantum computers. So the physical quantum computers, as I told you before, they only support a low number of qubits because it's just too hard to keep a large number of qubits stable enough for us to really use, unfortunately. So it will take some more time to try and figure out how to make that work. But we are not sure how long. Companies are doing investigations, they are experimenting. We can have real useful quantum computers in 5 years, but maybe it will take 50 years. We're not sure. We really need to see what will happen with that. So I'm not going to wait for this because it's going too slow. So let's go back to my slides. Da-da-da-dun. Yeah, it worked. So now we have all the available quantum computers. But I'm going to wrap up here. So you can look at my examples and you can run it on Azure Quantum yourself. Depending on which quantum computer you're using, it can be cheap or it can be expensive. I'm using IonQ, and IonQ will bill you based on every gate you are using in your quantum algorithm. So it's a very low amount of money that you need to pay for each gate, which, like when you do a simple quantum program like me, it's like €1 or $1 US. So it's very easy. Honeywell is a little bit more expensive because you need to pay each month a fixed fee. So this is a very fun little game that I'm not going to talk about. And I'm just trying to show you the final slide, which has Thank you note. And PowerPoint crashed. Yeah, I'm very, very sorry, but something is wrong with my computer. It's something is running at 100% CPU, and I cannot solve that right now. So with that, I'm at the end of my presentation. I would like to say thank you. I hope you enjoyed it. I hope you had like a fluent image and you can hear my voice fine. And if there's any questions, I will look at the comments. Thank you.
Hey, Johnny, that was a great talk. So, am I audible?
Yes.
Perfect. I appreciate all the attendees. Submit your feedback with the code that you see on the screen. This would help us to qualify you and send you the T-shirts and certification vouchers. And great session from Denny. Looks like people
Thank
enjoyed the
you.
session.
Thank you. Was the image still fluent?
It
And the
is. It
audio?
is.
Okay.
Everything was perfect except the crash that the PPT crashed in the last moment. But I think until the last moment, we were able to see all your code. What you presented,
Okay,
it was
perfect.
great. All right. Thank you so much, Johnny. We have Jose joined. So once again, a quick reminder, please submit the feedback about this content and please stand a chance to win awesome giveaways. Head over to the contest page on the event website, participate in the hackathon as well as the free certification voucher. We have a lot more session coming up for the rest of the day, and I'm sure you would find it very useful. Thanks, Jose.
Bye-bye.
Thanks, Johnny. Take care. Have a great day there.
Hello, everybody. Good morning. Can you hear me and you can see my video and my presentation properly?
Yep, perfect, Jose.
Perfect. Thank you, Elias. First, thanks. I think it's the lead is Ambul for organizing all this and all the team. It's such a fantastic conference. Thank you very much for having me in. All right. So let's start to the Azure Community Conference in the India's largest Azure conference. Honestly, I never seen so many tracks together. It's amazing. So first, thanks to the title and gold sponsors and the community partners, Microsoft and Elastic. Thanks for making this possible. And let's go to today and why should you be listening to me? So who I am, I'm Jose Luis Latorre. I work at Swiss Life. Here is my Twitter handle. It's GOSLAT, which comes from my first and last name, the first three letters. I'm the Usernet Group Zurich organizer, and I have been a 9-year Microsoft MVP. I'm not anymore, just to be clear. I think there was said that I was a Microsoft MVP, and at the moment I am not. Maybe tomorrow, nobody knows. But I'm not at the moment. And I work as software architect and dev community lead at Swiss Life, amazing company in the core of Switzerland. So today I'm going to talk about Azure Machine Learning and machineLearning.net, how you can work with both and integrate the models from them with ONX. In fact, I'm going to do exactly this. I'm going to go through a quick refresher on AI. I'm going to go onto Azure Machine Learning, do an introduction, what is that, what it works for, what you can do with it, to the designer, to AutoML, mostly the model authoring tools that you have inside Azure Machine Learning Studio. And we will take a look, a peek, on how to generate an ONX model with AutoML and, of course, notebooks, because you cannot do that with Designer and AutoML. Probably in the future you will, but not yet. And last but not least, how to consume the exact ONX model that you generated with machineLearning.net. And I will also give you the code and the slides later on. It's on the last slide, so keep your eyes on. And it's on GitHub, in my GitHub, which I shared before. And yeah, let's get started. So first things first, what is AI? AI is intelligence demonstrated by machines, usually software, that mimics cognitive functions from humans, such as learning, problem solving, like for example, playing chess or doing some things a bit more amazing, like driving a car. That's AI. But how do we get there? Usually we do that with machine learning, which is the foundation for AI. It's how do we teach a computer to make a prediction and draw conclusions from data. This is what we're going to see. How can we get that done today with Azure Machine Learning? So what's machine learning? Basically, we feed the data, some flowers with labels, then it processes, creates a model, and then when it sees it, it can detect which flower it is. So it's a training process. We put the data, it processes, generates a model, and then it can do the inference, which is from a flower, say, okay, that's bellies, essentially. And there is a process to this. So first we have to do the training phase. And then we have the prediction phase. This initially starts with the ETL, which stands for extract, transform, and load. So we have to extract the data, we have to process it and transform it so it can be properly understood by the machine, and then load that data to be ready to train the model. We have then to select a model and then train it. Once it is trained, we can select and deploy the model to maybe a web service or put it somewhere in our application, and then we can feed it unknown data, and it can do a prediction, also called inferencing, and give you some results. That's how machine learning works. So generally, what we are looking here is two kinds of machine learning, supervised and unsupervised. Supervised, we have classification and regression. We'll look at them in a moment. And then we have unsupervised, that essentially it's the kind of machine learning that we don't need a human. Scary, right? We have that clustering, getting elements together based on similarity and association, which is kind of similar. On classification and regression, I think this classification is pretty clear. We are classifying crosses and balls and putting them together, and we simply put them in one or other class. That's a binary because we have to class. If we had more, it would be a multi-class classification, and regression simply, we try to predict attendance based on values from the different elements on the data. So we get a new spot and we try to place it in the graph, essentially. So that's it for machine learning. That's everything we need to know to follow along. Azure Machine Learning. The goal of Azure Machine Learning is to bring AI to everybody with an end-to-end trusted platform. We have several features here, but the main goal is to boost your data science. So it's an environment, a complete environment that a machine learning expert or beginner or what we call a data scientist, even citizen data scientist that doesn't know that much about machine learning can get things done there. And that's quite amazing. It's meant to increase your rate of experimentation, main experimentation, that you play with the models to train different models, see how they behave, try to fine-tune them, deploy and manage the models, and then a lot more things. It has automated machine learning. We will see that in a moment. Managed compute, which is in fact very, very, very simple. It has simple deployment and also DevOps for machine learning. It has Super for open source frameworks and enables a tool agnostic Python SDK that we can run in the cloud. So it's quite cool. Essentially, we work with Azure Machine Learning, also called Azure Machine Learning Service, with the UI. The UI, what we interact, is a similar portal to the Azure portal. It's called Azure Machine Learning Studio, and it has a combine of Azure Cloud Services with the Python SDK that enables us to prepare the data, build the models, train them, manage, track experiments, and have full traceability of everything we do. So we can backtrack in time and see, okay, how did we create this model? What happened to do this? It's no longer we are blindsided because we did that in our computer. You have traceability of absolutely everything, and that's pretty cool. So let's take a look at how do we get Azure Machine Learning and overview of the studio. Okay, here I have Microsoft Azure, the portal, in portal.azure.com. And if you want to create it, this environment, you can create a resource. You put learning. What we're going to create is a Azure Machine Learning workspace. The workspace word is no longer anymore, but all the documentation refers to it. Then you click on Create. You can select one resource group and put I created the Azure conference, the tag name for this conference. It would create it in whatever region I want. It would create for us as well a storage account, a key vault, application insights, and a container registry if we wanted. We could put one. And then configure a few more things and click Review and Create, but I have it already created. Yes, that's perfectly fine. I'm going to resource group. And in this one, I have everything that was to be created, the container registry, insights, key vault, storage account. I have this machine learning workspace. And here I can click and launch the studio, which I had it already open just in case. So let me close that. Here, let's do a guided tour. We can manage data, train the models. evaluate the models, and deploy them. We have authoring creation for creating models in notebooks, automated ML, and also the designer. And we have some assets like that data sets, experiments, which are executions. We have pipelines that we can create with the designer, also with notebooks, and some endpoints that when we deploy, we can integrate with other services. And we can manage, for example, different compute, which is where we will execute and train the models or inference them. Environments, data stores, data labeling, external services. It's pretty cool. I stopped this because the rest is not that useful. And let's do one thing. So I had this stop. This is a compute instance that I can create for executing executing an inference, and I can create several elements or even select from all options and see what's the limit of my subscription. Yeah, it's not bad. I could get up to 8 cores or 16 cores here with 128 of RAM. This is CPU, I could even go for more. So the sky's the limit, right? 128 cores. So you probably don't have that at home. And maybe you'd like to do that and use that if you have a proper training you'd like to do in very short time. This is already starting. I can do the same with a computer cluster. So let's create one meanwhile, because we will sort of use it. I will create dedicated CPU, select from recommended options. Yeah, this one is perfect. I will put here, yeah, 2 is okay. And we can click on create, and this will go on. So then we have what we call the machine learning designer, which is one of the creation tools. This is a drag and drop interface to create pipelines for training models, inferencing, and data processing. But the thing is, of course, to look at it and maybe to use it. So here we have the option to create a new pipeline. We can create a blank one or create one existing. We have quite a few. This is quite cool. I really love this tool. This comes from the old Azure Machine Learning Studio, which is called now the Classic. That's still works, but it's going to be deprecated in 2024. I was really in love with that environment. I play a lot with it. And at the bottom, you have the pipeline drafts, which are similarly states of the pipelines that you have saved or when you did the concrete state, and the runs of them, which are the executions. You normally name the experiments, and I think it's quite funny that they changed the naming recently. Before it was a GUID, and now it's selecting funny names. I'm using PAM, Place the Sponge. Yeah, this is done from Microsoft, and I think it's kind of nice to have some humor. So let's build something. The designer is a drag and drop that you need to attach to a compute instance. We could also select a cluster, but oops. Configuration, yes. Compute instance, it's already started, which is good. Can close this one. And here we are going to add a data set. So we are going to build one right now. Here we could click here and preview the data. And you can see the different states of the data, the distribution of the values. I think it's quite nice. So let's leave it here. The next thing is I want to select some columns in the data set. I'm doing the extract, transform, and data. So I go to data transformation. Select columns in data set. Yeah. And I can connect the dots, which is essentially how I build a pipeline. In this case, I would select all the columns and add one more, not to include, but to exclude. And here, I want to go and take this out of the equation. Then I like to clean missing data in case there are some columns or values that are not filled. If you don't find it, you can also go there, search. The search works quite fast. And here I could see columns to be cleaned, and could say I want all columns to be clean. Yes, let's go for everything. And the clean mode, I would remove the entire row. Yes, that's it. If something is not okay in that row, I simply take it off. And then for what I want in the data, I want to split it for the training. So I will use part of the data for training and part for validation of the train model. I can drop this. Here I can see a random seed. I can put something, and here it's doing 50%, 50%. I like something different, like 70% and 30%. That should be all. So this should be a bit like all the extract, transform, and load, and I can go to train the model. So I go to model training, train model, and I will need the model. I will take the most simple one, which is linear regression, and also fit for it. And here we have an alert. That means it's not configured, and we need to select the label. The label is what do we want to predict. In this case, it's the price. So we will predict the price there. That's it. We are almost ready to score and evaluate the model. Once we get it down, where was it? Yeah, model scoring. We'll delete that one. Evaluate model, score model. I don't need more boxes, so I can collapse the thing. And here I will score the model with the data that this model has not ever seen, the 30% of the data. Now I could click on submit and execute it, but that because I already did that. Should be No, that was not it. Yes, this one. Whoops. No, this definitely was not. Sorry for that. Okay, need to go back there. 26. Come on. It was just here, I think. I think it was this. Yes, sorry for that. So here we can see that the status is complete. We can go to the model train on the score and they evaluate the model. And once we click here, we can see the coefficient of determination, which is as much as close to 1 is that it is really, really precise. And then we have here the errors, which the best is as close as 0 as they are. This one is good, this one is not that good, and 80%. We could do a lot better. But get the idea how this designer works. I think it's pretty cool because when you're executing, it goes top down and you can see it gets green. You see very visually the workflow, and you can see the columns detected, what the data is selected here. You can preview, you can see that out of the 205, you have 135 here, and here you have some other data. That's pretty cool. So the part is done. We have built something. And now we will go to automated machine learning. Machine learning is essentially using machine learning to program, to create a model, which is pretty cool. It does everything that you saw for us. It does ETL, the model selection, parameter tuning, and everything done for you, a lot more. It does feature selection, feature engineering. It implements a concept of data guardrails that you can see where the data has exceeded the margin, and it can modify in a bad way your model, so you maybe should clean it. It selects the best model for you, doing a scoring for them. It does hyperparameter tuning on the model selected. And also it can explain the model, how it works, and give you some insights, like, for example, which features of it are important. Also supports different tasks like classification, regression, and time series, which is cool. Essentially, it's a data scientist in a box. So it's a machine learning model trained to be and behave like a data scientist. To me, it's the dream of an aficionado data scientist, and even it can, for a data scientist, it can do a pretty big amount of work. So it's pretty cool. It does the feature selection, selects the model and scores it, and then says, oh, which one is the best? Oh, this one, right? Then selects a model, does some hyperparameter tuning, and brings it to the next level, and then you get your model. So it's pretty cool. What you get, what you have to prepare is the data sets, the target metric, and give it some constraints like time and cost. And then it does a lot of work for you. It can take a while, so it can take 1 hour, half an hour, but it also depends on what you put there as the hardware that you put in the cloud executing. Also remind that you should power it down or delete it after it, otherwise it will have a cost. And yeah, let's let the machine do the work. So you will go to the automated ML through here, and here you have a recent automated machine learning run, some documentation. It's very simple, but also very powerful. And you go, let's go here, and you go and select new automated ML run. Here, we could input and create a new data set from local files at the store, web files. From local files, it's almost like a CSV import in Excel, so it's fairly easy. I have one already created, which is bank marketing train. This one, we will try to implement a model to predict the prices. No, not the prices, sorry. It's a classification to detect if a customer will sign the contract or not with the bank. Okay, so I will put the experiment A. I will put a new one. I will select the target column. In this case is yes, which is yes or no. And I could select a cluster. And as it's already created, I could click on next and then select the settings. I could go to classification. I could pick another one, but it's clearly classifications because we select, and also select some additional configuration settings, AMC weighted, exclude some algorithms, put the exit criteria. So I could tell it, okay, after 6 hours, you stop and you pick the best model. Or I could put, okay, just 1 hour. Or I could put a score threshold that once you reach like 90%, it's good enough. You could put a validation and how many concurrent iterations. If we have a cluster, yeah, you can select that. And you could also pick featureization settings. and put some manually. And then finish, and the run would start. But I have one already executed. Our marketing, display name, experiment. So let's go to the experiment. This is what you see once it has run. Here you see the runs, the main one, but you can see what else did he execute behind the scenes. And you can see that he did a lot of work. Different runs with different models and trying out different things. So to select the best model, to fine-tune the hyper parameters of that selected model. Let's take that out. Let's go into it. This one, we can see at the right best model summary, which is the voting ensemble, and the score, which is quite higher than the previous one. It's like almost 95% of score. It's pretty cool. And yeah, it took like 39 minutes to generate this model. And also, we can see that it stopped, not because it ran out of time, but because it had no improvements over the last 20 iterations. So it could not get this model better in any way. So it stopped by itself. It does not overuse your resources. It's pretty cool. Otherwise, we have here the models, where we can see the different models. And if you want to generate the explanation for the model, you can click here, explain model. And of course, this needs a computer or a compute cluster to execute, and it would take like 5 or 10 minutes. So we will not do that. I already done that for you. And you can view, for example, the explanation here. And here we can see, yeah, not right now, the different elements of it. So how the model is scoring the features to give them more importance. And this is the importance, and how do they affect to a customer signing the contract or not. I think this information is super valuable. So the duration that the person stays inside the bank is really key. Other one, if the person is employed or not, and then the variability rate, the Euribor, and we could even look at that a bit more. So this index, this other index, and then, yeah, as well, the age a bit, teeny bit. So then you have also, you can look at the outputs where you have the logs and the model that you can download, but this is a PKL, you cannot download it. So in fact, a goal that we had when I was inferencing, this is technically Azure Machine Learning is supporting ONX, but at the moment, the only way to generate ONX is with a notebook experience. But you have seen how to generate a model now with the designer and just reason with AutoML. And let's go to ONX. First of all, what is ONX? I have been mentioning that for a bit. It's Open Neural Network Exchange. It's an open source project. I think it's orchestrated, created by Microsoft and other companies. And the goal is to enable a format that can be shared between different machines. But let's build the ONX with Python notebooks. So ONX is meant a bit to be the format to exchange it with different platforms, the cloud, and any kind of computer and operating software like Mac, Linux, Windows, you name it, even IoT. As time is of the essence, I will open this Python notebook. And this is the only way. So this is a Python notebook that trains a machine learning with a machine learning model. Using AutoML. So the first part is, let me make it bigger. These we don't need. I'm going to put it a bit more visual so you can see it properly. So the first part is the cleaning of the data, so importing pandas and some other libraries. Here I'm getting the data is New York TLC Green, which is an open dataset package, so directly from the cloud. And here I'm doing a filter from 2015, from the first month of 2015. I'm getting only 2,000 there. I'm showing here the head, which are the first 10. And then I simply want to build some features so the machine can understand it. So I'm taking the month, the day, the weekday, and putting that in a variable. So it is easier for the machine learning algorithm to compute and understand this data, which is, for us, normal. It's easy, but for a computer, it's harder. So we split it. And then we add it to the features and we show it. So we have now at the end some more data like month number, day of month, etc. And then we remove some columns that we think they are not essential, and we simplify the data bit. So we end up with the vendor, which is who provides the data, which passengers went on the taxi, the distance on the taxi, where it was picked up on the longitude and latitude, and when it was dropped, and the total amount that this costed. This is the cost that at the end we want to predict. We do a bit of a description of the data, and then we do another filter. So here we want to filter by New York. So this is the place, and we do a bit of a longitude and latitude filter. And then we want to eliminate some strange things like having a passenger of 0 and a cost of 0, which really does not apply to what we want. And when this is done, we set up the workspace, which is needed. Workspace is like similar to Azure Machine Learning workspace that we have, so we can use and connect to it. And then we use here sklearn to use that and to use AutoML inside of Python. In fact, what I'm showing you is a common exercise tutorial with a bit of a twist for generating the ONX model that we will take a look at the moment. Here is similar that we did in the UI. So we have a timeout. We have a timeout in hours. Before it was 6, but I put here 0.3, 30 minutes. And then to enable early stopping, which is what we saw. Once the AutoML determines it cannot improve, it will stop by itself. The metric that we will check if it's a good solution or not, and auto featurization, which is the same that we had configured before. Some cross validations, and then here we have the configuration and some additional auto machine learning configuration. And here the main difference is to enable ONX compatible models. That's it, because some models are not compatible with ONX yet. So we need to add this here. That will ensure that it will create an ONX model. Then we do the training as an experiment. Here is the code, what we evaluated, and the results. And we can export the results and show the run details. It's similar to what we are doing in the UI, but we can print the model here and put some data of the model, and some tests of the accuracy. But what really matters to us is to export the model. So this starts when the experiment finishes. So to retrieve the best ONX model, I'm doing this line of code. I'm getting the local run, I'm getting the output, and I'm telling it to return the ONX model. And then to save it. This code I'm showing you, I'm putting it in a Git repository that I will share the link just at the end. Here, I'm doing that. I want to import the ONX converter. This is a library that enables us to generate or convert a model into ONX. And then we use it to save the model as ONX. Once we execute that, that's already executed, we'll get this file. Well, we cannot really read. It's a binary with some text on it, but you get it. What we do is, what we have to do there is to download it, and then we can use it in Azure in ML.NET, right in our desktop. So we have built this ONX tool, and now we are going to see how to use it from machineLearning.net. As mentioned, you have to remember that you have to add support onto AutoML configuration to enable ONX compatible models equals true. And once the model is built, you have to export it as ONX. It will not do that by itself. You have to retrieve the model, telling it return ONX model equals true, and then, of course, convert it and save it. So it's a bit of cumbersome, but still it's just 4 lines of code and 1 line of configuration. You have to give it the name or the name of the ONX file, and then tell it to save it. Nothing more. MachineLearning.net. Now we go to the other side of the wall. We are on the cloud, and now we are in the laptop or in your computer. Either it's a Mac, Linux, or Windows, like I have. So here, MachineLearning.net is a component. It's a cross-platform machine learning framework that you can use in Visual Studio Code and Visual Studio. It's more fit for Visual Studio because it's natively developed for it. So you have what is called Model Designer. But I think the best is that we take a look to it. First, there is a tool that I like to show you. It's called Neutron. Here, what I did is I opened this best model ONX. This best model is this exact same that we had. And if you remember, we had those inputs, the day of month, week, day, month number, passage in code. And I think it's quite amazing that what we have here, the vendor ID, we have here. I mean, with this, you can clearly understand a model, what is it doing, right? And we have the inputs, vendor ID, passage in code, trip distance, don't forget this one, and the outputs, which are variable one. And here, you cannot see it, I think. So my recommendation is that you play with it, you download it. The tool is called Neutron. It's also, the code is available on GitHub. It's a tool from Lutz Rader. So thanks, Lutz, for this one. And here you can see the type, the name, exact name, and here the different types. Here is a float, here is an int. And with that, what you have to do is to create an application. And the first thing is, this is a .NET standard application. In fact, you can use .NET 5 or .NET 6 separately, it will work. And I put here the model. And I put here copies, that's okay. And I put first, for example, I put the output. And on the output, you can see the name is exactly the same as here. Variable one and float. And the same for the input. So I put with column name to map it to machine learning, ML.NET, and I do some conversion here that's necessary for converting the types. And I put exactly the same variables that I need. Then what I have to do is essentially use machineLearning.net like a standard model. I put a reference to the ONX model. Of course, I start with a hello world, what else? And Then we create a machine learning context so we can work, and we get the prediction pipeline. This is right here below. And here I define the input columns already exactly the same as they are: vendor ID, passenger count, etc. And the output columns, an array of strings, nothing more, and create the pipeline. And then I have to do a transform to apply the ONNX model with the output, the input, and the path to the model. For that, I'm using the ML transforms ONNX, which I had to load as dependencies first. You can see here I have the ONNX transformer. Also, I have the ONNX runtime, but that's also included here on the next transformer. And this is the one that we used before in the cloud with the same name. So kind of you can relate. Then I simply train it or load empty data for it, do the feed. So we create it, and we have already the pipeline for doing an inference or prediction ready. Once this is done, I can start the prediction. So I get the engine, I create the prediction engine with the input and output. I create then an input of whatever day of week, 1 or day 7, for example, day of month, trip distance, prediction, ONX, and call it simply to predict. If I execute that and bring that here, we got a predicted fare of 45.8. So that's how you use ONNX model in machine learning.net in your own desktop, one that you have generated in the cloud. I think that's pretty powerful because this you can deploy anywhere in your applications and have a means to download dynamically ONNX or create a pipeline and have it retrain. I think it's pretty cool. And if you can do that, you can train at the scale and use these in, for example, a container without any reference, and ensuring a bit of security of the data if you work in highly regulated environments like I do. So that's a bit the scenario and the use for it. Apart from, okay, how cool is that? You generate a model using like a super duper computer or GPU in the cloud, and then you can run it essentially anywhere, and it's quite fast. So that's we use ONNX in machine learning.net. On here, on all the different slides, I put a bit of a guidance on the Microsoft documentation that is the closest to this. So I recommend you to follow it. It's pretty cool. And as we are reaching a conclusion, I'd like to leave you with some takeaways, some points to reminder. Apart from that, the code is on my GitHub, github.com/hoslet/onx with ml.net. I'll show you in a moment. So I put this here. The slides I show are also here. The notebook is here as well. And here is the machine learning.net. And here is some guidance. So my recommendation, if you want to try this at home or in your cloud, in your tenant, of course, you can follow this walkthrough and then do these modifications I propose. I would recommend you try to do that because otherwise you will not learn. And this is fairly easy to follow. Also, if you don't succeed, you can take a look to the notebook. But I would recommend you try to do both because it's pretty cool. It's really satisfactory when you get it working and it simply works. So as points is Azure Machine Learning. It rocks. These Microsoft folks did really good work. I could congratulate, I believe, Cesar de la Torre is behind this fantastic platform. Also, Seth Juarez is behind it, and it's really cool. Designer is really cool. I love it since the Azure Machine Learning Studio back in 2015, 2016. and AutoML is definitely amazing. You have as well AutoML in machine learning.net, but it's limited at the moment in classification and regression, and also limited in the models that it can use. Still, there is no ONX in Azure Machine Learning without code at the designer or AutoML, but it will come. And also we can get the ONX models with notebooks, which is at the moment the only way. And of course, AutoML, which is what we did. We can run it in machineLearning.net. And of course, we could go the other way. We could generate in machineLearning.net. So we have all the ONX tools for that and deploy it into Azure Machine Learning. But I don't think this would make too much sense, or maybe yes. And the best, as I said, is you try it yourself. It's the only way to learn, because if you don't practice what you have learned, you will forget. Again, I like to thank the learning partners, Pact, developers of the head, and the security partner, Faitian. Thank you very much for making this possible, and to all the amazing communities that are helping on this. Not going to mention them all, but Women Tech, TechMeet, Chennai, Pug, like the name, dear Azure. So thank you very much. Now, if anybody has any question, I would be very open to it.
So, Jose, thank you so much for the talk. I think it was a wonderful technology, ML.net, and I hope the audience really enjoyed your content. I don't see much questions so far, but I'm pushing this feedback form as well as the unique code to qualify for the giveaways. I appreciate all the attendees who joined live or later. Make use of this feedback form with the code to get your t-shirts and other interesting giveaways. If you have any questions, I suggest that you be in touch with Jose later, or even now. If you have questions, please post your questions on this window on the chat wherever you're watching, be it Facebook or LinkedIn or Twitter. Put your questions and Jose would be happy to answer them.
Sure. Thank you so much. I have a question. How do I get a t-shirt from this fantastic event?
Yeah, so it's definitely simple for the India audience, of course. So what they have to do is fill in the form and share their feedback about the overall conference or your specific session by going to this link and use the code that's shared there. And each one of the audience who filled the form would receive a unique t-shirt claim voucher, and they can go to, in addition to that, we will send the URL from where they can claim it, so they could do that. And of course, for you, Jose, we are sending an exclusive one.
Oh, that's fantastic. Thank you so much. Thanks for having me in. It was a pleasure.
Thank you so much for being with us, and I think the audience definitely enjoyed your content. And thanks for the GitHub repo as well. People can go there, and try their hands on with whatever you have thought so far. That was fantastic.
Everything you need is there. Have fun.
That's right. And I really enjoyed your background. I think you have worked on that well.
It was easy.
That was fantastic.
Thank you so much. Have a great day, everybody. See you next time.
Jose. Yeah. Take care then. Have a great day there. Bye-bye.
Bye.
Well, good morning, everybody, or evening or afternoon. It's early morning for me. It's like 2 degrees Celsius, so it's really, really cold outside. But I'm glad to be here, and I will be talking about maybe hidden features in the Azure storage. My name is Jiří Chinchura. I'm a Microsoft MVP for the development technologies. So I will be showing you most of the features that you can use from your code or use that as part of your application. If you'd like to follow me, you can find me on Twitter. The handle is on the screen, or if you want, you can also go check my blog on tabsoverspaces.com. So without any further introductions and so on, I will move into my next slide. So what we will be talking about, I will do some basic features first. Probably you will most of them know, but it will be a great kind of recap of what we have there. Then I will check some performance features, and then I will jump into something that I call features, meaning really something that you can use and it's something extra beyond what you will find in the basic, like how to get started with the Azure storage. I will be showing most of these things in the code, but obviously you can use that from any type of environment you want. So let's start with what type of storage account you can have. There's a few options regarding redundancy in the storage accounts. And basically these options give you extra peace of mind in terms something bad happens, like, I don't know, Godzilla eats a data center. So the least reliable option is called locally redundant storage. This option gives you 3 synchronous copies in one data center. So one region, one data center, and you have 3 synchronous copies. This option gives you 11 nines in terms of durability. So normally when we are talking about SLAs, we might be saying, hey, this service has 99.95 or 99.99. And usually if it's just nines, like 99.9, 99.99, and so on, we just say, hey, it's 3 nines or it's 4 nines. In this case, for local redundant storage, it's 11 nines. So it's quite a number close to 100%, but not yet. The next option is called zone redundant storage. And it means that you have 3 copies in one region, in one data center, but in 3 availability zones. And the availability zones in Azure means that this part of the data center, this part of the region, is completely independent. So if you have 3 different availability zones, that means you have 3 different copies in completely independent parts of the data center, meaning it has an independent cooling, power, internet connection, and so on and so on. So if something really, really bad happens, let's say like a fire in the data center, the part of the data center might go down, but you will still have at least 2 extra options in other parts of the data center or other parts of the region that are completely independent, so they can operate without any disruption. This option gives you 12 nines, so 1 9 extra compared to local redundant storage. Then we go into the geo-redundant storage. This one gives you 3 synchronous copies in one data center and 3 asynchronous copies in the second data center. And the second data center behaves like a locally redundant storage. So what this basically gives you is peace of mind in terms a full data center, full region goes down for whatever reason, because you still have the backup in the second data center. This option gives you 16 nines. So that's a lot of nines, but it has one major, let's say, problem. The second data center is just for you, for peace of mind. You cannot use it for read access or something like that. So if you would like to maybe load balance the load a little bit, or if the data center goes down, you would like to switch your application into the read-only mode, but stay up. This is not an option. Microsoft would need to say, okay, the original data center is so down that we are switching the second data center as a primary node, so the storage account will start working. It never happened so far, so the second copy is just for peace of mind. If you'd like to be able to access the data in a read-only fashion, no matter what, during the downtime or even during the normal operation, you can always opt in for something that's called read access geo-redundant storage. It is the same features, same nines, everything, but the second data center or the second replica is available for you. And the last option is called geo-zone redundant storage, which is basically a combination of zone redundant storage and geo-redundant storage, meaning you have 3 synchronous copies in the primary data center, and these 3 copies are spread across 3 availability zones, same as the zone redundant storage. But also, you have 3 asynchronous copies in the second data center. That's again a locally redundant storage. Again, this gives you a 16 nines, same as the previous one. But the primary data center has the extra option with these availability zones. Again, as with the geo-redundant storage, you can opt in for the read access options. So for read access geo-zone redundant storage, well, that's a lot of options. You will get an access into the second data center if you want to or if you need to. So carefully selecting these options obviously affects the pricing, how much you pay for a gigabyte, and it's great to evaluate what your application actually needs, because you might say, okay, well, I always want to have the geo-redundant storage because, well, then the data is replicated into the second region, so if something bad happens, I have the secondary replica. But one needs to think carefully that even in the locally redundant storage, you still have 3 copies, but only in the one region. And well, then you need to think what's gonna happen if the region goes down for whatever reason. As I said, like Godzilla came and started eating the data center or something. Is this really a case you want to cover? Because most of the time, unless you have an application that's ready to be run in a high availability scenario or high availability setup, then okay, well, if the data center goes down, then your application is down anyway. So what's the point of having, for example, read access geo-redundant storage? Because, well, you can access the data and everything, but there is no application running. So always think what's actually needed for you and what data you are storing. If you are storing some like normal, I don't know, like pictures and tweets and Instagram stuff and Facebook stuff, you probably don't need the geo-redundant storage. But if you are storing like invoices and bank statements and so on, you probably want to go into geo-redundant storage because, well, you know, stuff happens and better safe than sorry. But still, local redundant storage, very capable option for a lot of applications because 11 nines, you still have 3 synchronous copies, so like hardware failure and so on, it's fine. And even if the data center goes down, it's usually that the data center does not go down in a way that it's losing data. It goes down mostly because some major outage in the region or flooding or a configuration mishap or something like that. It's not like it's losing data. All right, then we can choose from different access tiers. And again, this affects the performance and what you pay for accessing the data. And we have 3 options: hot, cool, and archive. That means that for hot, you are not paying anything for accessing the data. You can read and write the data, and that's just fine. That's the normal option. But sometimes you are storing data that you are accessing less often. Might be older data, might be even data that it's not really accessed that often, that the user uploads something and that's it. Maybe it's cached because you can use the Azure storage with content delivery network, so it's not even accessed that often because it's often cached on these edge nodes with the CDN and so on and so on. So in the cool, you are basically storing data that you are still accessing, but you are not accessing them often, and it gives you the option to pay less for storage, but you are paying more, or actually it's not free, for reading and writing the data. Then we have the archive storage. That's basically offline storage. You cannot access it online. You pay less for the storage, even compared to cool, but you pay a lot more for reading and writing the data. Actually, reading the data only, writing is free. But the biggest problem with the archive is that it takes, let's say, hours to so-called hydrate the file. So whenever you want to access something from the archive storage, and again, the archive storage is very, very cheap, absolutely awesome pricing per gigabyte. But if you want to read some file, it takes usually a couple of hours to kind of show up, because what you do, you send a request like, hey, I want to read this file. And the storage says, well, okay, well, just check in a couple of minutes or a couple of hours, because it's going to take me a while to fetch it from some underlying storage. And it might take a couple of hours. And once it's hydrated, you can access it just fine, just the normal way as you would access like the hot file or hot blob file in the storage. What you can actually do, and it's a nice trick if you are thinking about the archive storage and you are kind of worried about, hey, what if something happens, I'm using it for backups or something like that, and I need to kind of quickly get back in business because something happens and we need to take the backup and we need to restore the backup. There is something called priority or high priority retrieval that basically lowers the time from hours to like tens of minutes. So basically under an hour, you will be having the backup and you can start restoring the backup and hopefully be up and running. But also worth mentioning that the cool and archive have something that's called early deletion fee, meaning that you need to have the data in the cool or in the archive at least X amount of time. So for archive, for example, it's 180 days, meaning that if you delete something from the archive sooner than 180 days, you will pay a fee. That basically means the same time as if it would be in the hot storage. So it's good to not only think about, hey, how often I'm accessing the data and how much I want to pay for it and so on, but also whether you are deleting the data or not. Because sometimes it might be more expensive to delete the data, or put differently, it might be easier to leave the data there, especially for the archive storage, and delete this data, let's say once every 5 years or something like that, because, well, then you are safe to delete the data, and given the price for the gigabyte, it's really, really cheap. And finally, we have two performance tiers. The performance tiers is divided into standard and premium as usual. The standard gives you time to first byte in milliseconds. It's available in all regions and has all features just fine. That's probably what you are using, but you can also use the premium one. The premium one gives you the single digit millisecond for the access times. So it's really good if you are accessing the data often and you need to access them a lot, and every millisecond counts. But it's available only for locally and zone redundant storage, basically meaning, hey, it's only in the one data center, one region, and it's only available for blob storage. The second option, there's a feature that's basically turned on by default. You don't have to do anything about it. Just use a specific size blocks. It's called high throughput blob. Whoa. So if you are using blobs, and you use blocks that are bigger than 256 kilobytes or 4 megabytes on standard, when you are using the put block or put blob APIs, you can get something that's called high throughput. And this high throughput is quite an extraordinary if you have the capacity to use it. So for example, one D32 version 3 machine was able to copy in one stream 100 gigabytes in 1.7 gigabytes per second. Not gigabits, but gigabytes. Using the 4 machines in D64 version 3 configuration and using 50,000 32 megabyte blocks, the throughput was 12.5 gigabytes per second. Again, 12.5, 12.5 gigabytes every single second. Obviously, in these modes, you are mostly limited by the throughput you have from the storage you are reading from, like your disk or something like that, a database or something, and the network throughput. That's the reason why, for example, for the 12.5 gigabytes per second, 4 machines were used, because then you are basically multiplying your network throughput. And finally, I was talking about the block blobs. We have 3 types of blocks, 3 types of blobs. We have a block, page, and append blob. The append blob is pretty easy. As the name suggests, it's optimized for concurrent writers. So writers can actually start adding content to the end of the file without any extra locking or something like that. It behaves the same way as the block blob. The only difference is that the maximum size of the block is 4 megabytes. The block blob is comprised of arbitrary sized blocks where the maximum size is 100 megabytes. You can have up to 50,000 of these blocks, which gives you the maximum size of the blob, and greatly improves in parallel upload and download scenarios, because each of the blocks can be uploaded and downloaded in parallel. So if you need to upload, I don't know, like 100 megabytes, you can split them into 100 1 megabyte blocks and upload them in parallel and use all the available bandwidth that you have in your server or in your application. And finally, we have the page blobs that are optimized for random read and writes. Maximum size is 8 terabytes, but I think the size is actually increasing every so often, so you don't have to like remember the numbers, because next week or next month it might be different. And the page blob is a blob that's comprised from 512 byte pages, similar to what we have on the disk, like a virtual machine disk or something like that. So it's always rounded up to 512 of these of this size. So if you have something smaller, you either need to save the original size, or you need to kind of like deal with the right padded zeros. So without any further talking, let's jump into the code. So I have a bunch of extra pieces here that I can take and show you. So let me start the application. That's not what I wanted. That's what I wanted. So the first one is a performance in general. There's a few options you can do to tweak the performance, also depending whether you are running .NET Framework, .NET Core, .NET 5, .NET 6, and so on. But 2 easiest options is to disable the Nagel algorithm. You can do it with the service point manager. You can do it in a config. You can do it like 5 different ways. I'm here using the code because then I can easily show it. So disable the Nagel algorithm, and also disable something that's called expect 100 continue, where the HTTP is expecting the 100 response with the continue to continue doing some stuff. Especially if you are doing quite a heavy usage of the storage account, this might give you extra couple of % of the performance. Again, especially with small operations that you are using. So next demo that I have is called async copy or asynchronous copying. What the storage account allows you to do is basically copy a blob from a different blob asynchronously on the server side. So if you have a huge files in one storage account, you can copy these huge files without these files going first to your machine and then later going again into the blob storage. Because, for example, copying, I don't know, like 100 gigabytes and first downloading and then uploading would be really, really wasteful. The asynchronous copy basically starts the copy, and then you can query what's the status. You can copy from basically any storage account. It does not have to be the same storage account. It can be a different storage account, different subscription, something like that. The copy does not care. The only requirement is that the blob is accessible. So if it's the same storage account, that's fine. Any blob is accessible from the same storage account. If you are copying from a different storage account, either the blob needs to be public or the blob needs to have a shared access signature. So what I'm doing here is basically creating a new blob, say, hey, give me the copy.blob, and then I'm calling the start copy from URI. And I already have in my blob storage account a blob that's called 1gb.bin, that's 1 gigabyte of the file. And what I'm doing is basically say, hey, start the copy, and then I'm fetching the properties. And if the copy status is pending, I'm basically still looping. I'm asking, hey, is it done? Is it done? Is it done? Once it's done, I check the status again and say, hey, is it okay? Did it succeed? If not, I say, hey, copy failed. If not, I will just say done, and we are done. As you can imagine, even on very fast networks, copying 1 gigabyte would be quite some time. But if I start here in my console app, the copy, which you will see that the cursor jumps onto the next line, it's gonna take just a few moments, less than a second or something, because everything happened on the server side. So if you want to migrate from, let's say, one region to another because it's cheaper, faster, or you need to create a copy of these files or something, it's just fine. You can use it as kind of like a manual backup. So you will just, hey, create a new storage account, copy it into it, or even create a new container, copy the files into it, and you just start these operations. Especially with like command line applications like AZ copy, you can just start these copies and check the result afterwards, like what failed, what succeeded, and so on and so on. So the next one I have is called blob lease. And we can talk and we can say, hey, this is like a distributed logging, because the blob storage being a service that's basically available for every part of the world and every part of the Azure data centers, given that you can actually create a file and put a lock on it, you basically have a distributed logging mechanism. And you can use this one to synchronize some applications together or coordinate some work on some files in the application. So what I'm doing here is creating, again, something that I call lease.blob. I delete it if it already exists, in case I would run the demo multiple times. I have here a simple helper method called upload text. So I actually create some file and upload a content into it. It's a simple extension method that basically says, hey, write some text into a stream, then put the stream at the beginning, and then upload from that stream. Simple as that. After that, I will just call get blob lease client. One thing I have to mention here is that there are multiple SDKs available now for the Azure storage in the .NET world, but everything I'm showing here is pure API stuff. So if you are using Java, it's fine, it should be available. If you are using pure API and you're just calling HTTP endpoints, it's fine, it will be available. It will be available for you. It's nothing specific for the .NET. But I'm also using here the latest version of the SDK, the version 12. So if you are using, for example, version 11, which is the latest version of the previous generation, the API names will be slightly different. But again, if you just look up something that contains, let's say, a lease or something, you will find it. So in my case, with the latest API, I'm calling get blob lease client, and on this client, I'm calling acquire lease, and I'm leasing the blob to myself for 30 seconds. Meaning that every operation that that's going to happen on this blob for next 30 seconds needs to have a lease ID in the request itself. So here on the blob lease, I have I'm missing await here. That does not really matter much. So await, I will do blob lease, and I have a value, and I have here the lease ID, which is a normal string, nothing specific. And each and every operation that's going to happen needs to have this lease ID. If not, it's going to fail. So that's what I'm doing here. I'm deleting the file. I'm actually trying to delete the file, but I didn't provide the lease ID. So it's going to end up in the catch block and say it worked. Then I'm going to release the lease, or I could wait 30 seconds, does not really matter, and anybody can do extra operations. To provide the lease, you just use these options to provide it. So options, is it options? Probably it is options. Well, blob request conditions. So it's not options, it's conditions, and I can specify the lease ID here. Then it would succeed. So if I run my code, so it will create a lease and try to delete the file without it. Let's say it's another application, something like that. And it says it worked. So apparently the deleting the blob failed, and everything jumped into the catch block, and it worked as expected. Another feature that I'm showing here is called shared access signatures, or SAS in short. And I've already mentioned the SAS before in terms of the asynchronous copying, in terms if you want to copy from a different storage account with a private blob, you need to kind of like make the blob available for the reading. And well, you can also enable it for public. That's probably not safe. One option is called shared access signatures. What it is? Well, it's basically an extra query string parameter that's cryptographically signed, that gives the holder of the shared access signature a permission on the blob for a certain period of time. So what I'm doing here is actually saying, hey, give me the blob, upload something into it. I'm also setting the content type to text plain, so we can actually access it later. And then I will just write the URI. If I would try to access this URI, it would fail, because, well, it's a private blob. I didn't say, hey, it's public. But what I can do is call generate SAS URI. And I say, hey, the permission is read, so I can read the blob, but you can actually use a bunch of other options, like you can write into the blob, you can delete the blob, and so on and so on. So if you want somebody to upload you a blob and only this one blob, nothing else, not delete anything else, not read anything else, you can just say, hey, you have the permission to only create the blob and nothing else. So I say, hey, the permission is read, and it's valid for next 20 seconds. So if I take this signature, and in next 20 seconds, I will try to create a request. It will succeed. If I do it later, it will just give me a failure. So let's run this one, and I will copy this into my browser. And if I run it, it just shows me the Hello Azure storage, because I have this signature in my URL. The most important part being this basically signs all the parameters that are before it. So it says, hey, the storage permission SP is read, the resource is blob, storage resource is blob, and some extra options about expiration and version and so on and so on. If you change any of these values, then the signature is invalid, so you cannot change it just nilly-willy. because then the signature is invalid. And even if it expires like now, and I do the request again, it gives me a failure saying, hey, the expired time was 7004 GMT, but now is 7031 GMT. So I am a couple of seconds late. And even if I would change it like, hey, it's valid for 1 day, and I run it again, it says, hey, this signature did not match. So somebody either changed the signature or somebody changed the query string, which is actually what I did. The validation of the signature happens only at the beginning of the request. So if you have like 10 gigabyte blob and you are worried, hey, the user might be downloading this file for a couple of minutes or a couple of hours, what's going to happen? That's fine. The signature is validated only at the beginning. So you don't have to worry about it and say, hey, it's valid only for like a 1 minute or something. And the user can just click and start downloading, and that's it. So that's fine. One thing to remember is that the SaaS signature cannot be revoked. So once I send the SaaS link or the SaaS signature to somebody, I cannot revoke it. So the validity period should be pretty short. As I said, like a couple of seconds, maybe a couple of minutes, maybe a couple of hours, depending on what type of data you are handling. But once it's out, you cannot revoke it. The only way to revoke it is to regenerate your key 1 or key 2 in the portal, but that not only invalidates the SaaS signatures, but also invalidates the connection strings or the keys themselves as well. So other applications using these keys will be affected as well. So always think like, how is the SaaS signature being distributed and who is handling it? For like browser-based applications, probably a couple of seconds is fine. Desktop applications that are mostly online, something, same stuff, probably a couple of seconds, maybe a minute. If we are dealing with like uploads from a mobile app and something like that, maybe a couple of hours, so the user does not have to get an extra signature for each and every upload, but maybe isolate these uploads on the container level. So in case something happens in only one user or subset of users is affected, it's better than only a subset of users affected than if all users' uploads will be suddenly accessible, or if somebody is able to upload like terabytes of data into your storage. So the next one is really a trick, and quite often than not, in the blob storage account, you will end up with like thousands and thousands and millions of files, because most of the time the files are there generated not by users but by applications. And it might be pretty difficult to be able to list all these blobs for whatever reason, because if you start listing these blobs, it takes a lot of requests back and forth to get all the files. So if you have like 5 million blobs and you need to list them all for whatever reason, or maybe just a subset, but still from 5 million blobs, you just want like 1 million, that's a lot of round trips back and forth. But what you can do is actually list by a prefix. So if you know that you have some common prefix that's like only a subset of like letters, which quite often it is, if you are using like numbers and letters and you are using only US ASCII, then you have like 26. If we consider only lowercase or uppercase, I think 26 letters that you need to consider. And what you can do is do these listings in parallel. So what I'm actually doing here, I have a simple list method that's doing the listing for me. So it's calling the get blobs async with the prefix that I provided. So if I would need all the blobs in my blob storage, what I could do is call list with an A, list with an B, and so on, maybe for the full alphabet. And I'm running these asynchronously, and I'm just waiting for all of them to finish. So basically, I'm like trying to interleave as much operations as possible, because the listing takes a little bit of time, and there's also a lot of round trips. So kind of like have something happening in between these round trips. There's always a limit. Like if you have lowercase, uppercase letters, that would be like 52 letters plus numbers, that's plus 10. That's like 62 like parallel operations running, depending on the speed of your network and capabilities of your application. It might actually have a downside effect, but you can always do the listing in like, I don't know, like 3, 5, maybe 10 operations in parallel, not 62. So in this case, we are not going to see anything special, because if I do the parallel listing here on my machine, well, you don't know how long it would take in terms of like sequential listing, and my blob storage that I'm using here is mostly empty. So yeah, there is not much we will see, but again, I will run it and it finishes. That's fine. So the next one is from the same story or from the same group, and it's called parallel upload. As I mentioned, if you have a blob, you can have up to 50,000 of these blocks. And each of these blocks can be uploaded or even downloaded in parallel. In fact, in upload, you can have up to 100,000 blocks like in the flight. So maybe 2 applications are uploading the same file, but the second one will eventually overwrite the first one or something like that. So up to 100,000 in flight, 50,000 as a one file. And although you can do the upload completely manually, where you will split your file or your stream or your data in chunks and you start uploading them and so on and so on, it will be really, really painful to do this one, because why would you have a parallel upload if your SDK didn't give you some extra helpful options to do it directly through the SDK? And in fact, if you are using the .NET SDK or Java SDK, you can do this stuff pretty easily. So what I'm doing here is say, hey, I have a 20 megabyte file that I want to upload. And I'm calling upload async. In my case, it's just zeros. I'm not putting any content into it, but that's fine, 20 megabytes of zeros. And in my blob upload options, what I'm doing is I'm specifying something that's called transfer options. And these transfer options give me 3 options to basically configure how the parallel upload is going to happen. So first, I'm setting what's my maximum concurrency. So I'm saying, hey, the maximum number of like threads that are uploading, or maximum number of like network streams that are going to be used is 12. Again, that's something that you need to like test, or maybe have some reasonable default, because it doesn't make sense to have, I don't know, like 500 network streams to be uploaded, because, well, your network is probably not going to be able to handle it. So we are going from 1 that's like purely sequential into parallel, but as you probably know, the parallelism has an inherent limits depending what we are talking about. If it's an IO, like a network, then probably the network is the limit. So I'm saying 12, that's still probably an overkill, maybe 4, maybe 6, maybe 8, depending on how good your network is and how limiting is the network hardware in the full network. So I'm saying 12, a little bit of overkill, but why not? And I'm saying, hey, the initial transfer size, the first upload is actually going to be 1 megabyte. So what the library is actually going to do is, hey, fetch the first megabyte and upload it. And if this is the full file, then fine, we are done with uploading. But if we are not done with uploading, continue starting another 11 uploads with the next megabytes. So I'm saying, hey, upload 20 megabyte file in 1 megabyte chunks, 12 at a time. So it will do 12 uploads of 12 megabytes, then the 8 will be left. So the 8 will be uploaded again in parallel, and then we are done. What I can also specify is maximum transfer size, meaning what is the full maximum size that we will try to transfer, just in case you want to limit that as well. you don't know how fast my network is. Well, I don't know how my network is at the moment because I'm also uploading my screen and my voice and my face. So it's hard to guess. But still, uploading 20 megabytes is going to take few seconds at least. But if I start it, again, you will see that the cursor jumps into the next line. It's not going to take that long. So it's still uploading, and it's done. That's like 20 megabytes uploaded, mostly because my network is able to handle more or less this amount of traffic. But especially if you are having application directly in the Azure and you are on the fast network, you are in the data center, then having this one can make a huge difference. Because, well, you will be hitting the storage account with more uploads. So for files of like couple of megabytes, gigabytes, and so on, it will make it faster. I'm showing here this on the upload, but you can do the same on the download as well if you would like to. And the parallel upload or download has also another benefit, and that's that the blobs will be spread across partitions. So if you are uploading not only a single blob, but multiple blobs, when the user is uploading like 5 files, you can also upload these separate blobs in parallel, and you will be spreading it across the partitions. Because how the blob storage, let's say, internally happens is that there's a huge distributed file system on background. On top of that file system is a bunch of servers that are handling the incoming and the incoming HTTP requests. And if you're uploading into the multiple blobs, usually you will hit multiple of these like front-end nodes. And these front-end nodes have a limited capacity for the uploads, downloads, and so on and so on. So if you're uploading multiple blobs in parallel, even though each and every blob is uploaded sequentially, if you are still with me, so I have 5 blobs that I want to upload. And what I can do is take first blob and upload it in parallel, the same way I'm doing here in the code. Then take the other blob and again upload it in parallel. And then the third blob and again upload it in parallel. Exactly the same as I'm doing here. Or what I can do is start uploading all 5 sequentially. So it will be one blob uploaded in like one network stream, but also the other blob in one network stream. With this, I have the benefit of hitting multiple partitions in the blob storage, multiple like front-end nodes. So I'm not talking to one server with all my uploads, which means I can overload that node, but I'm talking to different nodes that will be pretty difficult to overload these ones. So also think about like, hey, if I'm uploading like one file, okay, well then I will parallelize it. But if I'm uploading 5 files, it might be easier to, instead of parallelizing the upload itself, to parallelize the full set of files that you're uploading. So the next one is optimistic concurrency. So what I have here is a simple code that basically uploads a file. And when you do anything with the blob storage, you will have by default on the server side some so-called E tag that you probably know from HTTP protocol given to you, handled by the server. So I upload a text and I will get back a response. And in the response, I have a property called E tag. That basically, it's like a version of the blob. And I can use this E tag to do the optimistic concurrency. What it means to have an optimistic concurrency, it basically means that I will send a request with a condition. So I'm sending the request anyway. There's no locking or anything like that. So I will send the request, and the server will validate the E tag depending on what I want to happen with the E tag. I will get back to that in a second. And if it's fine, the operation will succeed, like the upload or download or delete or something will succeed. If not, it will just give me an error and say, hey, your E tag does not match the condition you want, so something is probably not right. And usually this is used for handling concurrency. So let's say you fetch a blob and application is doing something with the blob, like user is updating the content, and then you want to save it. But you want to make sure that when you are saving it, you are saving it into a file that was originally fetched, meaning that no other application, no other user in the meantime updated it. Because if that would happen, then the first user was probably already updating the old file. So what you can do is the same stuff as I'm doing. I will upload my text, I will get the info, in the info I have the e tag, and then I will try to delete it. And normally I would do if match. So I would say, hey, delete the file only if the current e tag on the server is the same that I got when I uploaded the file. But because I'm the only one here working, I flipped the condition and I said if none matched, meaning if the current e tag does not matches the one I have in here, then delete it. That's obviously going to fail because I'm the only one working there and I have the correct e tag. So it's going to fail with the request failed exception, with the error code saying, hey, the condition was not met. The error code is a string, so you can hard code the string, but there is also an enum or a class called blob error code where you will find all the error codes available for the API. So there's a list of all the different strings that will be given to you as an error, so you can actually recognize like what's wrong. So in my case, I'm looking for condition not met. And if that's the case, I will say, well, maybe next time, don't delete it now, and I can do like task delay, try again, something like that, maybe in a loop if something is failing or not. So if I run it, we will see that it says maybe next time. That's pretty easy because, well, as I said, the condition is not going to be matched. Another small but nice feature is a root container. As you probably know, if you create a blob storage and you want to upload something into it, you need to put it into the container. So either from application or from the portal, you create a container with some name and some kind of access. If you create it, you can then go into the container and start uploading again in the portal or very likely in the application. But there's one special name of the container that's called $root, and this special named container gives you the option to access these blobs without the container name. So for example, if I go back into my portal, into the container that I'm using for these demos, I, for example, here have the 1 GB file that I was actually copying, and here's actually the copy. So if I select this file, and if I check the URL and paste it into the browser, we will see that the name is called azconf blob core Windows net. That makes sense. Then it's the container name, and then it's the file name. But if I don't want to specify the container, I want this to be like top level stuff for like niceness reasons, I can create the root container the way I'm doing. So I will create a root container, give it access for the blobs. I can upload some file, and then I will create a URL. So basically I'm saying, hey, it's an account name, blob core Windows net. We can hard code it one, and just the blob name without the $root. I can still use the $root. It's still going to work, but it works without it. So the URL is like the name of the storage account plus the file, no extra container, nothing like that. So if you don't want to have this one, especially if you are using like CDN or something, and you don't want to have extra level there, you can. So let me run the demo, and it will give me this information. So if I copy paste this one, go into the browser and paste it here, it's fine. There's nothing in the container name. I could put the $root into the name, and it would be the same because the $root is the name of the container, but I can use it without it. So especially if you are using this as a storage for like CSS files, images or something, and you don't want to have extra something because it's only one there, you can use the $root and have like, oh, okay, I have a storage account and there's just one container where I'm putting everything. Awesome. So let's jump into some small pieces. The first one is metadata. One thing that you can use with your blob is some extra metadata. This metadata is basically a dictionary of string and string, like key, value, and you can use it for whatever you want. It's up to 8 kilobytes of data that you can store there, and you can use it for extra metadata, extra information that you want to have, except like the file name, because the file name is the name of the blob. So sometimes you can use it for like storing, hey, who is the owner of the file, or who is going to be charged for the file, when the file was created, last modified, and I don't know, like some extra checksums, or I don't know, like access counter, whatever you want. So you can do that one. So let me run the metadata demo. So that basically calls a method called set metadata async, and I'm providing a dictionary itself to set the metadata. If I go into the blob storage, refresh this one, so there's a metadata blob. If I access it, here in the bottom, I will see, hey, there's a bunch of metadata, and one is called user, and the value is my name, actually. So the other application can pick it up and use it for something. It's just the metadata, like an extra information that you have there. As I said, for example, when it was created, when it was modified, although these times are already tracked by the storage account, but maybe you want to have it from the application point of view, not from the server point of view, or something like that. Similar story is then for the tags. So let me continue with this one. It's similar to the metadata. It's again a dictionary with some like key value, but in this case it's a tag, and then you can use some filtering and some extra operations based on the tag. So you can use it to, again, kind of like slice and dice your data. So I already uploaded the file. So if I refresh again and check the tag.blob, now I have the blob index tags option, and I have these two, tag1, tag2 with T and X as a value. And I could use this one for some extra filtering in the future or something like that. So not only you can do listing by like containers and folders and blob names and so on, you can also use these tags. Then we have a next, that's snapshots. These snapshots work the same way as you probably know from like VMware, Hyper-V, and so on and so on. Basically meaning, hey, I can take a snapshot of the file. That's kind of a lightweight operation, because unless I modify it, the snapshot is just an information. Hey, there is a snapshot, nothing is modified. But once I modify it, then I have like two versions of the file, and I can work with it. One thing that's good to study and read probably multiple times is this link. The code will be available for you, so you can just click on it to understand how actually the snapshots affect the billing. So I recommend reading that. So what my demo is actually doing is, hey, it's creating a new blob called snapshot.blob. It's uploading some text into it, and then it's creating a snapshot. I will get the snapshot identifier and when it was last modified, which will be right now. Then I will download the text. Again, that's my help method here that basically downloads a content and just puts it into a string. So I will write what's in the file. And what we would expect is there is a test. And yes, there will be a test. Then I will upload again into the same blob a new text called test2. So I'll modify it. And again, download it. That's fine, I'm downloading it. And again, I would expect to see test2, and that's what's going to happen. But what I will do then is give me a blob for a given snapshot. So I can have multiple snapshots for a blob, and I can get like access to this snapshot using this with snapshot and the snapshot identifier that I have in here. And what I will do is combine the copy that I had before. So I will basically say, hey, copy the stuff from left to right. So copy the original snapshot over to a new file, and I will download the text from the original file again. And I would like to see the test being shown there, not the test2 that I updated. So let's run it, and we will see that it works as expected. So it says, hey, test, test2, and again test. So it's like a lightweight backup or something like that. And finally, I have a option for a batching, especially if you're doing a lot of operations, then the batching is a great way to do it. And I closed my application, which was not the smartest idea, but anyway. So if you install an extra package called Azure Storage Blobs Batch, you can use it for batching some operations together, batching in terms of the API calls. So I will create 100 blobs, and the batching then works for setting the access tiers or deleting the blobs. So I will delete all these blobs in one request. So I will just send one request to the API and it will be deleted in one go. So I don't have to do like 100 requests to delete one file after each other. There's a bunch of limitations that I wrote in here, and you can find them in the documentation. Like, for example, there's only 156 sub requests in the batch. So you cannot delete like 10,000 files in one go. You need to split it into 256. And the last feature that I want to show you is something that's called hot and cold potato routing endpoints. So I will jump into the portal, close this one, and there is a networking section. And by default, when you are creating a storage account, you can select your routing preference, either Microsoft or internet routing. This is something sometimes also called hot and cold potato routing. The Microsoft network routing basically means that the request from your application, like when you are at home, enters the Microsoft network as soon as possible in the closest like POP endpoint of Microsoft. The other option is internet routing. It basically means that the request is going across like public internet lines and enters the Microsoft network as late as possible, like as close to the original data center as possible. And you can choose which one you want. But what you can also do is publish so-called specific endpoints. So if I say this one, if I save this one, it will give me the option to access one or the other depending on what I want. So I don't have to choose upfront when creating an account, but when I publish these endpoints, I will be able somewhere here see these endpoints and use them in the application. So let me do this, endpoints, and now I have the Microsoft network routing, which is this one, and then I have the internet routing, which is this one. So I can actually select inside the application which one I want to use in terms my application is to switch one or the other. So with that, that's my last demo that I have in here to fit into the 60 minutes. I'm checking the chat and I don't see any questions or anything like that. So thank you for your attention. I hope you learned something. You maybe have some tricks that you can use in your application. If you will have any questions, just send them in a chat. I will be there for a brief moment, or send them on Twitter or send me an email or something like that. And enjoy the rest of the conference. Bye.
Hey, Judy, thank you so much for joining us. Looks like there's not much of questions, but I would like to quickly appreciate people to give feedback for the session from Judy, and please also use the code that is shared on the window for qualifying for the giveaways. Okay, there's some feedback from people. That's appreciated. And thanks once again, Yuri. Have a great day there.
Okay.
Bye.
Thanks.
Thank
Bye.
you. Bye.
Well, nice soothing music. Hello, and it's great to be at the Azure Community Conference 2021. There's a huge amount of content, and this is a 3-day conference, so we're just getting started. I think shall I continue? Okay. So, as always, these events depend on the support of sponsors. And so we really appreciate their help in making these things possible. So today I'm going to talk about AI and the changing world of work. And this is a very boring slide and there's no real time. We've only got about a little bit under an hour to talk about this. So there isn't really time to talk much about me. But if you really want to know, then you can check out my bio on the conference website. So a little bit under an hour. What we're going to talk about is, not necessarily in this order, I wanted to talk about some of the differences between different areas of technology. They sometimes sort of get mushed together into one thing, but from the perspective of somebody who's not necessarily a specialist in artificial intelligence, but who wants to be able to use the technology as part of their daily work or deliver it as part of a daily solution. And we'll finish off at the end with some conclusions, which will be a little bit scary. So don't be too alarmed when we might see the Terminator appear towards the end of the talk, as with a lot of these topics. So artificial intelligence is the study of intelligent agents that perceive their environment and take actions based on that information to achieve a goal. Now, that's the academic definition of artificial intelligence, and it's pretty broad, and it's changed over the years as the technology has evolved into something like something like an automatic door that might have seemed like intelligence 50 years ago. Well, nowadays people aren't quite so easily impressed. And so what people mean by artificial intelligence today is machines that can do things that we used to think of as requiring human intelligence to achieve. And so that's generally the field of AI or artificial intelligence. As I say, it's very broad. Now, machine learning is one of many techniques in AI, and it's an increasingly important part. So even traditional statistical methods are being improved by using machine learning to automate the process of model selection and hyperparameter tuning, and in some cases using those ML models themselves. And then deep learning is an important technique within machine learning technology, which uses deep neural networks. We'll explain what this means in a minute, but it's deep in the sense that it's many layers in the neural networks, and we'll discuss that in a minute. So we can't really see exactly how it's working because it's too complex, and that's one of the criticisms of deep learning is we've really got to the point where we're not sure exactly how it's working, and there are solutions to that and techniques to overcome that problem, but it is an issue. So we build a model and then we train it with lots of data, and the deep learning model learns from the data. In fact, I don't really need to use air quotes for the word learn, because it really is learning in a very similar way to how we learn as humans. It's a kind of intelligence, but of course it's artificial. So data science, how far can we go? Is it really human intelligence? Data scientists use scientific methods, processes, algorithms, and a lot of statistics to extract knowledge and insights from structured and unstructured data. And typically this is, just statistics, in the sense that in a lot of applications, that's really all that's needed. There are three main types of algorithm that are used. There are others as well, but the first one is regression, which can really be seen as something as simple as fitting a straight line or a polynomial that fits some data in order to make predictions. You might have done something similar at school, but of course that's just in 2 dimensions. It's pretty conceptually simple, but in real applications it's multidimensional multidimensional. There might be hundreds of dimensions, and huge, millions of data points. It gets quite complicated, but the idea behind it's very simple. Then there's classification and clustering. So classification is where we have known data that we can label and try to find rules that can predict which class a new piece of data falls into. That is what machine learning or AI academics call supervised learning. We might also want to teach a model to identify something. So we might be looking for faults or trying to find marketing prospects based on some data that we've collected. But in clustering, we're actually letting the algorithm itself figure out the groupings for us. So it's looking for patterns and connections between the data. And these clustering algorithms are generally referred to as unsupervised learning. So these are really the main techniques. And of course, there are libraries that have been built to do this kind of thing. So data scientists don't have to build these algorithms themselves. They'll use toolkits like PyTorch and TensorFlow, and we'll look at Jupyter notebooks. So in Azure, there are many tools for supporting this kind of work, such as Azure ML Workbench, and we can also when we're dealing with real problems, then it is, a lot of it is statistics on steroids, but we can throw a lot of computer power at these problems. And fundamentally, it's it's not quite as magical and arcane as you might have thought. The skill of the data scientist is really in designing and running those experiments. That's what they're called. When we take some data, we look at it, we try and figure out what the structure of it is and what models might work, and then try things and try and tune these different hyperparameters, tweak the model, choose the model. And a lot of it's skill and experience, but a lot of it is also repetitive work. So you might think, well, if it's repetitive, maybe you can use artificial intelligence on the artificial intelligence, as it were, sort of meta machine learning. And yes, you can do that. So there's a tool called AutoML in Azure, which does precisely that. It uses machine learning to automate the process of machine learning and applying these models. So loads of tools in Azure for doing machine learning and at this level. And a typical tool a data scientist uses is a notebook. Typically, they use the Python language and use Jupyter notebooks. It's just a way of combining computing instructions with documentation. And it's the same technique that's used in a number of other fields where you might have seen it, like mathematics and engineering, using these notebooks. But it's just a convenient way of managing that and annotating it. Azure ML also includes some sort of drag and drop tools as well that make it a lot easier if you're not particularly a data scientist and you just want to work with these models without using, say, the Python language directly. And but it's whichever approach you use, it's just a case of finding the right model and tuning the parameters and possibly automating that using AutoML. So that's data science. And even with these, I mean, there are some models do use deep learning as well, but generally, even the simple statistical models, given enough complexity in the problem, you can't really see how it works. So these models appear to have intelligence. Not all problems are amenable, though, to this kind of statistical approach. So some things like computer vision, natural language processing, speech to text, these need a slightly different approach, which is deep learning. And by the way, just for clarity, I've got a picture of Alan Turing here. We're not quite at the point where we can pass the Turing test, which is fool somebody into thinking that they're talking to a human being. This is all weak AI in the sense that we're solving particular specific bounded problems in a fairly narrow domain. There's another topic, which is strong AI, which is machine learning that really understands what it's doing. which is a very different thing. And we'll come back to this rather philosophical topic towards the end of the talk. So AI is not new. I mean, we talk about it a lot now. People are getting very excited about it, but it's been the next big thing for about half a century, maybe longer, maybe about 60 years. It's also a field that's suffered a number of pretty spectacular failures over the years, and there've been a succession of disillusionments. There was the initial work on AI was in the 1950s. We'll look at that in a second because it's kind of interesting. And there were very inflated expectations of what it can do. And I remember there being a very large AI. Well, there was a large AI program in the UK, and then in academia, and then there was a big debate on it. And I remember seeing on television a debate where Professor Sir James Lighthill poured cold water on the whole idea. And I think that might have put me off becoming a computer scientist, and so I became a chemical engineer instead. But there were some fundamental problems with the initial research into artificial intelligence, which was really based on looking at natural intelligence and using that as a model. So in this is a technique that neuroscientists can use to study how brains work, not necessarily human brains, but they can study neurons and their interactions by making them dye different colors, which is a really interesting technique because on very simple brains you can see the wiring between the different neurons. The big colored dots are the neurons, and the axons that you can connect them can actually be traced, and so you can see the wiring and how they work in a very, very simple brain, not in a complex brain like a human brain. Of course, they're too complicated, but it's an interesting technique. Now that the fundamentals of how neurons work have been known for a long time, and so that's which is a slide I wanted to show here. That was what AI researchers did in the 1950s when they wanted to build an AI model. Is they built this machine called a perceptron, which was based on neurons in biological neurons. This is the model that they copied. This machine here is actually electromechanical. So if I can bring this pointer in here, all this wiring here is connecting these photocells, which is an array. You can't quite see it all here, but there's an array of 20 by 20 photocells, and they're putting numbers in front of there, or projecting numbers onto it, and they're trying to identify the different numbers. So it's a fairly simple, very narrow problem that they're trying to solve. And this here is actually a bank of motorized potentiometers. So it's kind of electromechanical, but essentially what they're doing is adjusting the weights for the different photocells to get the desired result. So let's look at how this is what the principle it's built on is a single layer neural network. So if we look at how that works, this is the inputs from all the photocells, and they're then summed, and then once you've summed all the inputs, we then pass them through some weightings that adjust the weightings for each of the inputs, and then the sum is then passed through what's called an activation function. This one's a fairly simple one. It's a way of mimicking the way that neurons trigger at a certain level of input. They'll trigger or fire, and then you get an output, and it indicates. There'll be several of these outputs indicating whether is it the number 1, 2, 3, 4, and so on. So it's a very simple idea, but it was surprisingly effective for very, very simple problems. once you tried to apply this to more complex situations, and it was mathematically proven that this would never work in anything but the most trivial cases. And this is why there was this sudden decline in interest in artificial intelligence research. But of course, the weighting factors are adjusted automatically, and this is the training algorithm. The backpropagation of the error function is what adjusts the weighting parameters until you get the desired result, and it's able to recognize things. So this is the principle behind the perceptron, or the single layer neural network. And this resulted in what AI researchers call the first AI winter in the sort of 1970s, as people realized that this wasn't really going to be, it wasn't possible to solve real problems with this. It was just a great, a bit like software products that are great to demo, but they're not so good when you apply them. This was the classic case of that. It looked like a great demonstration, but you couldn't apply it to real problems because it was just too simplistic. So in the 1980s, artificial intelligence had a resurgence of interest. And I do remember this because I was involved in trying to apply it to certain types of problems in chemical engineering. And it's not machine learning. It's actually more about getting experts, these expert systems, to come up with sets of rules. So if you wanted to do a sort of a doctor's diagnosis of an illness, for example, you say, okay, what would the doctor ask? What questions would you ask, and make a sort of decision tree out of this? And it would be a little bit more complicated, but essentially it was writing code in a sense, except it was there were applications that could kind of do that automatically and bring the input and build these decision trees. So the problem with the original AI research was, once you get to more complex problems, there's a sort of an explosion of complexity, and it becomes impossible. And funnily enough, the same thing happened really with expert systems. It was just there's this combinatorial explosion when you try to solve real problems this way. I think also a factor was that there aren't too many experts that want to go through the very tedious process of trying to codify their knowledge, really, just to put themselves out of a job. So it didn't really fail. So again, there was another failure, and all interest in artificial intelligence was lost. And researchers call this the second AI winter. So not one, but two winters of despair in funding. All the funding dried up, and here we are again in the 2020s. Well, really over the last decade, there's been a resurgence of interest in artificial intelligence. And the interesting thing is, we've kind of gone back now to what they did in the 1950s with machine learning and neural networks. This is really what's powered resurgence of interest in artificial intelligence. And you might well think, will this fail again? Will there be another third AI winter? I don't think so. I think this time it's for real. And the reason why it's possible is because instead of having a single layer neural network as we did before, we now have these multi-layer neural networks where we've got hidden layers, not one hidden layer, probably 50 plus hidden layers. And that relieves the problem of being able to handle complexity. And so instead of having a single set of outputs, this is now a layer that then produces a further set of outputs, and you can add as many layers as you need. And the skill really is in designing these. So there are many ways of combining layers and propagating information forward through these neural networks. And in some cases, the information can flow backwards as well through them. So they can be quite sophisticated. And the skill is the design of these neural networks. But fundamentally, it's the same principle that was being used in the 1950s. But in a much more sophisticated way and using a lot more computing power. So we can do things like, for example, this is just one example, which is doing computer vision. And in that case, we use these convolutional neural networks. So a convolution is a process that you'd use to go through an image and when it's applied to image processing anyway, and go to each group of cells and work out the relationships between the adjacent cells. And that's the same technique or the same mathematical algorithm that you use in something like Photoshop when you sharpen an image or add a blur to it, for example. These are all convolution networks. And so what these convolutional neural networks for image processing do is they slice up the image into sections. The segments tend to get smaller and smaller, and they get joined together and reprocessed. And it's a very complex neural network, which might have, in the 150 plus layers that have all kinds of feedback loops and operations on them. It takes a lot of research. It's a multi-year research project to build up one of these models. Microsoft produced one of the first ones that was successful in meeting some of these challenges for, given a certain number of, say, 1,000 image types and some sample images to start with, come up with a computer vision model that can recognize things, recognize common objects. But this is how they work. They're very complex. You can do a similar sort of thing for different areas like text processing, for example. Obviously, it's not quite as easy to see how it works because it's all linear, whereas with the computer vision is an easy thing to see how it works, but it's the same principles applied, but in a slightly different way, using slightly different algorithms, and the same with speech to text, for example, where it's processing audio information. Again, slightly different techniques, but in principle, it's the same idea. So what changed? Why is this possible now when it wasn't possible in the 1950s? Well, we have about 10 orders of magnitude more powerful computers to play with. And we also have the cloud. So it means that in these vast data centers, there can be, we can rent 10,000 machines with a GPU, a graphics processing units, and rent them for an hour and do our machine learning and train our models using these huge resources just for a very short period of time, which will be prohibitively expensive to build a data center to do that, but we can just rent these cloud resources. So that's made it a lot easier to get another few orders of magnitude of power to apply to the problem. And finally, we have, in the case of computer vision, for example, a huge source of images on the internet, largely already labeled for us. And we can use those to train our models. So it's become possible to do this. So a technique, and who knows, in a few years, perhaps quantum computing will increase our computing capacity even more. So it's been possible to build these, use the same techniques in principle, but in this much more complex way. Now, what's the result of all this? Well, if you look at how machine learning has changed over the last, say, 10 years or so, image classification started off at about 30% error rate in around about 2010, which makes it not terribly useful because if you, say, applied that to a problem and classified images, a human being would still have to go through and check them all, which is, doesn't really solve much of a problem. Might speed it up, might not. Speech recognition was even worse. In 2010, we were up at the sort of 60% error rate, which is of no practical use at all. It's other than for making humorous captions for things where it's failed to understand what the person was saying. But now in 2020, we're under the this dotted line here, which is 5% error rate, where below that, comfortably with image classification and speech recognition is also under 5% error rate. And that 5% error rate is significant because 5% is the error rate of a human being. And so once you get to the point where the machine learning algorithm is able to do a better job than a human, then in the majority of cases, then it becomes, that's a game changer. That becomes a very useful tool. I can take my million images in my image library which aren't captioned, and I can set the machine learning algorithm off on it and say, just capture them all for me. And it's and no human being wants to do that, and it would be extremely expensive and extremely tedious. The machine learning doesn't care. It'll just churn away through them quite happily, and so you can solve a lot of business type problems using these kind of algorithms. But remember, they're only for solving in particular fields, so it's not quite the same as human intelligence, where we look at a picture and we understand what it means. It's simply able to identify things that we've shown it images of and can see similarities. So Azure Cognitive Services, how can we use these techniques now? Well, you don't need to be a data scientist. You can use Azure Cognitive Services, which has a suite of these different machine learning models, and they're pre-built, and in most cases they're pre-trained as well. So, for example, we'll look at computer vision in a moment. A pre-trained model, and they're easy to use with APIs. So if you want to build a solution on top of Azure Cognitive Services, you can use their REST APIs, and some of these pre-trained models, or in some cases we can build our own models as well, which or train our own models. We'll see that in a moment. So let's just quickly look at cognitive services in Azure. So if you go to the AI and machine learning and go to cognitive services, there are 4 broad categories: decision, language, speech, and vision. And I'm just going to quickly look at computer vision so we can just see how effective it is. There's a little demo page here. So normally you'd use the REST API to make a request, feed it an image, and it would respond with a JSON object which says what it's seen. Now these purple rectangles are object detection, so it's finding multiple things inside each image, and then it will also give you a description of what it sees. It sees a skateboard. It might say, not to always get it perfect. It might think it could be snowboarding, but I think it's a skateboard. It says there's a person riding a skateboard. If we could look at this one, which is a picture of a bicycle, it's not a very good picture, but it can pick out the bicycle. It can pick out the bicycle wheels. It's not fooled by this circular shape here, which I think is lens flare. It's only picked out the actual bicycle wheels and captioned them correctly. So a lot of the time this model can identify bicycles and provide you other additional information around it, just using a pre-trained model that is built into Azure. Now, what that's doing is it's using this deep neural network. So this is a simplified diagram, of course. This is really 150 plus of these layers in this very complex network, which we had a bit of a quick look at sort of in a diagrammatic form earlier. But what it's doing is it's able to distinguish in reality between a few thousands of different types of everyday objects. Let's simplify this and pretend that it only knows about dog, bicycle, apple, and tennis ball. So it's a pre-trained model, but it's still limited in that it only recognizes certain things, everyday objects. So you might think, well, that's great, but how can I use that for something more specific? I can maybe caption some general images, but actually I've got objects running down a production line, and I want to identify the faulty ones by looking for cracks, say, or I want to look at a supermarket shelf and identify my products on there from a photograph. Those are very specific things. I'm not going to get a model that, say, the example I use is I want to identify different types of butterfly, different species. That's something that you would bring an entomologist in to look at because they know the differences. How can I use a computer vision model to identify different species of butterfly? I'm lucky if it can identify it as a butterfly versus a moth, let alone look at the individual species. So do you then have to go through that process again of having a 10-year research project and spend millions of pounds training one of these models, which is what Microsoft did to come up with this general purpose model? And the most amazing thing is that it turns out that you don't need to do that all again. Because what you can do is you can chop off the last layer or 2 or 3 layers of this pre-trained general purpose model that Microsoft's built and take that away. What you end up with is something called feature detection. So there's a layer, these F1, F2, F3, these are features that the model has been trained to detect. Now, we don't know exactly what they are. They could be circles and lines and checkerboard patterns and edges. It's whatever it's used, because it's been trained to identify things from pictures in the most general sense. That's what we've got sort of a few layers down in the neural network. And this is amazing. This is called transfer learning. We can retrain that model. So what we do is we say, I've given it a number of images of tortoiseshell butterflies and a number of images of red admiral butterflies, and then retrain this layer. So I can leave most of this, I can leave as it is, or I might sort of allow it to adjust some of the weightings in some of the later layers. It depends on the technique you use. And this final layer or few layers, we just retrain that bit. That turns out to be a very quick process. And then you can have a model that can identify between tortoiseshell butterflies and red admiral butterflies and be surprisingly accurate at doing that. And the interesting thing is that it only takes a few minutes to train this model. I only need, say, dozens, if that, of images to train the model. They don't have to be super high resolution images. I can go onto the internet and use Bing and do an image search and say, give me red admiral butterflies. It'll give me a nice set of training data that I can use. Most of the time they're accurate. I might have to go through and pick out the cartoons and diagrams and things, but I've got a lot of training data that I can get very easily and then train the model to do that in a matter of a few minutes using another service in Azure Cognitive Services called Custom Vision. So that's what's happening. This is transfer learning. It also, you can use it in other fields as well. So things like text processing and image recognition. You can say for text processing, you might have a general purpose model that doesn't know about specific terms in your industry, but you can then refine that and say, I wanted to recognize terminology that's very arcane and specific to my industry. So this is all possible due to transfer learning. And the interesting thing when you think about this is, that's kind of how the human brain works as well. So when we learn to identify new objects, we don't go back to preschool and toddler and learn how to, or as a baby, learning how to see things again. We just sort of use our existing knowledge of shapes and edges and all that's we've acquired over our lifetime, and then reuse that. And that's essentially what's happening here. It kind of gives you a little bit of a window into how the human brain works, or at least the visual cortex works, possibly the whole of the brain. when you think about transfer learning and that you're using models, when you think about a new problem, you often think in terms of similar things that you've done in the past that might be completely unrelated. And it's almost like learning, any learning is reusable models, or reusable understanding of things that we can use. So, I think uh, uh, you might learn something at school or at university that think, well, I'm not really going to apply that. But really, learning anything is a bit like building the basic model that you can then fine tune to learn a new thing on top of that. So I think it's a really fascinating thing that the way that transfer learning works. So I'll just very quickly look at custom vision. I don't think we've got time to go through the whole of this this demo, but this is how we work in the custom vision service. So there's a portal where you can go in and you can, in this case, we'll pick the general model, and what we need to do is add some images which we're going to use to train the model. So what effectively we're doing is retraining a model, or doing the training. And like computer vision, which is a pre-trained model, this is a model that we will train. It's a pre-built model that we're going to train. And what we need to do is find some pictures. So what I normally do is I go to the internet and start finding images. So we'll create a new folder for the Red Admiral butterfly. And then I'm going to go to Bingle. I'm going to use a well-known search engine. Bing works just as well. And what we can do is, we'll say search for Red Admiral butterfly. You have to say Red Admiral butterfly. If you just say Red Admiral, you'll get pictures of admirals and red things. But the Red Admiral butterfly, mostly you have to scan through the images and just make sure that they're all really are Red Admiral butterflies. And then same thing here, but this time with a peacock butterfly. So I've saved about 15 or 20 of each of these images. They're only the thumbnails. I haven't gone back to get the original images. All I need is the thumbnails, and that's sufficient to train the model. So now, having got the images, I can upload them into the custom vision portal. So this is, I'm uploading the peacock butterfly, and now this is critical. I have to tag that because I know those are all peacock butterflies, so I tag them as peacock. And obviously, if you get the tag wrong, it doesn't work because that's all it knows. It has no understanding of butterflies and different species. It's simply, if I'm labeling them as peacock and labeling them as Red Admiral butterflies. And this is the supervised learning part. So I'm specifying what they are. There is other techniques as well. We can build object detection algorithms using this approach. You can also do use the unsupervised learning technique, where you say you figure out, the algorithm figures it out. Now here we're training the model now. This will take a few minutes. I'm actually already trained with, and I added more images and retraining it. And it tells me how successful the model's been in the training. It actually takes a couple of minutes to do this. It depends, but it doesn't take a huge amount of time. And now you can feed it sample images. You have to obviously test it with images that you didn't use as part of the training data. And you can see that it's very high success rate in identifying them. Now, you have to be a little bit cautious. If I feed it an image of a butterfly that it's never seen before, then the whole thing breaks down, because so you have to do something like either build a set of data of things that aren't butterflies or other species of butterflies and have a sort of a null set. So there are ways of getting around that as well. So it's surprisingly easy to use this to build a custom vision model that can identify things that are images that are specific to whatever you're trying to do, your products. fault detection, whatever it is you're trying to do. Very, very interesting. Now, this is still a little bit artificial intelligence. In some cases, what we want to do is we don't even want to get into this at all. We just want to use pre-built models that we've got access to with things like the Microsoft Graph. So a quick word of explanation. A graph is a term from mathematics, from discrete mathematics, which is a way of describing a relationship between these vertices and the connections, the arcs between them, various words, depending on which field you look at. It's another type of network. It's not a neural network. It's a different thing. This is a way of expressing the connection between things. And so typically in the Microsoft Graph, what we're talking about is people and their connections and groups of people. And over time, that's been extended to things like the files that we deal with, the conversations we have around things. There might be emails or increasingly chat in Teams, or there might be where we're doing co-authoring of documents and we have a conversation around a particular document. All that gets captured inside Microsoft 365. And then we have insights. So one of the features in the Microsoft Graph is the insights, where artificial intelligence algorithms have looked at all these connections and seen how things are connected, and it's able to draw information from them. That's then all presented in the Graph API, which we can then use as we build our applications and call those. So these are pre-built models with a sort of it's all pre-done for us, and this gives us these insights. Can be things like what documents are particularly interesting, which I always think is a bit like search in reverse. So instead of waiting for you to search for a document, it'll actually can say, here's a document you might be interested in, and proactively suggest things for you to use, to look at. Who should I contact in the organization for this topic is another example. So it's a way of capturing all the information in an organization and helping you find things, because often things are known within your business, but you don't know who to ask or where it's buried. This is a way of bringing this information out, and really, this is now being surfaced in a number of different ways. So one of these tools is Viva Topics. Not to be confused with Viva Insights, which is a slightly different thing. Viva Topics will, it's particularly designed for people, say, when you're joining a team and you just don't know what all the terminology means, because in organizations and in groups within organizations, words have particular meanings to that group of people, and it can take a while to get up to speed on that, and this is a tool that can help you do that, because using those same techniques, using the underlying what's in the Microsoft Graph as another way of surfacing that in various different places, like in topic pages and topic cards, and just helping people find things out about the business. There's also a tool called SharePoint Syntax, which is built on top of Project Cortex. Again, it's using AI as a sort of a super search engine that can do more than simply search for information. It can actually surface information. So these technologies, underlying it all is AI, but we don't have to work with AI. We don't have to be data scientists or even use something like cognitive services. It's another layer on top of that, but it empowers us to find information. And it feels, I think, just as the steam power in the 19th century enabled us to do things beyond what our human strength could do, now we're just starting to see things that extend what the human brain can do, and extend our mental powers in a way that allow us to do things more efficiently, and as thinking and in business and the world of work. Now, I think it's very exciting, and I think we're going to see this really improve and give us some very exciting possibilities. I just want to end with a slight word of warning, and if you want a depressing read, then just read anything by Nick Bostrom. He writes books about how humanity is going to end in all kinds of horrible ways. We can think of a few of them. I think there's this weekend we'll start discussing one of the major worries, which is climate change. But another one is, well, where will artificial intelligence end up, and where is it taking us? And there are a few issues here as well, so there are some ethical issues which we'll talk about, and some existential threats as well, which is quite scary. So let's tackle the ethical issues first. So if you look at this interview, it's a TV interview with an actor. He's a comic who can mimic other actors. So if you look very closely at his face as we do this clip, he's called Bill Hader. It's very clever, but there's a change to his face when he starts imitating Al Pacino. I'm not sure if you can hear the sound, but you don't need the sound. You can see his face has changed to Al Pacino's face, and it's quite disconcerting. And in this second clip here, you can see him change to. He's going to change to Schwarzenegger. He's become the Terminator. So it's quite frightening that somebody's face can be put into replaced. And so, of course, you can't really trust what you see in a video anymore. Like it could easily all kinds of scary implications of that. That your face could be put onto the body of somebody doing whatever, a politician, for example, saying something or doing something that they never did, and so it becomes even more difficult now to trust what we see. So there can be useful applications of this kind of visual face replacement technology, particularly in entertainment, but it can also be quite worrying. There are other ethical issues. So, for example, if you wanted to screen 10,000 job applications and you wanted to get it down to 10 people to interview, well, a lazy HR department might think, oh, we can just use an AI model. And based on our previous hirings, we'll just screen candidates that look like people that were successful in the business before. But that might introduce all kinds of biases in a way that perhaps a human recruiting person wouldn't make those mistakes because they know they were wrong. The AI algorithm doesn't know that, and you can't always see exactly how the algorithm is working. As I say, there are ways to mitigate this, to say test the algorithm to see that it's not biased, but great care is needed. So although these powerful tools are easy to use, it doesn't mean they're easy to use safely and in a responsible way. Other things like detecting crime, calculating insurance premiums, healthcare. Who gets the expensive medicines in healthcare? All these are very problematic areas, and there's a set of responsible AI principles which you can get if you just Google for Microsoft AI principles. There's that you can. I would recommend that you have a look at and keep in mind as you apply these techniques, so that we use them safely and wisely and fairly as well. Now that's a whole bunch of ethical issues. There's also the existential threat. So if you look at machine learning versus human learning, and if let's start in 1957, which is when our perceptron model with all the wiring and the electromechanical potentiometers doing the weighting algorithms, and then we look where we are now, we can see that roughly human learning performance has stayed roughly the same. It's maybe improved a little bit as we've got easier ways of acquiring knowledge than we had in, say, 60 or 70 years ago. That has got better. So we can, I would argue, we can learn how to do things more efficiently than we could before. But the human brain itself hasn't got really any better. You know, there's only so much we can do with evolution. You know, that's a very slow process. It's taken millions of years to get us to this point. It's not going to change very rapidly. On the other hand, computers or machine learning is increasing very rapidly and at an accelerating rate. Now, you'll notice we're not yet at human performance. We are in certain specific things in a field in what would be called weak AI, in that it's a very narrow fields of application like computer vision. They're very specific things. In terms of general intelligence, what we're talking about here, strong AI, then there's still a long way to go. But there's a few people are predicting that are experts in the field that it's going to be probably 30 to 50 years before we get a crossover and the machine intelligence, and talking here about strong AI, sort of general intelligence, begins to overtake human beings. And that's a very dangerous situation, because it means something could happen. And if somebody programs a goal into an AI system and makes a mistake, it could run away in some way that we hadn't predicted, that it might, there's all kinds of scenarios. As I say, if you read that book, it's a little bit depressing, but there are lots of scenarios where, something goes wrong, where you tell the AI to improve human happiness, and for some reason the AI concludes that people are happier dead. Then that would be a bad situation, and then something could get out of hand, and we wouldn't be able to do anything. It might be something more subtle than that, that it just consumes more and more resources to achieve some goal at the expense of the human race. So some quite scary scenarios. Probably not the Terminator, but you have to have the Terminator in any talk on AI that talks about the future. This is probably the least likely of the scenarios where robots take over and try and destroy mankind. It'd probably be something more subtle than that, and just some silly accident. So we have to be very, very careful with this technology. Now is the time to think about how to solve these problems. Don't wait 50 years when it's too late. We need to be thinking about this now. So as well as COP26, we need to think about the future of artificial intelligence, and about 5 other things are serious risks to humanity. So AI is here, really, just to wrap up. AI is already here. It's pervading everything. It's everywhere, and there's more and more of it. It's really useful, and I think it's going to really change the world of work for us, and in a good way. You don't have to be an expert. You can use cognitive services and the pre-built AI models, and you can use everything that's built into Microsoft 365, and you can use those tools now, and they can use them as a consumer. You can take advantage of them, and you can build things using those technologies, and it's really easy to do. But do be aware of the risks, existential risks, but also the ethical risks. So be aware of the responsible AI principles when you apply these models. So that is pretty much it. So our partners, thank you for your support, and the various communities that have backed this conference, and probably just got a few minutes for Q&A if there are any, perhaps in the chat or possibly live, not sure. But thanks very much for listening.
Thank you so much, Bill. It was a great session. I learned a lot of things throughout the sessions. I think it was very interesting. I hope audience equally enjoyed the session. I don't see much question except appreciation from a few of the attendees. Hope they equally liked it. And I just pushed a feedback form as well as a unique code for this particular session. So if the audience could fill in this feedback for Bill and the content shared along with this unique code, all of them will stand a chance to win. Not standing a chance to win, but they would certainly get a Microsoft T-shirt sent to them another couple of weeks. So I strongly appreciate everybody to fill in and now support it. Once again, thank you so much, Bill. Let's wait for a couple of minutes and see if there's any more question. All right, not many.
Everybody's too frightened.
Too frightened about AI, it seems. But I liked all of your, the videos that you shared, the face thing, as well as the Terminator image that you shared. I enjoyed it.
Good. Well, yeah, I hope it was scary but interesting.
That is right. And I found a theme of, speakers presenting the similar topic. There's a lot of cognitive and AI specific topic on this conference, a lot of ML and ML.NET, cognitive services. So I do. When do you think organization would take AI seriously? Does that mean?
Oh, I think yeah. I think now is the time. Yeah, I think now is the time. It's. I think if you don't get on this now, it's going to be too late. Your competitors will. People are applying these things in all kinds of ways. They don't always tell you that they're using these techniques. They're not going to. So yeah, if you're in business, you need to get on top of this. And yeah, definitely watch some of these sessions over the next few days, which will delve into some of these, like Azure ML, fascinating tooling to support that, and cognitive services, just amazing what they've achieved in just a few years.
Agreed. So, what I really like about the cognitive services is built for developers, right? Not everybody is an ML expert, and it is a very hard area to get into, and the learning curve is quite high if you want to really deep dive into AI yourself, and that's where cognitive services come in really handy, and embed cognitive services without really having the deep down knowledge of that technology. So
yeah, exactly.
I certainly appreciate all the attendees who are watching live, as well as who would be watching this content later on YouTube, as well as Channel 9, to try your hands on with cognitive services. All right.
Definitely. It's a great starting point.
Of course, yeah. Thank you so much, Bill. It was a pleasure having you on AZConf.
It's been fun. Thanks for having me.
Thank you so much. Have a great day there. Bye-bye.
You too.
Patrick, you're live. Thank you so much for joining.
Hello there. Thanks for having me. Great to be here. It's been a good day so far.
Yes, the stage is yours.
Awesome. So, my name is Patrick. I work for Microsoft, focusing on our open source and NoSQL database platforms. So that's what I will be talking about today. I only have 20 minutes, so it is going to be lightning fast and relatively high level. But you did get to hear a little bit about Cosmos already in the morning from Rohan. I was pleased to see him call out Cosmos, and we also have some great sessions after mine that's going to go much deeper. But without further ado, I want to start by just looking at the trends we're seeing in the market when it comes to both open source and NoSQL. And there's no doubt that enterprises in general and enterprise developers in particular have really embraced open source in general and open source databases in particular. And to really simplify it, I guess you could say that many web developers have been used to using MySQL as part of the natural LAMP stack when it comes to building web type applications. And over the years, we've also seen Postgres become really the enterprise data platform of choice for enterprise developers. So these two databases kind of tend to fight it out every year, which is going to be voted the most popular database on the DB Engines rankings. Then if we listen to Gartner, they are predicting that already next year, more than 70% of all the new applications that are being built will be built either on open source databases or on a NoSQL database. If we look specifically at what developers are using today and what they would love to use in the future, you'll see again, MySQL is number one. Of course, a lot of that is going to be web developers. Postgres is number two. Might be a surprise to a lot of companies that are still using a lot of SQL or Oracle or, God forbid, even DB2. But what would they like to use? If that's what they're using today, what would they like to do? Certainly Postgres is number one on the relational database side, but it's a very close race between Postgres, your traditional relational database, and MongoDB, which is kind of the newer concepts around NoSQL databases, in this case, a document database. So that's really the trend we're seeing. If we then look at the flip side of that, which are the least liked databases and rather most dreaded? No surprise, some of those legacy technologies like DB2 and Oracle are at the top of the least wanted databases. And that's on the technology side. If you then think about the businesses that have to pay for the licenses and the support maintenance of these databases, they are probably pretty aligned with their developer counterparts. And as I mentioned, NoSQL, whilst it's been around for 15 years or so, it's really started to rise in popularity really over the last maybe 5, 6, 7 years. And MongoDB has kind of led the way with the document database concept. But then if you add graph to that concept with Gremlin and other graph type databases, it's really growing exponentially with the new use cases that we are seeing as more and more companies are building truly cloud native and truly cloud scale type applications. So let's look a little bit at common use cases. I'll start with Postgres, and I'll keep it really simple to begin with. The first thing I would say is anything you would traditionally do on an Oracle database, a SQL database, or possibly a DB2 database, most people are now considering doing that on Postgres. So if it's a greenfield project, definitely most enterprises building an enterprise type application or workload will run that on Postgres. The other big trend we're seeing is an exodus away from Oracle and DB2, and the favorite database of choice to make that move to is also Postgres, as you can see from the reverse trends here, where Postgres has been growing really rapidly, and this is a logarithmic scale, by the way. So in the last 5 years, it's grown, by 3x in popularity, and both DB2 and Oracle are taking a beating here from this open source database that by no means is a new kid on the block. It's been around for 2 decades or so. And is therefore a really mature, really scalable, stable, high-performance database, which is exactly what enterprises are looking for. And not only that, it also has some really interesting extensions, one of them being PostGIS, which makes it the most mature geospatial database. Then you have things like JSON, which traditionally you can only do in a document type database. Postgres actually supports JSON, so kind of crossing the borders between what's a NoSQL and a relational database. And even further with Citus, which is another extension that I'm going to talk more about, because we got so excited about Citus that we decided to acquire that technology. What Citus does is allow you to scale Postgres horizontally, which again is one of those killer capabilities of a NoSQL database. So this is really turning into a very interesting database for many different use cases. And we certainly see large telcos, banks, healthcare providers, and governments starting to default and de facto on Postgres. Why Postgres for Oracle? Other than every point I mentioned earlier about the enterprise grade, obviously TCO is a big conversation starter here. If you can go from Oracle to SQL, you'll definitely save license costs, but you're still paying a SQL license. If you go to a Postgres community version, all of a sudden you're not paying any licenses, which is obviously a major factor here. But the more important benefit here is the fact that Postgres and Oracle are very closely related when it comes to the database language, the stored procedures and the schemas, which means that the complexity and therefore the time and therefore the risk and therefore the cost associated with moving to Postgres is a lot lower than it would be moving from Oracle to any other database. A good example here is the Austrian Railway, who decided to replace their Oracle database running their ticketing systems, an 11 terabyte sized Oracle database, to Azure database for Postgres. And whilst they were doing that on the database side, they decided to also take this monolithic application and turn it into a microservices-based application, now running very happily and scalably on Azure Kubernetes services. MySQL, as I mentioned earlier, it really is the web developer's favorite database. Still to this day, it runs 9 out of 10 websites around the world. It's just a natural part of the LAMP stack that many developers have come to love and possibly have a love-hate relationship with, but generally love. And then another point I wanted to make here is, why do we have a MySQL database and a MariaDB database? They are clearly very closely related. In fact, they share the same founder, a Swedish founder, Michael Widenius, who first created MySQL and got a little bit uncomfortable when Oracle acquired MySQL and turned it into MySQL Enterprise, where you do have to pay a license. So you can now run MySQL Enterprise version, paying licenses to Oracle. You can run community versions for free, and that's the one we support on Azure. Or you can run MariaDB, which is truly an open source community database that we also support on Azure. Use cases here, we already talked about web apps, certainly e-commerce sites. A lot of these packaged applications, whether it's WordPress, Drupal, Magento, Shopify, they are very naturally supported on MySQL. So it's very, very easy to run those applications on top of MySQL. Another killer use case is for secure digital payments and online transactions. So whenever you're paying for anything you're buying online, chances are that transaction is being handled by a MySQL database in the backend. And then another use case we see a lot here in Asia, particularly in Korea and Japan and China, is gaming. Most gaming customers that we have, whether it's Linked Brain or GamePub or others that are not yet public, are running their online games on top of MySQL on Azure as well. But to make it real, here's one example that is a really fantastic use case, not only for MySQL, but again for Kubernetes services and also for Cosmos DB, where HSBC in Hong Kong have built their PayMe online payment application on top of our services on Azure and are serving more than 2.5 million customers every day with this service. We do have an amazing video here from how we built it on YouTube. So if you search for PayMe plus how we built it, you can watch the full architecture and a conversation talking through how we put all these pieces together, both across the data and the application front end as well. So overall, the key point I want to make here is that, yes, Microsoft is the company who built and continues to build SQL. SQL will continue to run best on Azure, absolutely. But we are definitely not, only your SQL and Windows Server cloud. We want to be the open cloud platform. And for that reason, we have invested tremendously in building out first-party services running all of these open database technologies. And we pride ourselves on leveraging on the community editions and not just leveraging, forking, and turning it into another cool, sexy database that becomes proprietary Azure. We are fully community-based. And what we build, particularly on the Postgres side, where we have 6 contributors, not only do we build that into our service, we contribute it back to the community. So I think if you're moving to open source because you want to avoid vendor lock-in, obviously that's what we want to do for you as a cloud provider as well. On the NoSQL side, we did go with a cool name, Cosmos DB. Don't ask me why. But under the hood of Cosmos DB, we have a multi-model NoSQL database, where again, we support open interfaces and APIs with Gremlin, Cassandra, MongoDB. So you can use all of those NoSQL databases that you know and love, but run them truly at cloud scale on top of our platform. So what do we mean then when we speak about database as a service? Well, it's just the database word for PaaS, right? So if you're familiar with PaaS, you can understand the concept of database as a service. And what does it do for you? I really love this quote, which I actually got in a one-to-one conversation with Apurva over at WebExpress. And he put it better than I could have. He's getting 4 nines of uptime. He's getting 90% less operational administrative overhead to work on, and he's getting 900% more peace of mind, which I think is just a fantastic, adamant to how much DBaaS can help you save up your time you're spending on operational tasks and really focusing on building and innovating your application. One killer use case for sure is the fact that if you're running these databases as a first-party Azure service, you will get the support directly from us. Just like any other Azure service, if you have a problem with your Azure MySQL or Postgres database service, you raise a support ticket with us and we will help you solve it. And in the unlikely event that you find a bug, we have the relationship back with the community, so we can work on fixing that bug with the community as well. There used to be companies like Percona and EDB that build a business around supporting open source solutions on premise. Red Hat, obviously, the first open source company that became a $1 billion company providing that kind of support. But in the cloud, you really have less need of paying someone else for support when that's provided by the cloud provider. Other benefits, everything becomes easier. Setting up backup, you just need to decide, do I want a 30-day or a 90-day backup window? Do I want to do high availability across availability zones? Do I want to do DRs across different regions? It's a click of a button. It's not a lot of work to set that up. The platform will do that for you. You just make the decision. And on top of that, we also provide additional intelligence and security. So we can tell you about suspicious activity against the database. We can even tell you when you're over provisioned, which everyone is on premise, and tell you, actually, you could comfortably move down to a smaller SKU, which means you're going to pay less for the service, and you're not going to have to over provision for what you might need in the future. Similarly with queries, we can even tell you that, hey, this query would run better if you put an index here. So it's really providing that additional intelligence on top of the service. So definitely some of the key benefits. I think I called out quite a few of them here. Definitely we talked about the importance of being open. But regardless of your favorite database, I know that if you're going to build your application on AWS, you're not going to put your database in Azure and the other way around. You want to put your data where your application is, certainly from a latency perspective. And that's why we also pride ourselves on the tight integration with other Azure services, such as the examples I've given now. Pretty much every new customer that we have are building an app. They're building it on containers with Azure Kubernetes Service, and they're using a modern and open data backend. So it all fits together, right? So the integration there of building the full solution in one cloud native platform and one package is super, super important. Now, one of the differentiators that we offer on Azure is the flexible deployment options. So we have two options in terms of a traditional single noded database SKU. We have single server, which you can think of as a cost optimized SKU, which more or less gives you high availability for free, unlike other cloud platforms. Then we have flexible server, which you can think of as our performance optimized SKU. So this is the one you would go for a true enterprise workload that have higher requirements and also gives you more flexibility. For example, our gaming customers use flexible server because they get a much more customized maintenance window. But also for enterprise workload, you have more options when it comes to high availability. Then we have our real ace up our sleeve, which was the Citus extension I talked about earlier. And as I mentioned, we got so excited about Citus when we used it ourselves for our Windows Update service that we got really close to the company. We decided to acquire the company. It still runs and contributes everything, every code back to the community, but we're building it straight into our database as a service platform as well. And what that allows you to do is not just scale vertically, but scale horizontally. So now all of a sudden you can scale to, petabytes of data, and you can run your queries across multiple nodes under the Citus cluster. Then, of course, Azure prides itself on being the open and the hybrid platform. So you would be surprised if we didn't offer an option to run Postgres in a hybrid fashion, and we do that with Azure Arc. So really another unique capability that you will only find on the Azure cloud. And if you do want to know more about this, check back in tomorrow when Daman Kaur is going to talk about, in general, how Azure Arc supports our different data services, whether that's SQL Server or Postgres, to run those in a hybrid fashion. I'm not going to go super deep into Citus, but what I want to say here is that the concept is you can now scale out horizontally like a NoSQL database, which is why many people have started to call this category of SQL databases that scale horizontally new SQL. So it's really a new category, if you like, of databases that takes the best of SQL and the best of NoSQL type database technologies. Again, I'm not going to do justice to this call, but do check in again tomorrow with Subhashis, who's going to talk about how a customer of ours moved from AWS Redshift, which, if you didn't know, is actually a Postgres fork, back to the point about forks, which makes it very easy to move from Redshift to hyperscale Citus, and they achieved 2 times better performance at half the price. So really awesome case study that you can listen into tomorrow. These are a couple of other examples. The Helsinki Transport Authority moved to Citus from traditional Postgres to improve query performance and went from minutes to seconds of query processing. And as I alluded to earlier, we are actually using Citus now hyperscale on our Windows Update service, and that's truly cloud scale. We're querying 2 petabytes of data, millions of queries every day, and those queries are being run in milliseconds. BNY Mellon, another great example where, similar to the HSBC one, if you go to YouTube and you search for BNY Mellon and how we built it, you can watch a 10-minute video about the full architecture. I'm not going to either have time or technical ability to do it justice here. So do check out that session as well and learn on your own with these how we built it sessions. They're really awesome to learn the real details of what does the service look like under the hood. So with that, I've talked about both MySQL and Postgres. What about NoSQL then? I think many of you have probably started to use NoSQL. Possibly you're more familiar with MongoDB than other databases. Some of you might be using Couchbase, and some of you might be using Cassandra. Now, what's different about Azure Cosmos DB is that it's a multi-model database. So all of the traditional NoSQL concepts, whether that's a key value or a document or a table or a wide column or a graph database, are supported on Cosmos DB. We do have our own API called the Core or the SQL API, which is actually a document database. The reason it's got SQL in its name is because it's more akin to the SQL language. If you're more familiar to writing your database queries in SQL, that will be an API that'll be more familiar with you. Now, if you are already accustomed to Mongo, then you would probably go for the Mongo API. And in the case of Cassandra, we actually offer 2 options. One is the Cassandra API as a fully database as a service offering, but we also have an Apache Cassandra managed instance service, which makes it really easy for you to either entirely move or extend your existing Cassandra clusters to a managed service on Azure. And then potentially in the future, you want to go full database as a service, and then the Cosmos Cassandra API would be the right option for you. Gremlin is our Graph API. Graph has become really a big phenomena, whether you want to do, supply chain tracking, shipping tracking, you want to track your food ingredients if you're a food manufacturer or food processor. The Graph database is excellent for those use cases. So we're seeing a lot of those type of use cases lately. So what Azure Cosmos DB has in common, regardless of which database type or API you're using under the hood, is the fact that it is leveraging on the fact that Cosmos is a globally distributed cloud platform so that you can easily globally distribute your application. All you have to do is select, actually, I know I'm going to have customers. I'm a shipping organization in Hong Kong, for example, but I know I'm going to have customers in America and in Europe, and I need to make sure that those users have the same low latency experience as my Asian customers. With a click of a button, you can replicate your data into those data centers that are closest to the user, and that way ensure ultra low latency. In fact, we provide you with financially backed latency performance as well as 5 nines of availability, provided you go for a geo distribution. Obviously, the more you replicate, the higher your availability is going to be, and the closer you put your data to the customer, the lower your latency is going to be. So that's really a killer capability of Cosmos. And the other one is how easy it becomes to scale up and scale down. If you remember when I showed you the slide earlier, there were a couple of NoSQL databases like Cassandra and Couchbase that were dreaded databases. My personal theory is that's because it's very difficult to manage these kind of clusters, similar to managing, a big data Hadoop or a Cloudera cluster on premise. It becomes painful. So let the platform take care of that for you. Once you've decided on your partitioning key and your data model, the database and our platform will manage the rest for you automatically. And you can then go in and use capabilities such as autoscale or serverless to reduce the cost and have a truly scalable platform where you use only as much as you need when you need it. Perfect example is a lot of media companies and media streaming companies are using this. And if there's a big fight night on, then they scale up. And once the fight night is over, they scale down very, very quickly. I provided some links here as well to a couple of articles that I've written about 5 reasons why you would want to use Cosmos, but also a bunch of examples of who is using Cosmos and why. Now, of course, you're going to want to go more deeper technically. So again, I want to promote my fellow speakers here. Shweta is amazing, and we'll be talking about how you optimize your cost and performance later this afternoon or evening, depending on where you are. And Leonard Lobel, one of our amazing Cosmos MVPs, will be talking about these concepts around data modeling and partitioning that you just have to get right to have a good experience with Cosmos. So those sessions are super important if you are serious about NoSQL and Cosmos. These are a bunch of customers, a bunch of public customers that I can reference, and you can see the link to read more about exactly what they are doing. But there's so many different use cases. NoSQL is certainly not just for the Facebooks of the world, and not even only the Coca-Colas or the Mercedeses or the Asuses for that matter. Most companies have a use case for Cosmos, particularly if you need to do and serve data in real time and serve that back to an application. Perhaps you're doing an online payment app like the one I mentioned with HSBC and also Vips over in Norway. Perhaps you need to do supply chain tracking like DHL and Lynx and HarvestMark, or you have other retail use cases where you are serving up an online shopping experience where the customer wants to get recommendations in real time. Another fantastic use case for Cosmos. So there's no shortage of use cases. And in fact, I have an article to share with you as well to go deeper into some of those. One common use case is getting away from running these type of technologies on premise because it simply doesn't scale. So these are just a couple of examples of customers that have moved from either Cassandra on premise or Mongo on premise. And again, if you capture that URL down there, you can get some great advice on how you go about doing one of these migrations. So to sum it up, really what we're trying to do with Azure is offer the right platform regardless of what your favorite database is. Yes, we still love SQL, and everyone have a different database favorite. Someone loves Maria, someone else loves Postgres, and so on and so forth. We want to be that open platform regardless of what your favorite database is, and regardless if you're building a new application, if you're modernizing an existing application, or you're migrating an existing database technology that is being either painful to run, like Oracle or DB2, or you find it time consuming to manage the operations yourself on premise and want to give as much of that operational management to the platform as possible. So as I mentioned, I am really interested in these technologies, and I try to write about them in very layman terms because I'm really a layman myself. So if you want to learn more, feel free to check out these articles that I've written on these different technologies on LinkedIn, and hopefully you'll get some good ideas from there. I also want to give another shout out to all the amazing sessions that are going to be much more deep and technical than this session, to go and learn really about whether you want to learn about Postgres or Cosmos DB or how you run hybrid data services. It's all available in the sessions that our amazing community has put together for us over the next 48 hours or so. So with that, that's all I think I have time to share with you. And I hope you have a great conference and a great Saturday tomorrow as well if you're joining us.
Good afternoon, everyone. Am I audible? Just checking the audio. All right. So let's proceed here. So in this pretty fast forward discussion about the Kubernetes application developer certification, I have some tips and tricks for you. So that's the agenda for the talk. What I essentially have here in the link is set of things I wanted to speak about. So that's my live slide. So it is in my GitHub portal, and then I have got this list of tips and tricks which I thought are most important, which can help you make things pretty easy and straightforward, right? So to begin with, let me share the screen and then show you what exactly is there, okay? So if you can see my screen, it is a GitHub page, right? And then I have a couple of points here. And the first point I wanted to emphasize on is this Kubernetes exam, the certified application developer or Kubernetes admin is all about doing things. So you basically get a console and set up problems to solve, and you go and fix them. There is no objective type question, which means that you will not be able to, let's say, select an answer. So it is all hands-on. So you need to keep practicing. So the more comfortable you are with the command line tools and the keyboard, you are far better in terms of clearing it up, right? So one of the first step I wanted to make is that Kubernetes or this kubectl can be run on both Windows as well as on Linux, but the console you get for the exam is a Linux-based console. So if you come from a Windows background, make sure that you practice things in the Linux environment, maybe in a headless VM or in somewhere which is a console. So use Linux to make yourself comfortable, and also learn VI editor or Vim editor, so that you will be able to do like making changes into files, modifying things, etc. So how do you open a text file in VI editor? How you come out of that? How you copy a content into that? How you move or replace some content from that file? All these things will be coming back and back again into your exam. So you may need that, right? So that is something which is absolutely important, right? So I kind of noted down few things. It is all about practice. So the more you practice, the better you become in the VI editor. But I wanted to highlight few things. One of the things I wanted to talk about is number 2, that you have many different options to practice this, right? So what I like about Minikube is also one of the recommendations from the Kubernetes official documentation is that if you have Minikube running, now this is one of my machines where my Minikube is running. Minikube is a small utility for Kubernetes installation. So it's a single machine where you can run things, right? Maybe can I have my avatar removed from this screen, please, because it's blocking the area. All right, so if you see that it's running Minikube, right? Now, one of the tips I wanted to also talk about is we use a lot of kubectl command. Kubectl command is a CLI which you need to use again and again, but you need to keep typing that all the time throughout your session. So when you basically have this kubectl, right, you need to actually use this alias to make sure that you can type only k to get the same output. So if you now type k, you get the kubectl. So for example, I say k get pods, you get list of pods in that machine running here. So the kubectl becomes k. So it helps you type faster. Now, for example, now I need to create a pod as per the instruction. So what I can do, I can simply run the cube run, let's say web3, and then image nginx. Now, what this will do, this will create the pod for me immediately as soon as I'm done with that. But if I use something like dry run client, and then I say output to an YAML, that is what the file we use for deploying resources to Kubernetes, and save it to, let's say, one pod.yaml. And what happens there, it will be a file called one pod YAML. If you open it to the Vim, or you just say cat one pod YAML, this is the file which generates. So it did not create any actual resource. Now, you might want to come to this file and start modifying some of the things like, let's say, a namespace or the name of the pod you are creating, etc., which you can do by modifying it in the VI editor, which you are, once you are done with that, one of the things which is also recommended is that you use this file to create the resource, and to create that, use -f and then one pod. That's how you get the thing created. Now, for example, you are not happy with what you have created, or there was some problem and you want to delete this, one of the things you can do, you can use this delete command and then say pod and the name of the pod, that is web3. That will delete. However, you can use the same file to delete it. So it becomes easier for you to delete any resource if you have created that using a file. So you can run this command and that will delete the pod or whatever inside that file is one by one. So clearing things up will also be very much helpful in the sense like when you delete things. Now, if you notice here in my screen, right, it took some time for the pod to be deleted. Now, if I just go ahead and create it again, it's pretty fast, created, and I say, okay, get pod to, if the pod is still under creating thing, you can see that now the web3 is running, which means that this pod is now working fine, and say, okay, get pod, you get the pod running, which is web3. Now, if I go ahead and let's say run a simple delete command, okay, and you might have to do it in the exam because you might be doing some mistake by creating something and you think, oh, I did a mistake, let's recreate that. So you need to delete that to be able to create it. So to delete a pod, and if you say po web3, you use something called grace period, and that's what I mentioned in my write-up. So if you see over here in this write-up, a little bit down here is a grace period. Okay, so that's a switch you need to use to delete it without wait. Okay, so let's see the experience. So if you say grace period equals to 0, so it'll not wait for anything to happen, so it'll go ahead and simply clear it up. And then you need to also use a combination of force equals to true. By default, the force is false. So if you do that, now the pod is deleted. I want to show this experience again. So assume they're gonna go ahead and create this pod. You created the pod is created, k get pod. Okay, the pod is still under creation, so let's wait for the pod to finish creating, and it's running. Okay, now what I'm gonna do is that I'm gonna go ahead and delete this pod. Now if I delete it without this, what happens is that it waits. You can see that the cursor is waiting. The command did not come immediately. Now it came. Sometime it takes pretty longer, okay, nearly a minute or two. If that is the case, then you have to wait. Instead of that, if you, let's say, go ahead and create a pod and then delete the pod using the no grace or grace period 0 with the force true, it is almost immediate. Okay, so that's the difference, and that's what is pretty helpful in the scenario when you work on exam and then you create something by mistake and you want to delete it, right? So one of the things you can see over here at this point in time is an ability to do a lot of things. So you have seen me creating pod, and I can also create a deployment. I can say that, hey, I want to create a deployment. So if I say create deployment, and name of the deployment is web, and then the image is Nginx. So I'm not going to explain what I'm trying to do, but if you have worked on Kubernetes, you know what I'm doing, and you go ahead and get the deployment created. To read what is there in the deployment, you say deployment, you get that. Now I'm typing a lot of, let's say, and I'm also doing a mistake, right? So I'm typing a lot of things. You can see that I can actually make things pretty effective by saying that get deploy. If I say so, it also gives me. So this is the shorter form of deployment. Similarly, you can say get pods. It will give you the list of pods. But if you are lazy like me, you can type po. So you need to learn those shorter forms to be able to type faster. Okay, so you have po for pods, deploy for deployments, n. So if you say get namespaces, it will give you the list of namespaces, but you can say get ns. That's the shorter form of namespaces. So instead of typing the whole namespaces, you can say ns. So I kind of have also highlighted few of the shorter form over here in a table, so which you can use in this context. So you can see that you have got this list of things, but there are more than that, but these are mostly used, but you can figure it out from the official documentation. Now, one of the two things I wanted to quickly highlight over here is that when you work on Kubernetes exam and then sit for an exam, right? Make sure all the documentation is bookmarked, which means that all the important area which you need to refer. For example, if you don't know how to create a deployment, you create a bookmark and keep it there, because the CK80 exam is an open book exam and it allows you to navigate to the official Kubernetes documentation, so which is allowed. But you can open the official documentation during the exam and search for it, which will kill some time. Instead, if you know that these are the area you need to refer during the exam, keep a bookmark ready. And also the YAML file is important aspect. We did not have much time to talk about YAML, but if you see here that YAML don't like tabs, okay? So you always need to remember that the tab is something which is absolutely no for YAML, so you should not be using tab. One of the other things I quickly be touching on here is an ability to, let's say, let me show you that pod YAML. You can see that it basically has got certain areas. Now, if I put some tab intentionally, right? So if I say insert and tab, so I tabbed it, and then I save the file and try to create the pod by using this same thing, right? Same file, it's going to go ahead and give you an error because I put a tab. So you should always make sure that you don't have that tab character in the YAML. If you have it, so recreate the YAML or delete or modify the YAML, right? So with this, I think I'm pretty much covered. It's a lot of things I wanted to talk about, but I'm pretty much done with what I wanted to cover over here. So basically, this is the link. I recommend that you go back to this link, read out everything I documented. That's what I pretty much covered. It's a 20-minute session which talks about CK80 exam best practices. And I wish you all the best. Thank you very much. Any happy to answer.
Hello, everyone. Am I audible?
Ali, go ahead. You're live and people can watch you.
Okay. I am just trying to share my screen now. Give me a minute.
Right, Ali is trying to join back. Please stay on the line. He's facing some challenges. He should be in again in few moments from now. If you have any question, please feel free to put it on the chat.
Okay. So I'm trying to open my presentation right now. Just give me a minute.
Yeah, Ali, you would find an option at the bottom as share. So if you click on share, it will ask you which screen do you want to share.
Yeah, actually, it force closed my Chrome, so I lost
Oh my
that
goodness.
tab. Yeah, I'm just trying to open it up right now.
Sure. All right, so in the meantime, I would drop a link to the feedback. Feel free to share your feedback and stand a chance to win giveaways from AZConf.
Can you guys see the presentation?
Right now, yes. Go ahead, Ali.
So without any further ado, let's get started. First of all, a huge shout out to the organizers. It's really important for us to share all the information that we can so that we do the betterment for the entire community. So thank you for arranging such an awesome event. Now, moving ahead with our session for today, we are going to ponder around the question if your data is safe from exfiltration. Right now, about myself, I am Ali. I am an engineering manager at Experian. I also am pretty involved in solution architecture for my team, and my main role is to make, design, and implement big data solutions for our internal teams as well as our clients. I am a huge advocate of sharing information. I have a personal blog of myself as well. The link, you can see it on the screen. So I urge everyone to do that. Keep on spreading the knowledge. Now, before we move ahead and we dive into the question that is your data safe? Let's talk about what is data exfiltration, right? So in simple terms, data exfiltration is taking your data outside of your system in an unauthorized manner, right? Whenever we think about the term data exfiltration, whenever someone talks about it, the first thing that comes into our mind is malicious access, penetration being done by someone, right? Some hacker sitting somewhere, getting into the system, pressing some keys, typing very quickly on the keyboard, pressing enter, and voila, your data is gone, right? Most of the times that doesn't happen, we all know that. And it's a very common scenario that your data is exposed by someone who already has authorized access to the data, and that exposure is done unknowingly, right? Now, to give you an example, consider someone who is from the business end of your organization. The person has access to some reports as well as the data which is used to get to those reports. Now, the person is not able to view the reports properly on the UI that you have given access to that particular employee. And what the employee does is he or she they download that reports, download the data on their local system, have some third party tool, and then try to view those reports. So there's no intentional malicious activity that has been done, but still that counts as an exfiltration. It is an unauthorized export of data from the system. The data was supposed to stay there. It was not supposed to go out of it, right? if in case the system of that employee gets compromised, you would have no track of that data being used by that malicious user who has compromised your employee's data, because you would never know that that particular piece of data has been taken out, right? So and this particular scenario is very common. That happens in almost all the organizations around. So we have to be very sure in terms of who has what kind of an access on what type of data. We'll dive deep into that in some time. Now, before we get into the best practices of securing the data, let's talk about a few real life instances. Now, in 2021, a major telecommunications firm had 500 million records exposed. Right? It was a malicious attack. Someone got into their systems through a backdoor, and then 500 million records were exposed. In 2020, the biggest hotel chain of the world, everyone knows the name, everyone would have stayed in that hotel. They had 5.2 million records of their guests compromised. Those records were exposed. And that was actually an inside job. On further investigation by them, they found out that the login credentials of their own employees were used to get that data out. It's still not sure if it was done by those employees itself, or those credentials got compromised and this was done by someone else. In 2019, there was a big Indian PII leak. There were more than 275 million records which were available on an unprotected MongoDB instance. So someone would have scraped some website which would have all of that data, put all of those records into MongoDB, and then that MongoDB instance was publicly available for anyone over the internet to get into and see what the data is in it. It had data like the names, addresses, phone numbers, even resumes of those people. So that's how major problem data exfiltration is. Your information is not safe. In 2018, we had a major Asian airline company who had 94 million records compromised. That was a malicious attack. And in 2017, we had a leading ride-hailing company. Everyone uses that already. We had 57 million records of those commuters as well as those driver partners. Those records were compromised. That also was a malicious attack. Now, if you'd like to read more about such attacks, if you'd like to read what has happened when, what was the reason about it, feel free to visit this link which I've mentioned below. It has good UI, good visualization around those data breaches. And now, when we move on to when we have seen how big this problem is, when we have seen that how important it is for us to safeguard our data and to make sure that the data does not go outside our system, what should we do? What should we do to make sure that our data is safe, right? So these are the things that you should do. First and foremost, avoid making your blob storage, your data lake, or any other data store endpoints publicly available, right? Restrict access at the network layer itself. When you do a telnet, when you do a ping, that URL should not be reachable. A lot of times, I would say majority of the times, the data is not accessed directly by a consumer. There is some or the other form of an API, some or the other form of a web app that lies on top of your data, and that app or that UI exposes the data to the end consumers. Now, there is no need for your data to be available on the public endpoint. You can very well make it available privately only to the services which would have to access that data, right? So to do that, we would move on to the next point, right? Now, how do I make that data available privately? So the best option here is private link. Either you create a service endpoint and make sure that the service is available through that service endpoint only, or you create a private endpoint. Now, my preferred way is to move ahead with a private endpoint where you would create a private IP address of your storage account inside your VNet where all of your other applications are present. Now, what would happen is whenever any application would try to access your storage account, the application would enter the URL of your storage account, right? That URL would be routed by default to the private IP address of your private link. And that private IP address would internally then be routed to your actual storage account. So set up a private endpoint, make sure that all the data that gets accessed or that gets taken off from your data, from your database or from your blob storage or data lake, that happens through a private endpoint. Right? Now, we have made sure that the data is not publicly available. Not anyone out on the internet can access the data. What about the scenarios where an authorized user would take your data out, right? So it's really important for us to monitor what requests are coming in, what requests are going out, who exactly is allowed, what IP addresses are allowed, what FQDNs are allowed to access your data, and keep a tab of all the data which is flowing, right? Now, the best way to do that is to set up a firewall in front of your network. So from your firewall, you decide what can come in, what can go out. You would decide what particular application would access which storage account through what port number. So that's something that's highly recommended, and we all should do that, so that in case of a data breach, it's easier for us to see who has done that, where did the request originate from, what was the IP addresses, and it's easier to track who did what, right? Not that we would want to reach to that situation. Next is we should strive to stick to the least privilege principle for our identity and access management, right? Now, what does that mean? It means that provide access to a particular user, to a particular service principal, only the amount of access which is required for that particular entity, right? Many a times what we do is we create a service principal, we provide contributor access to that service principal on our entire resource group or on our entire storage account, and then we have that credentials as a single source of truth to be used all across our applications, right? That is a big no. Never do that. That is a single point of failure for you. If those credentials reach into the hands of some malicious user, you expose all of your applications, all of your data. We never want to do that. We should always make sure that the permissions that we provide are on a least privilege principle. For example, if I have a storage account, I have a queue in which I would receive messages from a third-party application, right? I would make sure that the third-party application is whitelisted in my firewall. I would make sure that connections from that third-party whitelisted application is present as a service endpoint in my storage account. And I would also make sure that the credentials that the third party use have access only to send messages to that particular storage account. So there will be an inbuilt role called storage account queue message sender. So I'll have to make sure that I use only that principle, so that the user or the third party is not able to do anything apart from just sending those messages. And that also that also applies to our data as well. So we have this concept of access control lists. So if your big data solution that you're using supports usage of access control lists, please use that. So for example, Databricks, I'm pretty sure you guys would have heard of it. Databricks can use access control lists and can restrict the privileges at a file level. So you don't have to explicitly provide access to a user at the storage account. You can provide access to the user only to a particular file or only to a particular folder. So that would be the best form of IAM that you would do. And that is something that would be a strong recommendation. Now, apart from that, use managed identities as much as possible. So if it's an application, if it's an internal Azure service which is trying to access your data, make sure you use managed identities, because it's one less credentials that you have to manage, right? It's one less piece of secret and client ID that you have to manage. So use managed identities as much as possible. You wouldn't have to worry about rotating those credentials. You don't have to worry about those credentials being leaked somewhere. Okay, let Azure manage your credentials, and you use managed identities. Finally, if you are using service principals, if you do not have any other option, make sure that you regularly rotate your service principal secrets and your user passwords, right? Add those policies, add those checks as your policies, that if a service principal secret has not been rotated, has not been refreshed in, for example, 3 months, you just kind of make that disabled, right? Azure provides that out of the box. When you create a service principal, when you create a secret, now it asks you for how much time do you want the secret to be available. So it recommends 6 months, but to have utmost security, always go for at least 3 months. You can go for lesser if you're able to manage that, but keep on rotating your secrets, keep on rotating your user passwords in 3 months at least. So next time when you log into your application, when you log into your data, and when you ponder on this question, that is my data safe from exfiltration, go through these points, check each and everything if you are following this, and I'm pretty sure if you are doing all of this, then you're pretty secure. Yeah, so that was it from my side for this session. Any questions?
Thank you so much, Ali. Looks
Thank you.
like there's not much of questions, but I request attendees to submit a quick feedback with a unique code that is shown on the screen and stand out chance to win amazing giveaways from the AZConf team.
Thank you.
Let's
Thanks,
wait
Nesh.
for a couple of more minutes, Ali. If there's any question, you'll
Definitely.
be able to answer. But at the same time, if you have questions later on while you're watching this content on YouTube or somewhere else, you could reach out to Ali Abbas on his LinkedIn and Twitter channels.
Mhm.
Hope you enjoyed the session, Ali.
Yeah, I did. I hope the viewers enjoyed the session.
Hopefully. So there are a lot of sessions since morning. So there's some more to come between now and until 6:30 p.m. today. So please stay tuned with the conference and please rate and submit your feedback. And also check out the event website where there are a lot more interesting activities going on, such as a hackathon. There are great goodies announced, and also check out the certification drive, free certification voucher. So you may qualify for that, and you could claim that certificate and do your exam. It is totally free, so please make use of that opportunity. All right, Ali, thank you so much once again.
Thank you. Thanks, everyone.
Yeah. All right. Thanks. Okay, the next session is going to come up very soon. Hey, Venkat. Thank you so much for joining us. You're live, and the stage is yours, Venkat.
Okay. Ilyas, is it possible to make the other view where my face is a little bigger and it comes on the side?
Sure. We could do that, yes.
And the slides can come on the right. Yeah. Yes, I think this should be anyone. Okay. Probably this is okay. I think this is the best. We'll leave it with this. Okay, shall I start? Okay. Good afternoon, everyone. So welcome back for yet another talk on Azure Conference. Thanks to the sponsors, we have the title sponsor and the gold sponsor and the community partners. These people have made this show really a possibility. Just to make sure you're in the right talk, the talk I'm going to be delivering in the next 1 hour is going to be on the future of software developers by 2040. This is a talk that I had given a couple of times in the past, and it had got good feedback. So I thought, let me do this again. And in the last 12 months, and rather last 18 months, a lot has happened in the world because of the pandemic. Almost all the entire software development in all the bigger companies, 90 to 95% or even more, is happening from their houses. And because of this, the communication tools have actually been improved a lot more faster. What some of the companies have been telling, what they would have taken in these collaboration tools, something like 3 to 5 years have been cut short into a period of about 12 months. That's the kind of change that has happened. So I thought it's time for me to change this talk and update it. So if you were to call this as like version 3 of this talk, there's a lot of interesting things here. So stay along with me. And if you have any feedbacks, please put it on the chat on YouTube. Let me come back and comment on them later. So what we'll be looking at is how these changes that has happened and the changes that will happen in the next 20 years will impact on the way we develop software. So my name is Venkatrangan Thirumalai. I'm a white space leader, a CEO coach, and I'm a Microsoft regional director for almost 20 years now. I don't work for Microsoft, it's an honorary title. I do work with their customers, partners, and deliver such lectures, the one that you're listening to. What qualifies me to give this particular talk? Okay, so if you're going to be spending the next 1 hour, why should you listen to me? These are my credentials. I've been in the industry for almost like 25 years. I look probably young, but that doesn't mean I haven't had my share of experience in the industry. So I've worked with clients across the globe, and I've had my own business in many countries. I've seen 4 industry cycles, 3 business cycles. What it's taught me is, when we as an engineer get into software, we think the tools, the technologies, the coding, that's what is important. But looking at this cycles, the changes that has happened in the industry, I can very well tell you, when a customer asks you to solve a problem, the technology or the coding, those are not the topmost priority for them. The most priority for them is how well you understand their business, how well you're able to solve them. That is the key thing. So with that will be kind of an underlying theme in my talk as well. And those are some of my other things that I've done. So I'll be talking about 4 things, 4 agendas in this talk in the next 45-50 minutes. First, let me look at what is the job market today for software engineering and what it's likely to be moving forward. What has happened because of the pandemic, the work from home, the remote working and all that. The third will be the technology trends. A lot of AI, ML tools are coming into how we develop software. We'll try to see some of them and maybe a demo. And then lastly, we'll talk about how do you stay relevant in this changing scenario where if there is an industry that is changing more than ever, more faster than any other industry, it is the industry of software engineering. We are the ones who are creating this change. We are the ones who are disrupting the industry, but we are also disrupting the way our own jobs are done. So it's very key to understand what are those changes and how do we stay relevant. I'll give you a clue on how you can stay relevant by something that I call as cola. It's not the Coca-Cola that you drink. It's COLA. Let me explain what it is. So if you stay with me, you can here, what is Cola and how do you use it to stay relevant? Let me start with a story. And that's me about 28 years, I suppose, back in my college. Those are my classmates that you see in the picture. And that's our computer science lab. I studied my electronics and communication engineering in a college in Chennai. And these are the old computers, those kind of the CRT monitors and all that. So what we were doing, I think this was in a Pascal lab that we were sitting, and we are coding. So Pascal and Fortran were what we had in our syllabus way back in 93, 94 when I studied, and this picture should have been taken. So you had those Turbo Pascal compilers. Okay, I know many of you, or almost all of you listening, wouldn't have even seen it. It's those orange or green screen CRT monitors and your Turbo Pascal compiler. And today we call it as pair programming, but in college, as you all know, and especially in those days, you didn't have one computer for every student. So we had two people sharing a computer. So the way it kind of works is, in one of the weeks, I'll be using the computer, and my partner, who comes next in the alphabetical order, he'll be helping me and guiding. And the next week, we'll switch roles and do that kind of the principles that are taken into pair programming. So my classmate who used to sit with me we'll call him UD. So when I keep typing, the way I write code, I try to write the outline, kind of the flow in any language that I program, and then keep filling in the details as we move along. So I'll be just typing a kind of pseudocode, probably in loose Pascal. And UD will next to me keep telling, oh, that's a variable undeclared, or the integer over bound, and so on and so forth. It's like a real-time compilation error that he will keep giving me. And those days, the tools didn't have those capabilities. This was in MS-DOS. You didn't have even probably multi-threading. So the tools or the frameworks, the compilers didn't have reflections to do what your modern compilers can do. Something like today in your Visual Studio Code, with even simple Python with pylint, as you keep typing a code, you are going to see both good practices being shown, what are you missing, and also sometimes compiler errors also will be getting in real time. Those are available in today's development tools, but in those days that didn't have. But I had a person sitting next to me, UD, who was able to give it to me. It was irritating. So most often I'll say, I used to call him as compiler, and that name kind of stuck with him for the next 4 years in the college. And I'll say, compiler, just be quiet. Don't give the compiler errors. So the point I'm saying is, those days the tools didn't have it. It was all human intelligence. The coder had to figure out a lot of these things. Otherwise, if you do a mistake, you compile. It's not like your punch card days where you have to wait for hours or days. But then still, it was a couple of minutes before the compiler will start, run, give us the error, and then we'll have to do. But the whole lab will be kind of for 60 minutes or 90 minutes. So, but today, we have very sophisticated tools, and some of them we'll be seeing in the talk as we move along, which can do a lot more interesting things. And that's the progress that we have come in the last 20, 30 years. And that's why it makes me really excited to kind of foresee what's going to happen in the next 20 years. So the first one, this I think pretty much all of us who are listening, you can relate to, especially in the pandemic in the last 18 months. It's very clear, if software is eating the world, the developers are changing the world. It's very clear. We are the ones who are making those new world. Whether it is vaccine development or whether it is diagnosis, even when you go to a COVID test today and you get your reports, at every stage, there is an application, there is a software that is involved. And at the vaccine development, a lot of things like Pfizer had used, and they had written a white paper on the kind of machine language tools that they used so that they could develop this vaccine in months. By the time the virus was discovered in January, they had a working prototype of this vaccine like in April, May. And then they tested it for the next 6 months before Christmas time, they could be giving it to people. And at every stage, software and applications and machine learning was extensively used. They were collecting, like, I think, millions of data points at the virus vaccine manufacturing at the early stages. And even in the trials, the amount of data they were collecting with thousands of their trial patients were humongous. And they couldn't have done it without software and at this speed. So at every stage, developers are involved. Software is involved in today's world. And even at the vaccine rollouts, you have your COVID portal and the certificates, and that's a software that is working like nearly billion people are able to take their vaccines and get certificates within minutes or even seconds because of the COVID software. These are just examples. Everywhere in the world, you have examples that have been done by software and developers. So let's remember that. Keep that at the back of your mind in the next 30-40 minutes you're listening to this talk. This is a very interesting quote I read from a Microsoft research paper. I'll give you a link at the end. This person, Ben Zon, is a partner researcher. He says, if you think about the world that we are in now, software plays a key role in our lives and everything we do. That's what we saw in the last slide. At the same time, there is also kind of a corollary to that, is that if that is true, then if we make software better, then we are actually making all the things that depend on software better, which means today, if each one of us are able to write a better software, faster software, error-free software, and which solves the business problem better, we are actually solving the world problems. We are helping the world be a better place. It's not a cliche. It's actually today very, very true, because everything is software. And let me just reread the line. If we make software better, we can make all the things that depend on software better. Just very, very key, insightful thoughts there. But at the same time, you look at it, one of the statistics in India says that there are 63 million micro and small medium enterprises in the country. They are the backbone of Indian economy. It's not your large enterprises. It's not your Reliances and Tatas and your Airtels, which actually make up Indian economy. These companies are important, but the ones that are actually ticking India and the ones who are getting back on their feet, one which are helping India to grow again, are these 63 million small, medium enterprises. And they're all probably single, couple or 10 people companies. And each one of them today are using some kind of software, and they'll be more using it. And even if we have to take that each one of them requires one application, we are talking there needs to be about 63 million applications. It's a not one-to-one correlation, but I'm just making a point here. Millions and millions of software had to be written, apps have to be written for these companies only in India. Do we have those kind of graduates coming out of India every year? We probably are not. There's only 0.9, about 1 million computer science graduates passing out of Indian colleges today. And some of them go abroad as well. And some of them go to attrition. Some of them go into other industries as well. So from a base of 36 million graduates that India produces across disciplines, we are having only 1 million that come into computer science. Whereas we said there are 63 million applications at the bare minimum that needs by these businesses. Again, some of them may have the application that they wrote last year, they will be using it, but that's, you get the quantum, you get the idea. So what do we do? A lot of new technologies are coming like low code, no code, which we'll try to see later. But the point is there is not enough software engineers out there, which is not surprising. And especially in the growth that all the software companies are making today with your Infosys, TCS, and your Wipros growing in 25-30% year over year. And all these companies hiring in thousands freshers, graduates every year. One of the recent Economic Times articles said about 150,000 fresh graduates are being hired in this financial year alone. Think about that number. It's 1.5 lakh fresh graduates coming in. And HCL, which offered in 2013 Mercedes-Benz for the employees, are again offering that. The attritions, are also big numbers, which we'll see next. But the point is, there is a huge demand of people who can write software. And today is the best time to be in software industry. If any of you have been thinking whether you should be getting into software industry, I think you should, because the next few years is going to be great. This again is statistics from the register. Most of my slides have the link and the reference that I used at the bottom. So when you're listening to this talk later in YouTube, you can actually go back and Google them and find out more information. So these are the top 4 IT service companies in India. And as you can see, the attrition, let's focus on the green column, so the last two. HCL had about 15% and Wipro had about 20%, 20.5%. I read an article today in Economic Times that said Cognizant had about 30%. And that's an interesting term they use also, voluntary LTM. So let's leave those fun of the industry later. But the point is there is about 20 to 30% attrition. So some of that could be to the pandemic-induced stress, or most of that, when I talk to people in the HR departments of these companies, it is because they have so much opportunity for growth, which you'll also see how the growth happens now. Something that I call as lateral movement, lateral career progression. But the point is that is 30%. And look at the number of freshers being hired in this quarter. It's amazing. About 11,000 freshers hiring, new hires that are done in this quarter by HCL alone. You multiply it by 4, that's about 40,000. For TCS, it's about 80,000 people are being hired this year. These are staggering numbers. Okay, but the point, every good thing doesn't last. Good things do come to an end. But in this case, one of the statistics that said, again in Economic Times, that said domestic software firms who employ more than 60 million are going to slash their headcounts massively by 3 million by 2020, which is next year. It's not too far. Okay, and the reason is automation. We'll see more data on why it is so. But they are going to slash their headcounts. At the same time, they are hiring in thousands now. So what's kind of happening? The way they are seeing in the last 18 months, they had such a big of backlog and demand because of pandemic, every business becoming a software one, that they are hiring. At the same time, they are also planning to slash headcounts in the next couple of years because they think the technologies and tools are going to improve productivity, which will mean they can leave the attrition and don't need to backfill those in the coming years. That's what I think will be happening. One other trend which is happening, you can research in that also. A lot of those companies which earlier outsourced to the Indian biggies, Indian IT biggies like your Infosys, TCS, etc., those companies, those MNCs, those American or multinational companies are now, instead of giving it to your TCS and Infosys, are setting up their own global development centers in India. This is a trend that happened in late 90s, kind of went back in the last 10, 15 years, but then it's coming back again now because software is becoming integral to every business, which means they don't want to give their secret. Software is their secret today, and they don't want to give their secret sauces to your IT service companies. They want to do it in-house, and with the AML, which means these algorithms have to work on data, which is very important for these companies, which they don't want outside, and also because the time in which these algorithms can work and give you results and your business impact had to be really, really, really fast. And that you can only do if you are doing it in-house. You can't be outsourcing with a change request, a software requirement document being written and moved around across the world and so on and so forth. That's not going to work. So you have to do in-house, which means there is a lot more employment being available from these companies directly. And there is going to be growth, but which also means not only you need to be good in the software, you also need to understand the business, which is a theme that I'll be covering a little later as well. So what's going to happen? This is a study by McKinsey. Again, the links are available at the bottom. If you look at it, the jobs, this study by McKinsey actually split it into men and women. Okay, there is no bias, but you will get an idea as I move along the slide, you will understand. China is going to be having about 66% of their job, men's job, or jobs in which men are working, going to be displaced by automation by 2030, in the next 10 years. Okay, India is going to be having 44. It's not like we are good. It's still 44% is actually a really 44 million is actually big number for a country like India. And some of these jobs, not all of them obviously are into software development. Some of them, or most of them, will be in your manufacturing and textile and the other industries. If you look at women, about 52 million jobs in China are going to be where women are employed, are going to be displaced by automation. Again, when I use automation, it's not only the technology or development automation or RPAs that we are familiar. It's automation and robotics and so on and so forth. It's not only the RPAs that we are familiar with. India is going to have about 12 million women displaced. Again, if you look detailed into the report, it's not all good news because these 12 million jobs that women are doing are already low-paid jobs. And if they are going to be replaced by automation, those women at the lower strata of society who are finding it difficult to survive, they are going to have a tough time. So this is the reality. As we write these tools that automate and robotics develop, there are going to be jobs that are lost. Okay, which means those people who are able to study and graduate, which is very must, you should get into software so that you can develop these tools. So that's one side of it, what's happening with the job market. Let's switch gears and see what has happened for work from home trend that has happened in the last 12-18 months, and will it stick as we get out of the pandemic at some point in time? Okay, so this is an interesting statistic. I love statistics. I love these graphs, infograph. It helps you to convey a point a lot more easier and quicker than doing many slides with lots of text. If you see, from May 2020, when the survey was first done, to July 2021, this is for the United States. I'm sure it's going to be very similar to other countries. Probably in India, the manufacturing might show a difference, but then more or less it will give you the same idea, especially in the top jobs, which are more jobs that you do in the office, kind of the white collar jobs. So if you look at the first one, computer and mathematical, that's probably where all the software engineering part comes. If you look at it, in May 2020, 49% of the occupants in the US were working from home. And that's immediately after the pandemic. And that number, 76% has been working for work from home, because that's how the pandemic started in it, and everybody lockdowns and all that. In the last 1.5 years, the number has come down, but not come down drastically. It is at 49%. So still nearly about 50% of people in software development are working in the US, still work from home. And if you take the larger companies like your Microsofts and Google and Facebooks, almost all of them haven't opened their offices yet, or they have opened only for very key roles. And that's the trend that we have seen in the last 18 months. What's also happened, this is another way of looking at the data. This is the new job openings that are being posted in Hacker News, which has the keyword both remote and on-site, or if that is the thing you run a query, you look at it in 2012 onwards up to 2020, there was about 20% of the jobs, 20 to 30% of the jobs that said you can work remotely. It's not insignificant, but it hasn't grown significantly, because it was like 15% in 12, and in the last 8 years, it became 30%, kind of double, which is significant, which is substantial, but not as big as what it became because of the lockdowns and all. Today, as on August 2021, 77% of the job postings had the word remote. So which means you can work anywhere from the world, which also means you can apply for a company that's in, say, US only. And earlier you had to have a US visa and all that. Today you can work for that US company sitting in India, sitting in your tier 2, tier 3, or in your village if you have a broadband connectivity. And you can apply for the job and work for them, and probably, hopefully, and I wish I did like that, earn in dollars. Okay, nothing is better than earning in dollars and living in India and spending in rupees. Okay, you could probably go to a country which has a more cost of living, like Sri Lanka or Nepal. You might be even able to save more, but then we'll stick to India. So 77% of the jobs in Hacker News had the keyword remote, and you could work remotely. And also those which said on-site, which means you have to work in the office, was only 25%. And this was like 75% earlier, and that's come down to 25%. It has become 1/3. It has reduced like 70%. That's huge. So more companies are asking you to work remote than on-site. It saves, especially in the Western countries where visas are becoming difficult. They said, why should I fight with all this? Let me get the employees working wherever they are by just asking them to work remotely. Having said that, this is a book that I read about 10 years back. Scott Berken, if you haven't read, he was earlier a project manager at Microsoft, a wonderful book. He has also written a new book today, this year, about designing. You should look at his, read his books. This one is a very fascinating book. This he wrote about in 10 years back, 2020 or 2011, where he worked for a year as a project manager for the company that powers WordPress. Automatic is the company's name. And even that time, this company didn't have offices. They had just had one small satellite office in San Francisco. But all their work, they had employees working remotely across 18 countries, if I remember right. And all of them were communicating through what those days they had their IRCs and pre-Slack tools and all that. And Scott Beckham wanted to learn how this company functions. So he worked for them for a year with an explicit mandate that he'll write a book. And that's the book, Year Without Pants. And that's a familiar theme, all of us this year, right? All of us There are memes that talk about people not wearing trousers. They are just in the shorts and things like that, because you only get to see your upper half of your body in video calls like this one. But the joke aside, that company has made it powerful. WordPress is powering about 30% of the web. There are like millions of websites that are running on WordPress, and they are able to work completely remote, even in 2011. And think what they could have been doing in the last 10 years. This is a native company that knows how to take advantage of remote working. So read that book. You'll have lots of points on how you can make remote working more effective and learn from that for your own companies. But the point is, we saw remote working and working from your home is a theme that has happened in the pandemic. But is it here to stay? The answer is emphatic yes. Companies like Twitter and Facebook have said it's very unlikely they will ask their people to come back or force people to come back to office. They'll be welcome at some point after the pandemic, but they are going to give the option of people to be working entirely from their houses. Even companies like Shipsy and Tata Steel, if you think of a company that emphasizes, that symbolizes the old economy like Tata Steel, they are saying those people who are having a white collar job, and I think probably they define the job roles, they can work from their house remotely forever. They don't need to come back to the offices. And that is the trend. And that also means this is here to stay. So you have to start adapting. Please don't wait that this remote working will go and I can go back to those offices. Probably those days are not coming. People will be going back to office, but those numbers will be very, very small. You will be having the options to work remote. So if you're looking for a job, if you're looking for change, start looking out for a job that allows you to work remotely so that you don't need to relocate every time. And I was curious. Those were data that I studied from papers and all. I interviewed before this talk in the last couple of weeks. My friends who are working in the large IT service companies in India. And this is the kind of the consensus I got from talking to a few of them. They're saying about 1/3 of the jobs are going to be posted entirely for remote working. They're going to be posting these jobs and saying, we are going to be taking jobs for remote. For tax purposes, you will be allocated to a Pune office or a Bangalore office or a Bombay office, so on and so forth. But then you will be assured you can work remotely. You don't need to come. And this may not be for all the jobs, but about 1/3 of the jobs are going to be kept for remote. And companies are not doing it for altruistic reasons also. They are saying, I find it so difficult, Venkat, to find employees, say, in the NCR region or in Bombay alone. I need to tap pan-India. There are a lot of developers in small towns like Udupi or Madurai or Lucknow. Lucknow is not a small town, but from the metro's perspective, IT perspective, those towns or cities we haven't heard of, but those are the cities that are going to give you the new software development people that are going to power India. And they are not going to relocate to metros, not all of them. And we don't want them in the metros also, right? Why should their quality of life be affected by traffic and all that? And the cost. Everybody comes to Bangalore. Remember the cost of apartments in Bangalore. So this 30 to 40% of people post-pandemic are also going to work entirely remote. You don't believe me? Open your browser now, go to Naukri and search for remote jobs. Naukri has a special option now, which actually says to search for jobs that are remote only. And that's not only with Naukri, Monster and Indeed and all the job sites that you go are going to be having this remote only option. And that's the way you can tap into these talents. We'll switch gear. Now I have come to the third part of my talk. If you recall, I said 4. Last one is how do you keep up with these times? What do you do to stay ahead in this game for the next 20 years? The third part, of course, is the technology, AI, automation. We'll see some examples. This is a very interesting image that I saw in Economist rather. It shows a robot picking up a cup of cola or a chocolate pretty deftly. It's not dropping it at all, but the arms it's probably sharp and the cola is pouring down. It's like Operation Success, the patient dead. The robot is able to pick it up, but then it's applying too much pressure probably. The other way of looking at it is an engineering perspective. You haven't designed the cup strong enough for the robots to pick. But then if you design the cup for the robots, can humans handle it? Those are questions that will come up. But anyway, today these tools that automation and AI are not as stupid as this. These tools are really good and they are delivering, which we'll see in the next few slides. Low code, no code. This is an area that I've been doing a lot of work in the last 1-2 years. I've been studying from Power Apps to Zoho creators to AWS Honeycodes and Google App Sheets and all that. There are a lot of low code and no code solutions that are available now. And why are they so? If you think about it, why are they so? Each company that was surveyed by Okta Inc. and it was published in a Microsoft site also, that said, there are at least 129 applications, each company on an average, and some of them have over 200 applications. These are even small companies, small and medium companies. And to develop each one of these applications, either internally or by professional folks outside, costs about $45,000 per application. That's a lot of money. That's about half a year's salary for a qualified engineer in the US, a software engineer. So about 200 apps. How are you going to develop them? How are you going to manage them? And how are you going to update them with latest frameworks coming up and so on and so forth? That's where low code, no code really comes in, because you can, if you go back to my earlier slide about several million graduates coming out of Indian colleges, all of them are bright students. Only 0.9 are taking computer science, but all those millions of graduates are smart. And if you can empower them to write software, they can solve their business problems themselves. That is where low code and no code comes in. And if these people are being able to be trained on, say, something like Power Apps, they can write their business applications themselves. Does it make them a software engineer? Does it make them a software developer? Certainly a software developer. I'm not sure about the software engineering part, but they are ones who are developing software, so they are software developers. And that's the way to go. You will find more and more people developing software for their own use, for their small business use and all that. Let's take a look at this. This is the codex from OpenAI. Many of you might have seen this demos. If you've not, just go to openai.com and look at OpenAI, the codex demo. It's a small 5 minutes video. It's really fascinating. You should look at it. And this is the ones we have all heard about, the GPT-3 NLP models that was trained by OpenAI and released, which could do a lot of intelligent understanding of language and even generation of text and prose and all that. Using that model, they had trained it on a little bit amount of code, and they found it was working for source code also. And they improved on it. They gave it millions and millions of lines of code, millions of data points to be trained on, and they trained on it. And this is the demo. It's not out. It's not available. It's only available for limited people for usage. But the video talks about this example. You just add this image of a rocket ship, and you give the URL in which the image is present. You're not writing any piece of code. There's only English here. If you do this, you get this output. Okay, and you see the code on the right-hand side. Add this image of a rocket ship. We gave that. That's the comment or the instruction. We gave it to the system codex, and it was able to come up with the output. Write it in JavaScript. Var rocket ship is equal to document.create element and all that. Basically, and it's output the image. And in the next step, we said make it smallish. We don't say make it smaller. We said make it be smallish. Kind of a weird English, grammatically probably not correct, but then it understood and it gave the output of the code to make that image as 100 pixel by 100 pixel. Next, we said crop it circularly, and then it gave the border radius is equal to 50%. Okay, I'm not taking a dig at Windows 11 rounded corners and all that. I use it. I love it. But this is just a sample that Codex have got it. Okay, so and you see the output on the top. Crop it circularly. It's able to do. And this whole demo kind of develops this small thing into actually a small game that you can kind of play with. It's pretty interesting. Just by giving commands, you're able to generate a working piece of code that you can take it and use it elsewhere. Does it mean software engineers are not going to be having any jobs? It's not so, as we'll see. This is a kind of a tool that is going to improve your productivity. It's not about taking jobs away. It is actually improving you, generate more code, write more applications, make you very productive. That's an example from Codex. And these tools are not perfect, obviously, and they are going to take times. Probably my estimate in the next 10 years, by 2030, these tools will be really, really good. And we'll be wondering, or at that 2030 time, we'll not be writing code manually entirely. Majority of the code that we write would have been generated by a software system like Codex, and they would have grown exponentially. Remember, AML doesn't grow every year incrementally. They grow exponentially. And that's a graph We humans actually have a problem understanding. These become so, don't have your experience of your Siris and Google Assistants not so great affect what will happen in this area. The way the software generation, code generation tools are going to develop in the next 10, 20 years is going to be phenomenal. Okay, and this is the example by Codex. It's not perfect, just to show that. Just the comment we wrote: add 3 to y, then subtract 4 from both x and w. There are 4 variables, so you wanted 3 to be added to y, 4 subtracted from both x and w. That means you have touched 3 variables. Then return the product of all the 4 numbers as your return value. But if you see the Python code that was generated, there are 2 things that was missed, right? It was not multiplying all the 4 numbers, which is what we wanted. It was only multiplying z and w. We actually wanted to multiply x and y as well. Okay, and it was not subtracting 4 from w as well. So 2 things it missed. And again, these are very, very early days. So the point is, these tools are not perfect today, but they're going to become so perfect by 2030 or 2040. Majority or almost all the code that we write will be generated by systems like this. This is Microsoft GitHub's Copilot service. It's available today. I got access to my, couple of hours back, I got access to my technical preview. I'll try to show you live in the next slide. But this is how this tool works. This Copilot, whatever I said about Codex earlier, is true for Copilot, because Copilot is based on the OpenAI Codex model that Microsoft has licensed from OpenAI. And they've trained it on millions and millions of open source projects on GitHub. These are not private repositories. There were rumors on Microsoft is taking code from my private repositories, nothing like that. These are only public repositories that it has used to train, and it's not reproducing a code snippet. Remember, it's not like a find copy paste. It's not autocomplete. It's actually using those code to learn and generate this. Whatever code that Copilot generates is your own copy. It's your own license. You can use it for whatever you want. There's nothing you need to license it from Microsoft or GitHub or anything, because that piece of code has not been generated ever before for anybody else. It's uniquely generated for you on the data points that you have given, but based on millions and millions of lines of code that it has read from and trained on the Codex model. So how does it work? This is an example. Okay, let me try to do the live coding. I'll take the risk of doing this. Okay, let me go to my Visual Studio Code. Hopefully, I guess it's visible for you. Okay, so let's take it out. Let's write a comment. Okay, let me say subtract 2 numbers. Okay, and return the result. If you notice, I didn't type and return the. Okay. Let me switch. I think it's not. Yeah, okay, fine. So if you notice, the return result actually auto-completed for me. Let's do that. And let's see what comes here. This is what you shouldn't be experimenting with. It should be actually popping up with the Copilot recommendations for me. Let's try it again one last time. Yeah. If you see, it's able to produce this code for me at every stage. It's giving me those recommendations, right? It's a bit finicky. Earlier in the morning when I tried, it actually generated this piece of code automatically for me. But even now, you can get the idea of it. Let's try one more. Let me use this, whatever I had. Okay, read a file and return a list of lines. Okay, let's try that. Okay, read a file, return the number of lines. In characters, wow, in the file. Oh, it's giving me more choices. Okay. It does take a bit of time. Okay. Sometimes you need to wait. Yeah, now you see it. It's able to tell me the entire piece of code that I would have wanted. It's fascinating if you think about it. It has done everything correct. It has opened the file, read the number of lines. It hasn't given the number of characters though. Maybe it will. Yeah, yes, it is showing. It takes a bit of time. It's not as fast as what you would have wanted. Yeah, but you get the idea. Basically, it's able to generate this. And as these tools become better and better, as more people start using it, you'll find these tools like Copilot becoming really useful. Think about it. Most of the time when we want to write a piece of code, we don't know the syntax of something. How many times you would have opened a file in Python? May not be. That's not what you're doing every day. You're just writing Python for the day. You don't know how to open a file. You know the Python syntax, you know everything, but you don't know this syntax. You have to then Google, pick up the source code, copy paste, and all that. This is going to save you time because there's nothing proprietary in the way you open a file or count number of lines in a Python code. Every Python developer is going to do that. So why do that repetitive task? Why don't you give it to the A and ML that's powering Copilot to do that job for you? And in this way, you're going to be having lesser bugs because these are the code that's probably being tested. So it's going to work better for you. So that's Copilot. It's hot from the plate, as they say it, because only today morning, as I said, I got the access to the technical preview. Okay, so let's move on. Okay, so what are the benefits for something like Copilot? The benefits today, Copilot benefits are it can convert your comments to code. You can do a data structure, say in JavaScript, and it can generate the entire function, that is to read and write those values that are available. It can generate it for you. It will autofill repetitive code, which we saw. It can also do the test. There are some tools, not only from Microsoft, but from others, which allow you to do the testing, both unit testing and functional testing, without you doing the bulk of the code. And it also provides you alternate approaches. If you have been used to writing or opening a file, like in this Python example, in one way, it would have provided you an alternate way, and you will be able to circle back between multiple ways in which you can open a file. You wouldn't have known those different types of code to open a file. Those would know. So you can pick up the best. And this will also avoid you missing out some important step, like not closing a file handle or improperly opening a file that you're not supposed to open because you had closed it earlier. Those kind of typical errors, or your SQL Server, SQL injection errors, all those are not going to happen because the code that is being generated has been learned from millions and millions of lines of code from millions of projects, and it's likely to be good. And you also have those tools that we look at in the testing will help you to identify problems in these code. So your code that you are now writing will be a lot more better. It's not only from Microsoft. There is a tool called Kite for Python. If you go to kite.com, this is a system they already have for the last couple of years, which does something like Copilot, but not to the extent. This is more an autocomplete version. Copilot takes it to the next level. But then today, if you want to use, you can try out Kite for Python. It's pretty interesting. Some of the large data types you want to handle, you want to manipulate them. Having something like Kite, I have found it to be really useful. You don't need to remember all the syntax in your head. There is also a project in Microsoft called CodeBird. I'll give you links to these, or if you search Microsoft Research for CodeBird. This actually tells you to not only complete code, it actually does a summary of your code, which is very useful, because when you're going through somebody else's code, we all know it's probably easier writing a new piece of code than to read somebody else's code. And especially, even if it's your code written 5 years back, to read it now and understand, you will find it really difficult. I write a blog for about 16, 17 years now, about 4,000 posts. I read my blog post written 10, 15 years back, and I wonder, because on some of the points that I've said there, it's not because they are great, it's because I don't remember many of them. Okay, so it's very difficult to go back the code or read somebody else's code. And this kind of summary tool, which will take your code and then summarize. In the second example at the bottom for the concatenate, this CodeBird is able to take it and then give you a command, concatenate two arrays. It's not great, but it's very useful. Without reading all the lines of code and understanding what's happening, what is being incremented and counted and all that, you just get a summary. So you can understand this code a lot more faster. It is again not perfect today, but then my point is this is the direction in which we are moving. Code is being generated, code is being summarized, your code is being explained to you. These are where you are able, if you're able to see a theme here, I'll be happy. The theme is, these are the tools that are augmenting your capabilities, improving your productivity. There's this tool from Microsoft AI Labs. Again, the link is at the bottom, called Sketch to Code. You just sketch in your whiteboard, and it's able to generate HTML for you on the right-hand side. And it also tells you the model, why it predicted that. It's very interesting to learn. And if you're working on image visioning and computer vision and all that, this sample is very good to understand why it's able to predict what you have drawn as a box, as a image and all that. Very interesting. And it's also saying its confidence level, typical computer vision stuff. And on the right hand side, it's generate HTML. Think about these tools becoming better and better. They'll be able to generate XAML, they'll be able to generate React for you. Already startups are working on those things. So that's the way in which going. So if you want to write an MVP, you use your code generator tools, you use these tools like that, by the evening, you will be able to have an MVP. Again, remember, I'm not saying there will be no software development. It will give you a head start. Again, you have to take that code and improve it yourself. There's a lot of work that has to be done on top of it, but you won't be starting from a blank page. That's my point. These tools, remember, are not replacing your job. These tools are going to be augmenting your jobs. That's why I said by 2030, 2040, the amount of code that you write yourself manually will be very less. Most of them will be computer generated, but you are the ones who are supplying it with the intelligence. This is a thing from Google. Very interesting. You should check it out. There's a video on YouTube also of it. I found it really interesting. You all to video. You give it a URL of a page, a blog or a news article with images preferably, and it's able to generate a video out of it. Kind of a summary, like how the code bird in Microsoft example, research example, was able to summarize the code, was able to summarize a web page and into a shorter video. Google is an ad company, so they want you to generate ads. They want you to have video ads, and they want to help you to generate those advertisement banners. But at the end of the day, look at it. It's able to, the system is able to figure out, the AI system is able to figure out what is important in this particular page, and it has also reassembled the elements. From a landscape, it is able to make it into portrait. It's able to figure out what is the important text. It is not doing the smaller text in the page and all that. It's able to understand all this and able to generate a video. It's kind of a summary. The message that I see here is it's able to summarize a web page into something that is more graphical, more easily able to be understandable by you. This is a tool by Microsoft Lab again, called Code Effect. You can go and see it. It's learned from lots of open source projects. And if you give it a source code in, say, GitHub, it's able to tell you that these are the areas, these are the files that are having problems. It's very interesting. It's not only a static analyzer tools that we are commonly using in your job. It's something more than that. It's able to learn from the bugs that others had in their code and able to warn you that your code could be having those problems. And it's very interesting. And it also classifies your bugs into high risk bugs, low risk bugs, and so on and so forth. There's a third-party company, a startup called Functionize. You should check it out. They're having a product. If you give it a web page, it's able to tell problems in the CSS. It uses computer vision. It has multiple other things, but I found it interesting, the computer vision part. If you see, the text that I see in this web page is instant graph savings on the top nav bar, but actually should be big savings. The CSS is doing a bad job here. Probably I'm hiding, or the big saving is hidden by instant savings, or these should be two different things. But the point is the big savings is not visible. This, if you don't physically see this page or a human sees it, you won't be able to identify this problem. But Functionize, it's able to do it because it combines computer vision with AI models and able to look at multiples of CSS that are available out there and then do a recommendation for you. These are the kind of tools that are even now available. Lastly, before we close this section and move to the last part of my talk, Q Sharp. Today in the morning, there was a beautiful talk on quantum, on exposition and superposition and quantum bits in the same track. If you have listened to it, you will find this simple. I'm not going to be explaining you, but the point is there is a piece of Q Sharp code on the right-hand side, left-hand side, which to me looks like C Sharp. So, but it is Q Sharp because it is managing on quantum. On the right-hand side, you see is a quantum computer that Microsoft has got it at extremely low temperature. Probably it's like minus 100, minus 200 degrees Celsius or something ridiculous like that. And that's a quantum computer, and you're having quantum bits, and you're able to write a code to generate a random bit. And the code, if you look at it in the Microsoft website for Q Sharp, it will actually go to generate a quantum number, random number by quantum. That random number, today we know random numbers maybe at certain point in time, if you're not careful and certain conditions and all that. But with this, the random number is guaranteed to be random and unique because it is based on quantum superpositions. Okay, so because the scale in which these operate are again very, very large. Those are going to be coming in the next 10-20 years. By 2030, or at least if not 2040, we will all be using quantum. We won't be running quantum computers in our houses. It doesn't work that way. In the clouds or somewhere, quantum computers will be running and we'll be writing programs. Not again, remember, those of you who have a fairly bit of understanding of quantum, you'll know quantum computers will not be replacing our traditional binary computers. Binary computers will continue to work, digital computers, and quantum computers will be doing those critical cryptographic and random numbers, those very, very key part. And your digital computers will continue to do their jobs, which we are familiar with. But this is also coming in the next 10-20 years. So the kind of summarizing the third part of my talk, AI-based tools will help you improve your quality dramatically. You can't give the excuse that I'm moving fast or I'm failing fast. No, even if you are moving fast, companies and businesses will expect you to be without errors because the tools will be able to warn you that you're going to fail. So no more move fast and fail fast in the next 10-20 years. That's the trend. Every piece of code that you write will be expected to run properly. And if your organization follows pair programming, your partners will be assigned to you by AI systems, which will see, oh, A and B are writing similarly. So that's a best productivity to move them, both pair them into pair programming, or move A and C, who are having completely different way of writing code, to be put into the same project, because that way the project will get the maximum innovation. Scrum backlogs, which your managers are assigning today, will be done by AI. The managers will not be assigning those tasks to you anymore. Again, I'm just throwing up some of the ways in which typical software development will be impacted. Some of them are already happening, and most of them are going to happen in the next decade or so. And these systems will also be able to identify duplication, so that two people writing the same piece of code in the organization, which is always has been a kind of a want in computer systems. You don't need to do that. Systems will be able to spot it for you and tell you. And these are some of the links that are so beautiful. If you have access to IEEE magazines, go to IEEE Software July-August 2020 issue. It has a whole issue talking about intersection of AI and software engineering. Some of the points in this talk has been taken from that as well. And the Microsoft portions are from the link that I'm referring there, called Research Collection of Creating the Future of Software Development by Microsoft Research. Lastly, how to stay relevant. This is what I call COLA. As I said, it's not your Coca-Cola that you drink. It's called what I call as the continuous learning and then augmenting your skills. It's very clear you have to continuously learn this world. The next 10-20 years, if one thing that's going to be constant and for sure is going to be, you got to be continuously learning. And these AI tools are going to be helping you to augment your skills. Okay. So we'll see next few slides, and probably hopefully I can take one or two questions. Work involved in software development today. There are three large portions that people talk in the software engineering side. Business requirement, customer study. Today, that takes about 50% of the time. If you're not doing 50% of your time in business requirement and customer study, something is wrong. Okay, today that's the number. Only 20% is done in coding, testing, deployment. Architecture, design, mapping requirements is about 30. The typical software architect role, etc. 50, 30, 20. This is what is happening today, and this is kind of an ideal number. Again, each organization will have different. If you're writing something at the kernel level, this number will be completely skewed towards coding, because business requirements in a kernel development is very, very less. But the point is, this is what typical software today has, and this is going to change. Not change with coding taking more or something like that. When I say upside down, coding is going to become even more lesser, because the system is going to generate the code, like we saw with your codex, etc. Testing is also going to be automated. AI is going to do deployment. You will never ever, in the next 10 years, if I can be sure of one thing, you will never deploy your code anywhere. There is no such concept of you deploying your code, because the deployment would have become so complex that your code will be running in different computers, different clouds, with humongous amount of infrastructure, scaffolding and all that, and fault tolerance, error, security and all that. Manually, you won't be able to deploy code. Only systems will be able to do that. Okay, so it will become even more lesser, and the time that you save in the architecture, in the coding, will be taken over by business requirement. I call it as talking to the customer. That's why I have the image at the left. The time that you save by these coding and the testing job that you do will be spent in talking to the customer, empathizing with them, understanding their business requirement, thinking. We don't, with your TikToks and YouTube, we don't do much of thinking, but you'll be forced to think. You will be forced to innovate. That's where you will spend most of your time. And two things that you can do. One is, there is no lifelong jobs anymore. If you're thinking you can join, say, TCS and retire from TCS in 30 years, or Infosys or Wipro or Microsoft or any company like that, forget it. There's not going to be lifelong jobs. You might be with the same company, but you may not be doing the same job. That's gone in any industry, more so in software industry. If you're starting as a developer or with, say, C#, I can assure you that in the next 5 years, 10 years, you are neither going to be a software developer nor going to write C#. Okay, it's going to change, because that's how our system is changing so rapidly, and it's only going to accelerate. There's a beautiful example. A friend of mine talks about carrier being in auto drive versus sports mode. You have your Audis and the BMWs having auto drive, which we are all familiar. You don't need to switch the gears, it automatically switches. And the sports mode, it's not manual mode, it's called sports mode, where it gives you the power of manual mode, the control, but also gives you the flexibility and the comfort of auto drive. So it's a combination. So you will have to start, you will be coding, you will be writing code, or you will be generating software, you will be testing, but then these systems will be augmenting it, and you will be in kind of a sports mode. So that's what I call as the manual plus auto drive thing. You'll be able to continuously learn, unlearn, and learn. Be prepared for it. Last week, I joined on a course on Udacity to learn a new programming language, just for the sake of it. Otherwise, I won't be able to talk to the youngsters. When I'm interviewing them, most of them are probably years ahead of me in many of these tools. If I have to keep pace with them, which is very, very difficult, I have to first unlearn that a lot of things that didn't work 10 years doesn't mean they won't work now. So a lot of unlearning, and you have to become a person of gathering of information than just memorizing things. And as I said, you will be talking to customers more, you will be empathizing with them, you will be thinking, which means apart from software, you also have to understand business, marketing, sales, sociology, psychology, and all that. Lastly, be truly global, because that's the world we are getting into. Remote working, if you're working for a company, say in Ireland, sitting from India, you have to really understand their culture. And for that, the best way is today reading books. There's a lot of movies also available in Netflix and Amazons. Best way to understand a culture now, easier way, is to go to one of these OTTs and watch those movies. Okay, so recapping, the job market, it's fantastic, but it's not going to stay this way. Work from home, those of you who are worried whether it will be the same way, I can assure you it's going about 30 to 40% of the job are going to remain remote even after the pandemic. We saw how the AI tools, whether it is Codex or Copilot or Futura, all of them are going to augment your skills and improve your productivity so that you can write more software, more applications. And lastly, for you to stay relevant in these times, in the next 10, 20 years, it's very important you take up what I call as COLA, continuous learning, and augmenting with these AI and ML tools to your capabilities. So thank you. Thanks to our partners, the publishers, Packet, DevPost, RSA, Fishion, and Mr. Karthikeyan. And also to all the communities and the community leaders who have participated. And if I'm permitted to take questions, I'll leave with this slide for you while, if there are any questions, and if somebody in the organizer can relay it back to me, I can answer them. I leave you with this quote: let machines be machines, let humans be humans. What I mean by that, machines are very good when it comes to systems, process, testing, deployment, and all that. Leave it to machines. Humans are good in talking to people, connecting to people, understanding business, innovation. Let us do what we are good at and leave the machines to do what they are good at, and world will be peaceful. Thank you.
That was fantastic, Venkat. Some of the slides were threatening, and this one was amazing. Yeah, let machines be machines and let humans be humans. I think people are able to connect, and I see a lot of feedback. Not many questions, but a lot of feedback from many people. I think most audience really liked and enjoyed what you really shared. And please take a moment to share your feedback on this particular content from Venkat. I'm just leaving the link right here with your unique code. And if you submit this one, you would stand the chance to get awesome giveaway plus an Azure certification voucher from the AZConf. And once again, thank you so much, Venkat. Anything in the last moment? Anything you would like to add?
Thank you, Elias, and all the organizers. It's not easy to put forward a conference like this at this scale. Just to go through the number of sessions was like, it took me a couple of minutes at least. So fantastic conference. And for all the listeners, have a wonderful AZConf for the next 3 days. There's a lot to learn. And let's ensure we learn more than the machines. And lastly, that's my contacts at Venkatrangan. Just keep the dialogue going. I'd really like to hear your feedback on the thoughts that you think. Am I overestimating things or am I underestimating? What's the trends you are seeing in your office? I'd like to really see it. Thank you once again.
Thank you so much, Venkat. Have a great day. Bye-bye.
Thank you. Bye.
Okay, so next up we have Rickard.
Hi.
Rickard, the stage is yours. Thank you.
Thank you. So first off, thank you for having me. And this session will be about becoming an Azure Troubleshoot rockstar with Azure Monitor, or at least maybe not a rockstar. We maybe don't have to. Maybe the time isn't enough, just 1 hour to become that, but let's try. So my goals with this presentation is to give you an intro of Azure Monitor, the service in Azure, showcase some Azure Monitor features, and believe me, there are a lot of features, so we don't have time to go through all of them. And I also want to motivate you to start using Azure Monitor and tell you why it's good and why you should use it. And also, I've been using Azure Monitor and all the sub-services for quite some time, so I would like to give you some learnings that I've had during the years, both from a technical perspective, but also from sort of an organizational and cultural perspective when it comes to monitoring and troubleshooting. So a little bit about me first. I'm a cloud solution architect at O3H Consulting, based in Sweden. I'm a Microsoft MVP in Azure. Quite a long experience working with Azure, about 10 years. I started off as a .NET developer, and now I'm something like, well, I try to do security and dev and ops and sort of everything in Azure, and try to understand all the parts in Azure to be able to help my customers in the best way. And one big part in this is Azure Monitor and governance in Azure also. I helped both big and small organizations to sort of use Azure Monitor as their primary monitoring tool, both in Azure, in other clouds, and on-prem. I'm a strong believer in you build it, you run it, and you monitor it. And I always try to tell my clients that the ones that should monitor your application is the ones that have built it, because you don't really understand an application if you haven't built it, most of the case anyway. I'm a PaaS and serverless fan. My sort of motto is to use services as high up in the stack as possible. And this talk will be a little bit weighed to PaaS and serverless services and how to monitor them. I'm a lover of Azure and also Legos. As you might see behind me, I have a little pirate ship collection behind me here. So let's start. Why should you even do monitoring? Well, of course, the sort of obvious reason might be that you want to make sure that your system is up and running so your clients or customers can use it. But to me, there's a lot of other stuff that you should consider. Monitoring for me, if you're using the right tool, it's almost a way to see or look into the future. And that means that you can follow trends and see trends beforehand. And when the shits hit the fan, you can actually have proactively fix that problem beforehand, because you can use AI and ML algorithms and smart alerts and some features in Azure Monitor that sort of tells you that we have a trend that's not looking good here, and if your application continues to behave like this, we will have some problems, and that means that you can mitigate the error proactively. And to me, monitoring is a big part before you go to production also. I use it a lot to understand how my new code or how my app is behaving before delivering it to production, so I can actually see what's going on with my new code. For example, am I doing a lot of SQL calls that I haven't intended to do, or is my application eating a lot of memory? And you want to catch those bugs before you hit production. So that's also a way for you to be proactive. It's also a way to lower your costs in Azure. You can monitor your application, see how it scales, how it behaves, and that can help you lower your costs. It's also a way to find security breaches or getting a lot of calls from weird places, or brute forcing attacks or something like that. It's also really easy to take data-driven decisions, meaning that you look at the data and you take your decisions based on the data. No matter if it's scaling or if it's business cases or whatever it is, how your users are using the application, maybe. But in the end, you do monitoring to make your users more happy. But there's a lot of different ways you can do that with monitoring and Azure Monitor. So a question I often get when I am holding this talk is, what's the difference between Azure Security Center and Azure Sentinel and Azure Monitor? And this talk will be about Azure Monitor, but I briefly explain what the other two are. So Sec Center or Security Center is a security management system. It does threat analysis with Azure Defender for specific Azure resources. And it uses the logs that are collected by Azure Monitor to analyze these threats or security issues. So Security Center is using Azure Monitor to store data and to collect data. Azure Sentinel is a security information event management system, a CM system, and it's more like it helps you respond to security threats that have happened. So it's also a source system, which is security orchestration automated response. So and it also reads from Azure Monitor. So it uses Azure Monitor or Log Analytics to read its data and look for deviances. And Azure Monitor, it's the operations monitoring suite of tools and services in Azure. And that's what we will cover right now. So if we take a look here, there's been a lot of changes in monitoring for the last few years. Before you sort of had a three-level or three-tier stack of different people or roles that monitored your application. You had sort of the developers that monitored their apps, you have the operations that monitored the infrastructure, and you had your network admins that monitored your network. But when you go to cloud, all these services, sort of when you go higher up in the services stack to PaaS and serverless, all this sort of is blended together. So you actually need a tool that can understand both your application, your network, and your infra, and give you the insights of that aggregated. So what Azure Monitor tries to do is to be a tool for all roles and give the views to the views of the monitoring data to all the roles in the organization. So sort of trying to promote the DevOps or SRE culture. So some scenarios of Azure Monitor. You can detect and diagnose issues across apps and dependencies with Application Insights. And Application Insights is a sub-service within Azure Monitor. It contains a lot of different features to troubleshoot your app, see how it's doing from a performance perspective, availability perspective, failure perspective, or from a sort of a client perspective also. What you can see here is the application map, which I will show you a little bit later. It sort of shows you all the services within your application, how they are communicating, how many errors they have, how many calls they're doing, the latency between them. One other task of Azure Monitor is to correlate issues at infra level, meaning services a little bit more down the stack for VMs, containers, SQL network, etc. And there is actually separate services for all these infrastructure resources, which we will take a look at later also. This specific image is of Container Insights. So in a big organization, you often have a lot of applications that are dependent upon each other. And if you have an error in your application, that might be because another application that's managed by another team is having troubles. So Azure Monitor Alerts allows you to sort of get an aggregated view of all the alerts within an organization. So you can see, okay, I don't have any alerts within my application, but this team over here that I'm integrating with actually have one. So you can troubleshoot faster using alerts from an organizational-wide perspective. And if you want to dig deep and just look at the logs, that's perfectly possible. And you can create a lot of different dashboards using Azure Portal dashboards or workbooks. And I'll show you this a bit later also. So how does Azure Monitor work? Might be, so if we start off here to the left, we have sort of log sources. We could have application sending log data. We could have infrastructure sending log data. We could have actually the Azure platform, sort of audit logs or subscription audit logs to Azure Monitor. And you could even have custom sources. You could have your on-prem application or whatever application just sending data to a HTTP API to send logs to these buckets over here. And this bucket is metrics. That's sort of time series based data. If you're from the on-prem world, you can think about it as sort of performance counter data specific for each service, depending on what's interesting. And log data is more specific, row-based data, sort of an exception maybe, or some audit log or something like that. And this data, you then can use a bunch of services to look at the data, visualize it, analyze it, respond to it, or even integrate it to other monitoring solutions. So we will take a look at a few of these application insights, as you already saw, container insights. And we will also take a look at alerts and action groups today. So we mentioned that we sort of talked about how it works, but sort of what functionality is used within a service to send the data to Azure Monitor. So from an application perspective, you could either use an SDK, sort of a NuGet package for .NET, for example, and add it to your application, or for Java applications or Node applications. You could also add an agent on the VM or the PaaS service that actually running your application. So it's sort of auto-instrumented. If you want to monitor your infrastructure, that's mostly agent-based, meaning that you install a Windows agent or a Linux agent on your virtual machines. And you can actually also push these out using Azure policies or something like that. So for Azure resources, you just configure Azure resources to send the data, both logs and metrics. You can do that through Bicep or ARM or through the portal if you like. Subscriptions send their data mostly the activity log or audit logs, sends them automatically, and the same for Azure tenants. And custom sources, as I mentioned, you can use a REST API called HTTP Collector API. So that's enough slides. So let's take a look at Azure Monitor in the portal and get sort of an overall view of what it actually is. So let's jump to the Azure portal. Excuse me. If we go down here and click Monitor, and then click Monitor again, we are presented here with Azure Monitor. And here we actually have all the different sub-services that exists within Azure Monitor. So here you can see the activity logs, that's the audit logs for your subscription and resource changes, sort of. Your alerts, your metrics, dependent on what resources you select. If you want to view raw logs in Log Analytics, you can do it here. Service health is sort of the Azure status health. How is a specific resource provider doing in Azure? In workbooks, this is well, not a super new way, but this is sort of the next version of dashboards. In my view, it's a way to create sort of interactive reports for you in the Azure portal. So there are a lot of, you can use a lot of different data sources and present the data in different ways. I will show you this later also. There are a lot of sort of pre-made templates for this, but you could also build your own. And it sort of integrates sort of almost everywhere within Azure. Actually, some of the more specific insights that we see here are built using workbooks. So here we have application insights. We have virtual machine insights. Sort of take a look at I'm not sure if I have any VMs here. No, I'm not. I don't have that. If you want to look specific at storage accounts, the performance, capacity, and availability of those. Container insights, how's your Kubernetes clusters doing, and your pods and workloads within those. Your networks, these sort of shows you an aggregated view of the networking resources that exists within Azure. There's also a more granular way to view network traffics using network security groups. That's pretty cool. And as you can see, that there's a lot of different insights tools here. But what these have in common is that they read from log analytics, where the data is stored, or from metrics, where data also can be stored. And they sort of visualize that in a user-friendly way for you, so you can actually view your different Azure resources at scale. And each sort of insight here, of course, presents the data in a way that makes sense for that specific resource. And you can also jump directly to here from the specific resource also. So let's take a look at a demo of alerts and action groups. Alerts. In Azure Multi-Blade, under alerts, we can see all the alerts in this subscription right now. In Azure Multi-Blade, under alerts, we can see all the alerts in this subscription right now. We could see all the alerts for our whole tenant here if we wanted to, so you can really see all the alerts in one blade for your whole organization, which can be really useful if you have a big incident, for example, and you can see in which systems or infrastructure resources do we have alerts right now. An alert can have 4 different severities, 0 to 4. 0 is the most critical one, of course. An alert can also have one of 3 states: new, acknowledged, and closed. New is if it's been fired, and if you have started working on it and sort of trying to solve it, then you would change the state to acknowledged. And when you're done with it, you change it to closed. Now I wanted to create an alert rule. So we'll go here and click new alert rule. So first off, Azure Monitor is asking us for the scope. And the scope is most likely a resource. So what we want to do now is, if we have an app service plan that has a high CPU, we want an alert on that. So the resource we want to add an alert on is app service plans. Let's choose this one, Windows, and click done. What conditions should be met in order to trigger this alert? So we go to add condition. Let's choose CPU percentage. We are presented with the CPU for this app service plan the last 6 hours. Here we can choose static or dynamic. dynamic is it looks at the history of the CPU percentage and tries to evaluate if it should trigger an alert or not. But today we want a static threshold. So let's say whenever the threshold is greater than 60%, we get a text here. Whenever the average CPU percentage is greater than 60%, then we should trigger this alert. We can also scroll up here and see sort of a visual over the 60% here. We also see that it will be evaluated every 1 minute, and the aggregation will be 5 minutes. So we click done here. So now we've said that, okay, the resource, we want to check it for CPU percentage, then we want to trigger the alert. But what should we do when the alert is triggered? Should we email someone? Should we kick off some automated flow, or should we post something to Teams or something like that? That's what you do in an action group. So you could have created action groups already and use them for a lot of other alerts, but let's create a new one here. So first off, you choose a resource group, and let's call this Zero Sales Action Group. And notifications, who should be notified? You could email someone, SMS, or push a voice, or we could email the resource manager role here. So let's do that. Let's email the owner when this happens. Next up is the actions. This is if we want something other than notifications to happen when this alert is triggered. So here we could, for example, kick off an automation runbook or an Azure function, or post something to an ITSM, for example, ServiceNow or something like that, or trigger a webhook or logic app or whatever. So for example, in this case, you might want to, for example, scale your app service using an Azure function, for example. But in this case, it wouldn't be necessary since that functionality already is in app service. So I let your imaginations decide what you want to do here. So I skip this one. We will we are okay with only the notifications. And then we click review, create, and then create. The action group is created for us. And we just specify a name here. CPU high on app service plan. And we choose the severity. Maybe it's a warning. And if we automatically want to resolve it, meaning that when the value is under the threshold, it could be resolved automatically. And we create a alert rule. Okay, so that was alert. Now let's dig a little bit deeper and take a look at a example sales demo application. And when you try to, this demo is about finding what's wrong with an application. And when you try to do that, you could get an alert that sort of tells you that something is wrong. But to actually find what is wrong, I see that maps and visualizations and workbooks and dashboards and whatever it is a great way for you to actually find out what's wrong with your application. Where should I look? Where should I troubleshoot, sort of? So maps are great, and as you can see, I love all kinds of maps, and one map I love in Azure is actually the application map within Application Insights. So this application is just a super simple sales application, which sort of has a front end, a back end, a database, and then another system that contains the customers. And these are hosted. One is hosted on App Service, the other one also on App Service, and one on AKS, and another one using Azure SQL. And these are all instrumented with Application Insights and Container Insights. And I also have some availability tests that checks the availability of my application. So let's troubleshoot this application now, because the app is down, something is wrong. Let's try to find out what it is. We're getting calls and emails from our customers that our application is down. If we go into Alerts here and choose Past Hour, we can see that we actually have an alert here. So let's take a look at this one. It seems to be our Application Insights resource, and more specific, it seems to be the availability tests that exists within this resource that has been failing. So let's take a look at those. And we can see here that if we change to the past last 30 minutes again, we can see that we had tests that were going okay here, but somewhere around here we started getting failures. So something is not well here. We have 14 failures and 16 success for the last 30 minutes. And we're also failing from a number of different places in the world. So let's try to find out what's wrong here. We can click failed here. Then we can sort by date and click this one. We're now entering another part of Application Insights to view the end-to-end transaction details. And here we can see the availability test. And here we can see a little bit of a troubleshooting report. You can see that a number of things went well, but we're getting an internal server error 500 from the front-end application, and that does not match the 200 OK that we are expecting. We don't have any SSL certificate problems. That's good. So if you click the next one here, we're seeing the same thing, 500. If we click the backend application here, we can see that we have a 403 here. And that's usually forbidden, and sort of knowing app services, this could be a number of different causes, but most probably we have something wrong in this sales backend application. So usually here I go back to Application Insights and take a look at the application map. And as we saw, we have the front-end application and something is going wrong with the calls to the sales backend. And usually, or sort of the fastest troubleshooting here is that I want to know what has changed in Azure, or within my application or within my infrastructure resources. And then there's an excellent application or service for this in Azure that's called change analysis, application change analysis. Application change analysis shows changes that has happened in Azure on an ARM level through the resource graph, but it also is even more intelligent than that. For example, there are you can see even deeper changes within app service changes, for example, and some other resources. So now we want to see what has changed with my application for the last hour. And I know that all the infrastructure resources for my application is in a specific resource group. So let's filter that. And what we can see here is that something has changed a couple of minutes ago. And the old value was running and the new value was stopped. And it's in the sales backend web app. So if we click here, we can see that the state of the web app was running and then it was stopped. So someone stopped the application or something stopped the application. And this is could it be done through Azure PowerShell or a pipeline or through the portal. And we can even see here who changed, which user that changed this or stopped the application. So clumsy developer, a team member of mine, probably went in and thought he was stopping the test environment or something like that, but instead he stopped production. So this is an excellent way to actually find out what has changed since everything worked fine. And it will give you a quick overview of that. Have someone deployed the new code, for example, or changed some infrastructure settings. And you can even see all the changes that have happened within your subscription or your whole tenant. So this is super useful for troubleshooting. Yeah. So that was a demo of the application being down. This demo will show an example of sort of troubleshooting an app that is slow. Once again, we're getting information that our system is slow or not working. And we jump into alerts. And we can see here for the past 30 minutes, we have an alert here. Let's take a look here, where we have an alert fire that continuous CPU usage is high. Okay, so it seems that some pod in our AKS cluster is having too much to do or having a high CPU load. So as always, I first go to application insights and take a look there, since the pods there are reporting to the same application insights. You can see right away here that our response time has increased quite a lot for our application. Let's go to App Map and check the last 30 minutes. We can see here that this is our sales customer application. This is the application that's running in AKS, and these two are running in app service. And you can see here that we have 2 seconds here and 2 seconds there. Okay. gives us some information. Then we go and take a look at performance for the last 30 minutes. You can see that we have had a lot of spikes here from almost just a few milliseconds up to 10 seconds, 13 seconds, and then up again to 20 seconds. So we clearly have something going wrong here. And it's get sales, get home sales, and get customer that's acting up. Okay. And we knew that we had the CPU at one high on the AKS cluster. And these are all calls that end up in this call. So, okay, let's go and take a look at the AKS cluster. And now we can jump into Container Insights, which is sort of the application insights, but for the AKS cluster. And here we can see the node CPU utilization. This is sort of the VMs that are running the AKS cluster. We can see that we have had a spike here. So that tells us something. But of course, there are other workloads running in the cluster right now. Okay, so we can go to controllers and see how our specific application is doing for the time being. But first, let's change to last 30 minutes. Go to controllers. Okay, and we can see here that our O3H sales customer, that's our pod. It's running at 100% CPU, so we can see here and here. And we just have one pod running here. We can click view live data here to be certain on what's going on right now. Then live metrics, and then we can get sort of a live data here. And we can see here that the limit for this pod is 500 millicores. And it's actually running at that right now. The memory seems fine because it has a 500 limit, but the CPU is maxed. So, okay. And knowing this application, this pod should actually scale out, or the replica set should scale out using the HPA for this pod. So why isn't it scaling out? Most probably we have some misconfiguration. So let's try to scale this pod or this replica set and see what's going to happen. So let's connect to Cloud Shell and tell our horizontal pod autoscaler that we want to scale or set the max replicas to 20 instead of 1, it seems to be now, since it hasn't scaled anything. So you can see here we only have 1. So let's do that. See what happens. So now if you go to workloads, we should see that our application is scaling up. We can see here Now we're already at 4 pods here. Should have happened just 15 seconds ago when we ran the command. So this is looking good, and we should see a performance increase here now since we're scaling up. So let's go and take a look in Application Insights again. We can see that server requests are quite high, but our response time is going down, or has gone down. That's good. Let's take a look at performance just to be. Let's do the last hour. We can see here that these are the spikes that we had, and it's going down all the same. So that's good. Everything seems to be working now. Yeah, so that was a demo about troubleshooting an app that's slow. We don't have that much time left, but I'd like to sort of promote a new functionality or APIs and SDKs that Azure Monitor is implementing. And it's sort of OpenTelemetry is a standard for telemetry data. It sort of tells you how traces and metrics and logs should be organized. Today, Azure Monitor uses its own, but this could be a problem when using applications that are built with other types of languages. So what Azure Monitor is trying to do is to support a variety of popular open source or popular programming languages, and use the OpenTelemetry standard or get Application Insights and Azure Monitor to support the OpenTelemetry standard. And so the problem is the standards for APM data or traces and logs and all that is a lot of times vendor agnostic. And yeah, so before there were some different initiatives on this called Open Tracing and Open Census, but that's now combined to a standard that's called OpenTelemetry, which is now is a part of CNCF. And Azure Monitor is working hard to get this supported in Application Insights. So, for example, what does this do in reality? It's sort of you will be able to display applications, for example, within your application map in Application Insights from applications that are written in a variety of languages. So you could have an app you could have a Go app that talks to a C++ app that talks to a .NET app, and you can actually get that tracing visualized within App Insights, for example. And there is a library for this for .NET also. And logs and metrics will come later. Now they're focusing on traces. I also want to mention the Azure Monitor workbooks, which I said before are sort of interactive reports with several different data sources. It has a lot of use cases. It's used, for example, by App Insights to build troubleshooting guides and SLA reports and all that. So if you click around in Azure Monitor Blade, you will see a lot of different services that have used workbooks to implement their monitoring visualization. And it's almost like you're building your own Azure portal UI almost, because you're getting so much visualization components that look like the Azure portals, and it's very interactive. So you're almost building a UI for yourself. And they also are, if you build sort of different sections of your workbook, they are pinnable to the Azure portal dashboards. So you could actually pin them to your existing dashboards if you want to do that. You should check out the gallery, which exists within Azure Monitor. And you can change, build, or resave other ones and just change them to your own application. That makes sense. So I also want to mention a little bit how I think you should set up your monitoring architecture if you're a DevOps team. So you should probably have continuous delivery, including monitoring setup. That means that your alert rules and the diagnostic settings and how you monitor should be within your infrastructure as code. And you deploy this to, you can Azure or on-premise or other clouds, wherever you're running your applications. And then you use Azure. These resources will then send their monitoring data to Azure Monitor and Security Center and Sentinel if you're using that. And you can then use a lot of sort of developer-friendly tooling within the portal or within Visual Studio to visualize this data. And you could use automated alerting and healing, sending alerts to the Azure mobile app, sending it to Teams channel, or even have automated self-healing, kicking off a logic app or a function. Also, I try to tell my customers to use Azure Monitor to continuous optimize your application. So sort of when you start deciding on the infrastructure for your application, start small, size does matter. Run your app or load tests. Monitor performance and costs. Is there anything you can do with your code? Tune it. If not, scale up, scale down out in your infrastructure, and then do it all the way around, continuous for every release, sort of. So let's jump to some learnings. It's really important when sort of implementing DevOps monitoring and sort of the new wave of monitoring that your whole organization understands this. You need access to all the data. You can't save data that is sort of private data, because then everyone can't access it. So have a culture that everyone should be able to see the data and solve the problems together, and sort of structure your teams with the different competence to understand both network infra and PaaS and serverless logs. Monitor your monitoring costs. You can spend a lot of money within Azure Monitor if you're not sort of looking closely at how much data it is. Monitor all your environments, or at least a few that's not prod, to be able to learn stuff before you hit production. You build it, you run it, you monitor it. Mentioned that in the beginning. You should have a monitoring dashboard that you view every morning meeting, sort of to get everyone in your team, in your app team or DevOps team, to really get a feel for the monitoring data, understand the application, how it's behaving. Should we scale up? Should we scale down? Do we have some trend that's not looking good? Because if you're not looking at the data, you're forgetting about it. So use workbooks, a portal, dashboards, or something like that to visualize your data. And as I said before, app maps and workbooks are great. You should use them. Access model, it's a little bit hard to sometimes to do a granular access model within Azure Monitor. So you should think about that beforehand. But with that, I think I'm done. So don't forget to check out all of the treasures in Azure Monitor, and reach out to me on LinkedIn if you have any questions. Let's see if we have any questions in the chat. No. So with that,
Not
I
many,
think
Rick.
no.
Not many. But then I think our audience enjoyed the hidden gem that is always monitoring, in my opinion. It's a hidden treasure for application developers as well as the operations team.
Yeah. You should really use it and learn it and understand it.
Perfect. Thank you so much, Rick.
Thank you.
It was wonderful having you with us at AZConf. And a quick reminder for all of those who are watching now, as well as people who come in later, to submit the feedback for the session and use the unique code that you see on the screen at this moment, and stand a chance to win amazing giveaways from the AZConf, as well as do participate in the hackathon and Azure certification drive, and qualify for a chance. All right, and if there's any question, please use the chat window wherever you're watching this, or connect with Rick on social media, and feel free to communicate with them. All right, thank you once again, Rick. And now, in another 3 minutes, the next session will be in from myself, and let's push the timer for the next 3 minutes. And let's continue with the topic. Thank you so much for thanks for all the sponsors who made this event possible. And this is a quick introduction about myself. My name is Ilyas, and I work as an Azure architect at ABB. I'm also a Microsoft MVP and one of the co-organizers of this conference. So in this session, we're going to look at scaling Kubernetes or scaling applications using AKS. So before we get into the technicalities or the solution behind scaling applications using Kubernetes, let's look at a bit of context here, right? More and more applications or more and more manual things are being automated. More and more applications are hosted on cloud, and now everybody is working from home. That means the consumption of these services are going very, very high. And what this means is there's a significant stress on our infrastructure. So a lot of operations teams would be monitoring our web applications, be it, let's say, the application is hosted on, Azure virtual machines or app services. Of course, we have auto scaling feature in place, which automatically scales our web application based on the consumption, be it CPU or memory consumption or even queue, right? So there are a variety of ways in which we could auto scale our infrastructure. Now, in this case, I'm taking context of, let's say, a cat food manufacturer has a website which sells their cat foods online. And imagine, given that we are in pandemic, let's say they are trying to do a campaign or run a promotion, thereby they are giving a deep discounts, and now customers are going gungo, and they'd like to offer, they'd like to place order in bulk, and so they are jamming your website, and which is always good, right? So for a manufacturer or e-commerce player who wants to sell online, they would like to have more customers come on and look at our products and buy them. Now, when this happens to your product or for your enterprise, your underlying infrastructure should be able to support the automatic scale of your product or online services so that your customer get a better experience. Yeah, they don't see something like loading. So this is most people hate about, right? So they are eagerly waiting for ordering the product, and they come to your website and they see something like this, or the page doesn't load for all good reasons. So this is a very bad experience that most enterprises would like to avoid. Yeah. Now, how can we do this? Now, many enterprises as well as all the players, SME players, are now adopting Kubernetes. Yeah. So Kubernetes has been a platform of choice for more of cloud native players. This has become a unicorn. Most of the enterprises that I know of, or SMBs or startups, they are directly jumping into cloud native, as well as the existing enterprises who have web apps. They are trying to move to Kubernetes. Now, one of the key benefits of Kubernetes is its deployability, automating application deployment, scaling them, and so on. Now, in this demo, we're going to look at how to scale applications using Kubernetes with the, some of the construct that it offers. And now we are going to look at more from Azure perspective. Of course, this is universally true, wherever you could run Kubernetes on, right? Be it AWS or Google or Azure. Now, before we talk about scalability in Kubernetes, let's look at some of the basics of how Kubernetes is constructed on. Right? The fundamental component is a node. A node is basically a virtual machine or a machine that runs in a cluster. So it could either be a virtual machine or a physical machine. And each node is managed by a master. A master is the one which schedules jobs or pods or deployments in each of the nodes. Now, nodes can come and go. And when the node gets added, the master automatically deploys the pod or deploys the container in each of the node. And then the next construct is the pod. A pod is the smallest deployable unit in the Kubernetes objects.
Yeah, a pod represents a single instance of a running process in your cluster. A pod usually contains only one container, but at times you could also run, one or more containers into a pod, right? And when a pod runs multiple containers, the containers are managed by a single entity that share the pod's resources. Yes, and understanding of this particular is very much important when you deploy the application on Kubernetes, as well as when you want to, scale the applications in the Kubernetes cluster. Now, this is a reference to how a node contains multiple pods and volumes, volumes that can store your, databases or, configuration files, and then so on. So with that understanding, let's go to the scalability aspect. Yeah, because scalability is one of the reasons why most enterprises are adopting Kubernetes. Of course, there are a lot of benefits with respect to Kubernetes that includes how we could deploy microservices and how we could individually scale one microservices to another, and then it brings in a lot of security benefits and so on. Now, in this session, we are going to look at the various scalability options that are offered by Azure AKS. The 4 options that includes manually scaling your nodes, and this is a given option. Now, if you go spin up your Kubernetes cluster, you could define how many nodes that you would like to add as part of your provisioning, as well as you could define how you want to scale your Kubernetes, whether you want to manually go scale it, or you want to simply turn on the checkbox that says auto scale, which would automatically add instances when needed. The second option is the horizontal pod autoscaler, which is an open source project from the community and adopted by Google, which helps the simplifying the process of auto scaling our applications in the pods, right? So we are going to look at this particular aspect of AKS in detail in the demo, but this is one of the way using which we could scale the application. The second component that's offered by Kubernetes and Azure is the cluster autoscaler. And this is also a very critical piece. In fact, both horizontal pod autoscaler as well as the cluster autoscaler go hand in hand to scale your application in the pods, as well as scale the nodes, right? Because what is the point of scaling the pods, but if you don't have sufficient nodes or machines to handle or to deploy the additional pods? And that's why the cluster autoscale comes into rescue, which helps us to automatically scale the nodes or add number of nodes, as well as remove nodes when those nodes are not being utilized. Yeah, so that's cluster autoscaler. And the fourth option is Azure Container Instance Integration with AKS. That really helps us in a situation where you want to quickly spin up instances without really waiting for the new nodes to be added, right? So this is another great integration which helps us with the quick burst scenario, right? So these are the options. Now, we talked about manual scale, right? In the case of manual scale, you need to really look at your application, the consumption or the CPU utilization, the memory utilization of your existing nodes and cluster, and go manually increase the nodes, right? So this is not a good idea, and you don't want to do this yourself. Just imagine you have to do this on a weekend, right? So nobody likes that. So, and that's why we use horizontal pod autoscaler, which automatically scale your pods by autoscaling your cluster as well. And this is very much like what you're seeing here. When there is a more usage of your application, when there are more utilization of your CPU memory, the horizontal pod autoscaler would continuously monitor the consumption. When the utilization goes high, it would automatically spin up additional pods. And similarly, when there are no pods, or when, let's say, the utilization comes down, yeah, so the horizontal pod autoscaler would continuously monitor your CPU and memory. When the loads are less, it will go remove your pods one by one, right? So that's a no-brainer. And to help us understand, I mean, this could be a good reference point. So here you have a horizontal node pod autoscaler that sits between the nodes and pods. Yeah, and when the pod's consumption or the CPU and memory utilization goes high, the horizontal pod autoscaler would automatically scale out with a new pod. By doing this, the loads that arrive at the existing pod would be equally shared with the other two pods that are newly added. Yeah. Now the horizontal pod autoscaler can monitor, of course, the CPU and memory utilization. But in addition to that, we could also use custom metrics like, let's say, a queue. If you have, if the pods are basically looking at the queue, or picking an item from the queue and then processing it, the horizontal pod autoscaler could also use a queue as a source to monitor when there are more items on the queue. It can automatically spin out more number of pods and complete the process. And likewise, when the queue dies down, or when there are no more requests, the horizontal pod autoscaler can also kill the existing pod and thereby reduce the infrastructure utilization. So we talked about responding to multiple metrics. So we could either use the CPU or memory, or we could also use a custom metrics for auto-scaling our pods as well as our nodes. And there are significant, not significant, but there are restrictions and limitations, as this component is fairly new in the market. The vertical pod auto-scaling is something new. And there's a recommendation on the Microsoft website that you could see that it is still not supported, and it is also not recommended to use vertical pod scaling. Cluster autoscaler, like I said in the beginning, goes hand in hand. Yeah, so you need the underlying infrastructure, such as a virtual machine or a physical machine, to deploy your pods. Now, there is no point in increasing your pods by, let's say, 100, but there is no sufficient space to run those pods. And here we could make use of ACI instance for bursting out with new pods, or we could make use of in a cluster autoscaler, which would spin up additional nodes when the pods are not being able to schedule in the existing nodes. So the Kubernetes component actually makes a scaling decision. The scaling decision is actually made by the critical metrics, such as CPU and memory. And now we could also define how we want to scale the number of nodes that we want to add. For example, here we could set up a minimum count of 5 when the current node is 3, and it will again immediately scale up to 5 when there is a requirement. And likewise, when the utilization comes down, we could remove the number of additional nodes that was added into the system. And now AKS does this very graciously, right? It is very aggressive in terms of adding additional pods when there are high utilization, and likewise when the utilization dies down, when the overall requests are coming down, let's say now AKS will go and remove those nodes. Now this is done very conservatively. When creating a node or a pod, it does efficiently. It creates very proactively, but then when it needs to remove it because there's no more utilization, it does it very conservatively. So we need to consider that in mind. Now, in order for this to work, right, we need to make sure our deployment contains the important instruction, that is the request resource limits, right? So as you could see here, we have a deployment that deploys a Redis application, example voting app. And here is our image. And then this is the important section, so where we define the resource limits. The first one is the limit. So here we say what is the upper limit that we want to set for a given pod or a container. So in this pod, we have 2 images or 2 containers. The first one is Alpine image, and then we also have a busy box. Now, here we have set a resource limit. In this particular section, we are setting a higher throttle or higher ceiling. And then here is a section where we are setting a limit for a request. So that means this is the requested limit. Or so here we have memory and CPU. Memory is defined as 300 MB. And the higher ceiling is 600 MB, megabytes. And likewise, we have set a CPU higher limit of 1 core, and the requested amount is about 500 millicore. Yeah, so 1 core, converts into 1,000 millicores, and for every 100 milliseconds of computing time, it requires 100 real MS. Yeah, so that's like a definition for you to define how you set a resource limit for your auto scaling. And this is very much required in order for the auto pod scaler. If this is not in place, we cannot set horizontal pod auto scaler, because there must be some definition based on which we define or identify when to scale a pod. Now, the way it works is, let's say we have a pod that has defined memory with CPU of 300 MB and 500 millicore. Now, if something is running inside it and that is going beyond this limit, then the horizontal pod autoscaler would continuously monitor the utilization of this particular pod, and then it would go and spin up additional pod. And that would happen when this particular pod is getting throttled. And the throttle will only happen when this particular pod hits the ceiling or limit at 600 MB or 1 CPU core, right? I can give you a quick analogy of a home. Let's say you are starting a new startup and you got an office, and the office could seat about, let's say, 10 people. When you just started up, you hired a place where it could seat only 10. Now, you need to have a dimension for each of the tables or chairs, so that you could define for 1,000 square foot of office space, you could only seat about 5 tables of this dimension. And this is what we are defining here. We are saying a dimension of this particular container. And here we are saying this is a maximum space that this particular table could occupy. When you have more tables that exceeds the overall room capacity, you need to go find another room or an office that could accommodate another 10 tables of certain size. Then that's exactly what we are doing. On the left, you could see a node which has about 4 CPU with 16 GB of RAM. Now, each pod that would run on this node would consume each of the core. Yeah, because here we have 4 vCPU, and that means 4 core. And you have already defined 1 as the limit, but the utilization or request is only about 500 MB. Now, we also have another pod here or container here. So we need to sum all this and then compare this with our node and make a decision of how many pods that would be able to run on this particular node. Now, the horizontal pod autoscaler would continuously monitor the consumption of this and then make a decision to scale out or scale back in based on the utilization of the application. Hope this makes sense. Now, let's see this in action. And here I have an analogy about the same thing that I talked about, where you have hired an office and you are scaling out when there are more people that's utilizing the office. And likewise, when the number of people reduce, you go back. Yeah, so that's a scale in as well as scale out. So with this, we will jump into the demo, and the entire source code used in this application is already committed in this particular repository. So you could go and take a clone the source, and you could play by yourself. With that, I'll go back here. So here I have already created my AKS cluster. I've created a cluster called azconf, and this is a one node cluster, a simple one, and it has also configured with auto scaling. So if you look at the node pools, I've got just one node. It's very easy and straightforward for you to spin up a AKS cluster yourself. I have also turned on auto scaling. So here, as you could see, the auto scale is turned on, and I have set a maximum of one node. Yeah. And look at the vCPU core here. So I have 2 cores and 7 GB of memory. Now, if you recall our slide back, if I spin up a couple of containers, each demanding 1 core, I can only run 1 or 2 containers in the entire cluster. Yeah. Now, what we're going to do is spin up an application and see how we could make use of horizontal pod autoscaler so that my application can automatically scale out and scale in based on the necessary. So let me close all of this. I was testing it before. Hope this is visible. Let me close all of this. So like I said, this is a very simple application. You could access this in the GitHub repository, and the repo will also contain the PPT that I'm demonstrating now. So this is a Node.js application. It has a couple of APIs. One is add. If I give 2 parameters and numbers, and it will simply return me additional value of that, as well as I have a Fibonacci series, and I have introduced a sleep, because in this demo we will see how we are trying to simulate a sleep utilization, and the sleep function is a good one to create a stress on the CPU. So I am trying to sleep for about 1000 milliseconds for each request. So that means if I call more number of time, the CPU is going to get stressed out. All right. So nothing fancy about this application. And I also have a square root. So when you go into this repo, you will be able to find the source code yourself. And then I'm running the application and I'm exposing the port. That's all I'm doing. I have a Docker file that you could see, and it's a very straightforward and simple one. So you could basically run it in your local as well as try it on Kubernetes. So what I'm going to do, I also have a deployment file. That's the interesting one that we need to spend some more time on. So here, that is not the one that I would like to use. So here is the calculator app. I have a replica set to 1. So by default, it would create 1 pod, and I've named it as calc app. And here is the Docker container. So I've already published it in my public Docker repository. And here I'm exposing the application on container port 80. And the important area is the resource limit. So as we saw in the PPT, we have set a CPU higher limit as 100 millicore, and the request is about 30 millicore. Yeah. So as long as I can fit this pod into my 2-core application, I can run my pods, as well as I have created a service to expose this deployment. So I'm using a type load balancer so that I can get a public IP assigned to this container, and I can access this application. Right. So let me see if there's any question. If there's something, then I will pick this up and then answer. Otherwise, I can move on to, okay, so there's no question so far. So let me go back to the demo. So again, the service object is not fancy at all. There's nothing defined here, but the important piece is this section where I'm defining the resource limit. So this is one of the deployment. Another one that I have is called infinite calls. This is basically an application that runs a simple script. I'm using the BusyBox image because I would like to run a bash command that would continuously create an outgoing request. And I'm calling the application that would be exposed from the previous service. That's all we are trying to do. Of course, we could call this from our local machine, but I would like to create enough stress, and that's why I'm making use of the Docker container to do that. Perfect. So nothing much on this. So let's go and deploy this file, and let's get started. So let me close that down, and let me apply this file. And before I do that, let me make sure I'm doing this on a separate namespace, which is a good practice. Do not use default namespace for deploying your application. So here I created a namespace called azconf, in which I'm going to deploy my application. So let's do kubectl apply f, and then the file name is called deploy.yaml. So this is going ahead and creating all my pods. So the infinite calls pod has been created, as well as I've created the calculator app. And then I've exposed the calculator app as part of a service. In addition to that, I've also created horizontal pod autoscaler, which I missed to explain in the previous step. So let's quickly go there. So the horizontal pod autoscaler, it's a very simple definition that says, what's the maximum replica that you want to create for a given pod? Yeah. So here I've said for this particular pod, the minimum replica is about 1, but when there is a necessity, I can go up to 500 pods. And the important section is here, where I'm setting a target CPU utilization. The target CPU utilization tells at what time I need to spin up additional pods. So here I said when the CPU utilization reaches about 10%, I would like to go ahead and spin up additional pods. So here I have reduced the number. You would not do this in the production setup. I wanted to be aggressive here so that we could see how it actually spin up additional pods when the calls to our calculator API goes high. So that's the horizontal pod autoscaler definition. It's very simple. It's of type or kind horizontal pod autoscaler. You're giving a name for it. You're setting up a max replica and min replica, and then which particular application you're targeting to, and then you're setting up, what percentage this particular pod autoscaler should work. Now, here I've only set a CPU limit, but I could also set a memory limit. Then say what is the upper limit and what is the total request. But to keep this simple, I'm simply going to use the CPU alone. Okay, now the deployment is done. So the application or the parts has been already created. So to check if they have come back or come up, let's do kubectl get pod. Now we have 2 pods alone. One is for calculator app, another one is for infinite calls container, which contains our script to raise multiple HTTP requests. All right. So at this moment, there is no calls or no stress to our calculator API. So to check that, to check the CPU and the memory consumption, we could make use of kubectl top pod. And here you could see the current utilization for the calculator app is 1 millicore. 1 millicore out of 1000 millicore. That's 1 CPU, right? So there's no little utilization of this particular container at this moment, which means nobody is calling our service. So what I want to do is I want to make use of this container and make HTTP calls to the application that is running inside this one. Okay, and for that, what I need to do is get the public IP of this particular service and update this container so that it can call this calculator app. And to do that, let me go to kubectl get svc and this is the public IP of my calculator app. And I will go here and update this one. So to check if this calculator app is actually working, so I can go to the browser and try this, and it should get us some Fibonacci value for the given number. That's what is happening. I can also change and send a different value. It would give us different numbers for each time. So that is what running in the calculator API. And now we are going to call this multiple times from our infinite calls container to create some load so that we could see how horizontal autoscaler is actually working. So to apply that, because I've just changed the infinite calls with this IP, so let's go ahead and apply that again. So we could simply do kubectl apply and deploy dot YAML. So now the calculator, we have updated the infinite calls container with the right API or the IP address. Now it would start. It would start its work, that is continuously making calls. So if we go and do get pod, now we could see the calculator app is now created. 2 more pods are created. Now if we continue to see this, it will add additional pods. So now to create rapid request or not to bombard our calculator API, what we could do is scale this container, and each of the container would then try to make too many calls or many calls to the calculator API so that we could see how it is continuously spinning up or churning out additional pods. So we could actually see the HPA or horizontal pod autoscaler in action. So let's do get pod watch, and now it is continuously watching. Now let me open this in a parallel window and do let's scale this. Let's scale the infinite kubectl Kubernetes scale and choose the deployment. The one that we are trying to scale is the infinite calls, and right now it is in the replica is set to 1, but I'd like to increase it to 10 so that 10 containers will be up and will now start to create a number of infinite calls. So as you could see, all of these new containers are being in the scheduled state, pending state, and then container creation, and it is running. Now these parts, when they come up, they will start to bombard our calculator app. So let's give a few seconds for the HPA to pick up and start creating our calculator app or start scaling out to create multiple pods. And this can only create pods if we have enough node pools. Yeah. So to see this in action, let's go back to our portal. Now in the portal, we have set a max to 1, so which means it cannot scale beyond 1 node. Yeah. So how much ever this guy start to request the other container, but we have set a hard limit. So if you recall our point, horizontal autopod scaler can only work if the auto scale is set and you have set a maximum limit. Yeah. So now what I'm going to do is before I scale that out, before I update the max number of nodes, if we do kubectl get events, so here you could see that these are created and some of the calc app, you would see that it is in pending state because we don't have space. The existing node doesn't have space to create additional nodes. So it is continuously trying and failing, and it is waiting for us to spin additional nodes. The cluster autoscaler has picked up, but then unfortunately we have set a maximum limit as 1. So what we could do is quickly increase this guy to at least 3. So make sure you have, when you are creating the Kubernetes, you make sure you select the auto scale on, and then you set a maximum limit. Again, it depends on your application. You need to really look at your application consumption over a period and see what's your right size for your Kubernetes cluster. So now the agent pool, at least we have lifted the limit. Now the cluster autoscaler is continuously monitoring the capability to add new nodes. So it is going to look at the consumption. It is going to look at the pods that are waiting to be added. So it is going to create new nodes and then deploy the pods into the new nodes. Yeah. So we need to give some time for that to action. So it is not very rapid. It's going to take a while for the new node to come up and then deploy the pods on it. Now, if you wonder how this is working, right, how the pods are emitting its CPU and memory consumption, the Kubernetes has got the metric server. Metric server is another open source component that helps us to capture the metrics that comes out from each of the nodes as well as the pods. Now, the horizontal pod autoscaler component as well as the cluster autoscaler component is continuously monitoring the metrics that's coming out of the metric server. And as and when it reaches the ceiling, or when it gets throttled, when the pods are not able to deploy on the given nodes, that's when both the guys, horizontal pod autoscaler as well as the cluster autoscaler, wakes up, and then it goes and creates additional nodes as well as additional pods. So we could see some of the metrics right inside our container insight. So here you're seeing the metrics here. We are looking at past 6 hours of data, because this is a cluster that I created in the morning. So some of the tests that I was doing in the morning is the data that you're seeing right here. But we could also do a live data that shows and plots the live information about the node CPU utilization, node memory count, active number of pods that's deployed. For example, right now we are at 20. Hopefully it should increase because we have created, we have bombarded our calculator app by creating too many web requests. So slowly and gradually, the number of nodes should increase, as well as the pods that's getting deployed on those would increase as well. Right? So here in the nodes, we should see the new nodes that is getting scheduled. So as you could see, this is our existing node, and these are the new nodes that has come up recently. And if I go back to node pools, we should see them right here as well. No, not yet. It is still taking some time to spin up additional nodes. So let's give some time here, and we will go back to our VS Code to check what's happening here. So it is now trying to create new pods. So like you see here, it was terminating because it was trying to create new pods. The horizontal pod autoscaler was trying to launch new calculator app pods, but it was terminating because there was there's simply no space in the existing pods. But now we have turned on the autoscaler, as we did with the app, with the portal. Now, in some amount of time, the new nodes should come up, and it would automatically add new nodes. Let's give some time, and in the meantime, let's see if the new nodes are coming up. So here you could see the auto scaling is enabled, as well as we have set auto scaling to true, and we have also set the max number to 3. And this is a good example of why. So we enabled the auto scaling, and we have set a max limit of 3, but then it takes a while because it is now spinning up new VMs to deploy the pods, and it takes some bit of time. Now think about this in the production scenario, right? Think of an e-commerce site that is announcing a Diwali sale or some sale. And usually that happens. The operations teams would know that they would expect about, let's say, 1 million users, and they would have pre-provisioned the number of nodes and pods and all of that, and they keep it in a warm state so that the users could have a better experience. But just imagine, let's say the expected crowd was about 1 million users, but then let's say 10 million users have come to the site. Now, when we have the node pool to create additional nodes, that is going to take a good amount of time, a fair amount of time, right? Probably in few minutes, but then few minutes might lose customers for the e-commerce site. So they might not want to wait for 2 minutes to provision new servers. And that's where this ACI integration, Azure Container Integration, comes in handy, where it when you have a burst up scenario, when you want to create pods quickly but do not want to wait for the new pods to be created, right? So we could simply enable the burst option that would automatically create pods on Azure Container Instance, right? So that's another demo that we could see, but in this case we are going to make use of this new nodes to be created, and we would deploy this pods. Now, going back here, let's see what's happening here. So we are waiting for this application, and it is calling all this application. So let's do this. So it is still not able to scale, but I'm not sure if the IP address is set right here. So 2040 to 44. Let's go back and check if yeah, 20, 40, 50 to 54. Okay, these guys are up, but it is still not, the calculator app is still not up, and this could be due to the fact that we don't have the node pool still added. So let's go back here and check. I'm trying to scale the node pool again. Okay, it's adding an upper limit. Okay, that's done. And now at least the pool should be added. The additional pool should come up. So here you could see the number of pods. We have at this moment only one pod, but we have many number of infinite calls app. So let's wait for some more time for the pod, for the node to be up, and then we should see the pod spinning up. Okay, so let me go and scale the deployment infinite calls to just 3 and bring down the infinite calls. So I'm just trying to reduce the number of infinite calls and thereby increase the calculator app. Okay, so now this is resized, or at least resizing, and we should see the calculator app. So it looks like the cluster autoscaler is still didn't spin up additional VMs. Let's see what's auto scaling is enabled, and this is set to 10. Okay, so now let's go back and see what's happening with our pods here. So we could also check one other thing. kubectl get events will tell us what's happening in the overall cluster. And here we are scaling the replica set of the infinite controls and infinite calls. And we are still not seeing the scaling action for the calculator app. And that's simply because the nodes are not added yet. Okay, let's once again increase the number of okay, so let's wait for the load to be created, and this would create a stress on the calculator app, and this should increase the, it should at least request the pod to come up or node to increase. Okay, the new infinite calls apps are coming up, so let's wait for some time here. And this should have created enough stress for the calculator app. Okay. So let's see, what is the utilization of kubectl top? So the utilization is at 1 millicore, and that could be the reason why that is not being stressed. And we have to check. And this seems to be absolutely right. So let me try deploying this once again. I hope the calls are now going out. Okay, so now the time is up, but give a try. So here, looks like my API calls are not getting hit, and this is not creating enough loads, I feel, because of which it is not able to spin up additional, pods. So the reason could be this: my API requests are not creating enough, stress, because of which it is not loading. I will get this fixed and push the code to our GitHub repository. So give a try. In case if you find any issues, raise a PR, and I'll be glad to merge it back. And in the meantime, if I'm able to figure the issue, I will go and fix it and push the code as well. So that's it for now. And let's see if there's any question here. I think looks like there's a solution, and it's pointing to the old IP, I guess. Okay. Kevin, I think that's a good catch. Let's see if that is the problem. Okay, so let me simply remove and then recreate this. You're right. I will go delete. Let's recreate this once again. That's a good find. F deploy. Create. Okay, so in the interest of time, let me just go and delete this guy and recreate all of them one by one. We still have 6 minutes left, so we should still be able to do that. Create nsazconf1. That's created. And let's use namespace. And let's create them once again. Create. Perfect. Now this is created. And let's get it's still pending, so let's wait for the IP to come up. So these are some usual suspects. So let's get this done. Okay, now we have the IP. Let's go and update this guy. Hopefully saved now. Let's go and update that. Okay, so let me put this in a separate file. I don't know why this particular one comes. Infy dot YAML. Okay, so looks good. And let's go and deploy this infinite. Okay, so let's delete this. Okay, I am trying to create, and that's why it says that I should have said apply. Deployment infinite is missing. The Kubernetes lost connotation which is required. Kubectl. Okay. Delete infinite. Apply. All right, perfect. Now it's created. Let's see now if the loads are coming there. And let's see, kubectl get svc 1371, 126, and 64. And now let's check pods. So we have good number of infinite calls app, and now this guy should go up. Let's issue top to check the CPU and the memory consumption. Okay, sounds good. Looks like we missed it in the beginning, and now we see the CPU and memory utilization. Kevin, thank you so much for your hint. Looks like I missed the IP, and because of which this happened. I think we spent about 10 minutes roaming around this. Now, as the loads are coming in, we should now see the calculator app that's getting the horizontal autopod scaler now working. Okay. Now the number of calls as it hits, as it tries to deploy the number of calculator apps, it is going to create stress on the pods, and that would now start to create new nodes. And like I said, this might take a while. It's not that quick. So if I wait for another 1 or 2 minutes, it should now start to spin up. So let's wait for that to happen. Top pod. Here you could see the calculator app was actually spinning up, and the memory consumption, sorry, the CPU consumption is going high. And earlier we said if the utilization goes beyond 10%, we wanted the autopod horizontal pod autoscaler to spin up additional pods, and that is now working. Now here we should see new nodes to be now coming up, and like I said, it would take some while. But as we have almost reached the time, I'd like to thank you and try the source code. Probably do not miss the same thing that I did. Don't miss out changing the IP address to create the load. To simulate and try this yourself, and check the source code on GitHub. And happy horizontal pod autoscaling with AKS. And if you have any comments, please feel free to share that on the comment section. Thank you so much. And the closing note would have started on track 1. Please join that, and that's the last session of the day. Thank you so much. And you would see the feedback form right on the chat. And please feel free to submit the feedback. and you would stand a chance to qualify for awesome giveaways from AZ Conference. Thank you so much.